Welcome to this Python tutorial where we create a stock trading bot. Now what this means is we are going to actually grab some data from an API service, or actually a couple of them, and then bring them into our own time series database. This is a Postgres time series database thanks to TimescaleDB. Yes, I partnered with them on this course, but the idea is once we have time series data, it's a lot easier to do all sorts of analytics as well as just ingest a lot of it. So once we actually grab the data, we are going to put it into a TimescaleDB using Django and the Django ORM. Now, a lot of this is going to happen inside of a Jupyter notebook to start out, so you can get all of this down and have it working in an interactive Python environment. Once we have it all working, then we're going to start automating this process using Celery workers. Now, if you've never used a Celery worker before, it works hand in hand with just Python. It also works hand in hand with Django and all of the Django things. We're going to integrate all of that and make sure that they're all working together. Yes, and you can still call Celery functions from inside of Jupyter notebooks. It's called a Celery task. But the idea here is we need a worker process that can run on a schedule outside of your normal Django project or outside of Jupyter altogether. Once we do all of those things, then we're going to start to analyze this data. We're going to get stock market indicators using built-in features that Django has in the Django ORM to actually make calls to our database and run database functions. That is doing all sorts of calculations with just a few commands on a standard Django query set using annotation and aggregations. We'll see exactly what I mean by that in the actual course itself because there's a lot to it. Now, I realize that some of these API services and some of these stock market indicators exist elsewhere, but knowing how to do the calculations with Django, I think is a huge advantage if you're going to start building out all sorts of things, whether it's stock market related or not. So once we actually do all that, we're going to go ahead and implement some logistical things, as in doing some logic based off of those stock market indicators, based off of that analysis. We're going to build in some logic to make a decision whether or not we should buy, sell, or hold any given stock. We're also going to use OpenAI's LLM, or large language model, to make those decisions for us as well, so we can kind of combine those things and make a decision whether or not we actually want to trade a stock of any kind. Now, all of this is meant as a technical tutorial, a how-to tutorial on making this stuff happen. It's not meant for financial advice. I have to say that for legal reasons, but the idea here is this is a step-by-step tutorial that's going to really get into the weeds of all of this. I'm super excited. Let's go ahead and take a look at a demo as to what we're going to be building. Let's take a look at the demo right now. This is the result of the entire course. You can actually grab all of the course code on cfe.sh/github and then just navigating into the stock trading bot course. That is going to be the actual repo that has everything you'll need to get this going. Now, I do have as much of the installations as possible on here. Of course, the course itself will take you through it. Now, the idea is inside of this Jupyter notebook, we're going to go ahead and set up Django, make sure that you can run Django and Jupyter in one place. Then we're going to go ahead and do a bunch of Django related imports, as well as other configuration imports we need. The very first thing that we want to do here is we want to actually create our company instance. Now, in this case, I actually have this company already created, but the idea is you want to create the company. After you create the company, you can do a historical stock data sync. Once you do that, you can do it for however long you want. This right here is the synchronous version, the non-Celery version. This version will always take longer than the Celery version itself, which you could always verify. Now, the point of this is because right now, all of this code is being run inside of the Jupyter notebook. If you pass it over into a Celery worker process, this is one of those key things there. If you were to look in the tasks, what ends up happening for this sync historical stock data is it actually creates a brand new task for each one of the quotes, each basically batch of the quotes themselves, which means that the worker process can distribute this a lot more efficiently. You can also scale up these workers really well or really straightforwardly in the way that you can actually do this even faster, which is really nice. Now, it didn't actually take that long for 1 year of stock data, which is actually pretty cool. But once we actually have that stock data, then we do a simple analysis. This analysis is based off of the data we just looked at and the ticker we've been using based off of some sort of range of data. So if you did like 30 days, it's going to change just slightly. All of this is done using Django. All of the stock indicators are using Django itself. So inside of any given model, in our case, we've got this stock quote model here. We have ways of actually building out all of these stock market indicators. Now, there is a lot to this, so we actually go through it pretty quickly in some cases and in more detail in others, because you're not going to always necessarily going to do this much analysis yourself. You might actually use a third-party API service for that, which of course we go into and talk about for sure. But the idea here is all of these indicators, all of this calculation happens really, really quickly. This is for two reasons. One, we are using TimescaleDB Cloud, so you can actually sign up for Timescale here, which of course will be linked below. That is going to be as fast as one can be with a Postgres time series database. This is actually really, really fast on that end, but also doing this kind of calculation on the database side is going to be faster anyway. We could do all of these calculations, and we do, using just Python and then transition into the database. That's another big part of this, is making sure that we understand how to move from just doing Python calculations to doing Django ones as well. Once we have these results, we just turn it into JSON data like this, just so it has the right data types and all of that, so that we can then pass it in as part of our prompt to an OpenAI request, which of course is exactly what we do right here. I go ahead and run this response, and what I get is these values right here: buy, sell, or hold. And in this case, it's saying to sell it based off of this reason. Now, we actually did a scoring part of this as well. So when we do these stock market indicators, this score right here is going to actually be that logical score where we could go based off of that to buy, sell, or hold. This score right here actually indicates something a little bit differently than what the other one did. So if we were to look into that score itself for the logic-based recommendation notebook, we can actually scroll down in here and we can see the different scores. So right now, my logic is saying, hey, hold it, but the actual LLM is saying, hey, sell it. And this is going to be different depending on what we're sending into the LLM, whereas that's going to be true also with the logic-based one. This is where you can actually make something on top of this to actually really build out a full-on automated training bot and really just store the historical data so you can really keep track of what happens over time. But this is a lot of things in a very short amount of time. That's the point of this demo. Now, we don't really have a front end here. We do play around with the admin a little bit in terms of Django itself, but overall, this is very model heavy because we are using so much data. Now, we also use these third-party API services to make all of this happen. Those things are not seen in the actual, notebook itself of called putting it all together, but it is happening under the hood. The two of them that I end up using or integrating are Alpha Vantage and Polygon. Both of these are great API services, and they work slightly different. So we actually create our own API clients for each one to use exactly what we need from those API services, so you get a better sense as to how to do this. Now, a big part of the reason I do something like this is so that I know exactly how the API works. It really helps me learn their API by creating my own API client, even if they have their own API client. This is a really easy way to really get some idea as to how all of this stuff is working. And of course, we go through it in a way that I think makes a whole lot of sense. Now, what you'll notice in the code itself is there are a lot of different notebooks in here. This is to help those of you who are new to using notebooks to really get, up to speed. But realistically, we jump in really quickly by building out different APIs and all of that, and really build out how we can extract that data. Because at the end of the day, all of the data that we want into our database, that's going to be the key part. Using those API integrations and being able to grab that data on a regular basis, that's the key. After you do all that, the analysis and the decisions are not exactly that easy, in the sense that the analysis can start to get really complicated. But once you actually have the data, the analysis gets a lot easier. So I think grabbing the data is far more important then analyzing it and making decisions on it. Although those things are important for sure, but those things are secondary in terms of the technical capabilities of the things that we need to do. Anyways, that's the demo. Let's go ahead and talk about the technical requirements you'll need, or some of the skills you'll need to be able to do well in this course. Let's talk about some of the technical requirements to do well in this course. First and foremost, knowing some things about Python. That is, doing math, being able to do variables, classes, some functions, string substitution, some of those fundamental things you'll definitely want to know. If you're not ready for that, check out my series on YouTube, which is at cfe.sh/YouTube, and look for the 30 Days of Python series. Now, this one covers Python 3.8, which is absolutely okay because Python 3 is Python 3, especially with what we're doing. Some imports might change here and there, but all of the code, like I mentioned in the demo, is all available for you on cfe.sh/GitHub, and you can find that in here as well. So if you're having any issues with imports or your Python version, just compare the code and make sure that it's working correctly with your version of Python. Worst case scenario, you download Python 3.12 or 3.13. I'll show you how to set up those things in the next part, and I even show you an in-depth guide as well that you can take a look at too. Now, once you actually do some of the fundamentals of Python, knowing how to use Jupyter is helpful because we are going to use this a lot. Knowing a little bit about Django is also helpful in the sense that if you've actually created a Django model before and did some fields and maybe some migrations, that will be very helpful for you. Once again, on my YouTube channel, I have some fundamentals with Django. These things, even if they're older versions, Django and Python are very mature tools, so even the older versions are still very relevant. One of the things I do recommend getting some experience with as well is Docker. This is going to be helpful for using our self-hosted versions of TimescaleDB and also Redis. Redis is important and required for Celery, where Timescale, of course, is required for all of the Django and data storage stuff that we're going to end up using. I'm going to be using the dumb version of Visual Studio Code. In other words, I will not have AI activated. So while that might be really helpful for you in your own local environment, I'm going to be doing it where it's not activated so you can see exactly what needs to be done inside of that. And also, you can use a lot of the Jupyter notebooks inside of Visual Studio Code if for whatever reason you don't like the Jupyter setup itself. Now, that's pretty much the fundamentals of what you'll need. One of the questions you might have is, do you need to know SQL or SQL of any kind? You really don't, because we're going to be using the Django ORM or the Django models to do all of the SQL things for you. Now, if you do know SQL, you could probably write some manual SQL yourself in conjunction with Django, or actually writing it in the Python code itself to execute that if you're on that more advanced realm. Now, learning SQL is definitely something that you might consider doing, of course. And then also signing up for Timescale Cloud is recommended as well, because that's going to give you a lot more power when it comes to storing our data and also the speed, and also not worrying about overdoing it on your local system and all that. So feel free to use this link to sign up there, and thank Timescale for putting this course together with me because they did sponsor it, which is super cool. Now, we're also going to be using Polygon and Alpha Vantage. Both of these things are fairly optional in the sense that you don't have to use either one, but using both of them, because there are free API keys, will help us with our data. And then we're going to use OpenAI just very briefly towards the end for the LLM stuff, like you may have seen in the demo. So that's really it for the requirements. Of course, if you have any questions on this in terms of your skill set, please let me know. But overall, I try to give you each step of the way so it's not really that challenging in terms of even if you are a beginner. If you're a little bit more advanced, you might just put this on double speed and actually go through the repo itself, which is actually what I would recommend you do. Go in the repo and see what parts you don't understand. And then if there are parts that you don't understand, just go through the commits, and then you'll know exactly which video you need to watch based off of what happens at that particular time. Like batch and bulk loading stock quotes, for example. How do you actually go about doing that? You can always watch just that section, which of course, if you're on YouTube, will be linked in chapters. If you're on my website at cfe.sh, they will be individual videos that you can go through. So if you have any questions at this point, let me know. Otherwise, let's start setting up our Python environment right now. Let's go ahead and set up our Python environment from the Git repo, and more specifically from the start branch. The only reason for this is to have the compose.yaml file as well as the env sample there, and then maybe even the links to some of the things that you might end up using, like the in-depth tutorial setup for this actual process on YouTube. I'm going to go through this fairly quickly. So the idea is I'm going to open up VS Code. I'm going to go ahead and open up a new folder, which I called Stock Trading Bot, and then I just go ahead and clone the repo itself, and then I just do a quick git checkout start, so we all have the same code. At this point, what I would recommend that you do is you remove the git repo itself, and then do something like git init to actually make it your own repo. In my case, it's already my repo, and now I'm going to go ahead and work off of the main branch, and you also might have it on main or master. Either one, it doesn't really matter. At this point, I want to just go ahead and verify which version of Python I have. Of course, I also have Python 3.13 on there as well, which I'm actually not going to be using. But let's go ahead and create our Python virtual environment with venv and venv, just like that. And then we'll go ahead and activate it. And then I'll go ahead and do my installations. First off, I'll install pip and upgrade it. Then I'll go ahead and install and upgrade to my requirements.txt. And we'll do pip install-r requirements.txt. Now, in many cases, I actually might say, oh, let's go ahead and create the Django project. While those things are happening, I'm going to go ahead and make a new folder in here called src. And I'm also going to make a new folder in here called MBS, as in notebooks. So for Jupyter, we're going to start with doing a bunch of notebooks so we can really grab the data. Now, a big part of this is I'm using the DAD method of getting the stock trading bot going, which of course means just simply, get the data, and then let's see here. We extract the data, we analyze it, and we decide, thus the DAD method. So that's what we're going to be doing here. So we want to start with the data itself, extracting the data and then storing it. So with this in mind, I'm going to go ahead and just make sure that the Jupyter notebooks are working by just running the command Jupyter notebook. You're going to want to keep this command in mind when you actually go to run it. If for some reason localhost is not working, in my case it's not, just go ahead and close that out and then just grab the one that has 127 to start it. That often works as well. So since I'm using the Arc browser, I'm just going to open it up in that, and we'll have that going in just a moment. Next up, inside of SRC here, I'll go ahead and create a new terminal window. We'll jump into SRC and we'll just do Django. Actually, we need to activate the virtual environment. So source and then ..venv bin/activate. And then I want to go ahead and do Django-admin start project and CFE home, period. I call all of my Django projects CFE home, mostly so I know exactly where settings.py is. Of course, if you call it something different, manage.py will have this Django settings module in here with a different project name. But I keep it the same, so no matter what repo you look at, you'll basically see that exact same thing. Unless, of course, it's like 5+ years old. But what we have now is some of our foundational code in place and our Python project set up. Now, if for some reason I need to come back to the Django project, I certainly will. At this point, that's the setup process. If you need a more in-depth look at this, that takes a lot longer, like 20 minutes or something like that, check out that tutorial on YouTube because it will go into a lot more of the details that I just skipped over at this point. Now, one of the things we will need to do at some point is use Docker Compose. I believe in that setup video, we actually start the Docker Compose stuff going up right away. That's not something I'm going to do yet because I really want to focus on extracting that data before I start using Django and storing that data locally, which I'll be using Docker Compose for that, at least initially. When it comes to getting stock market data for our applications, we really have two options. One would be to actually scrape somebody else's data, like scraping Yahoo Finance and grab the current market value of any given stock. In this case, of course, it's Apple, but the idea is we would actually go on a regular schedule or a regular interval to start actually scraping this data. Now, there's a big downside to this. Number one, we actually don't get any historical data this way. Of course, if you started scraping now, you could potentially get some historical data because you'll build it up over time. But the other thing is, the more big problem that we have is what if Yahoo Finance blocks our requests and starts blocking us from scraping their website? Now, that actually might not happen for a little bit of time, and it really depends on how much you are actually doing this. But the idea here is web scraping is not going to be incredibly reliable for this kind of data. Instead, what we want to use is an API service. I found two to be fairly reliable. One is Polygon.io, the other one is AlphaVantage.co. Both of these are fairly straightforward on how you actually use them, but the idea here is we need to decide, are we going to go web scraping or go API? I'm going to say we're going to go API, and that's what we're going to end up doing and setting up in the near future. Before we get there, though, we need to actually implement Python decouple and see how we can load in any given API key so that we can actually use it in a Jupyter notebook. So the way we're going to do this is we're going to create a .env file. This is very common for storing your API keys. I do have a .env.sample here that you can bring over. This sample is going to be really important for when we actually implement Django later. But for now, what I want to do is bring in two other keys in here, the Alpha Vantage API key and the Polygon API key. So both of these things are very easy to get, and we really just want to verify that we can load them in for this first part. So go ahead and jump into Polygon.io, sign up for a free account, and go into the dashboard, grab whatever your API key is here, and go ahead and paste it in. And that's going to be in the Polygon one. In Alpha Vantage, you'll go in there as well. You go to get a free key, and then you'll grab whatever that value ends up being. So in my case, if I did Team CFE and hello at Team CFE, something like that, that will give me this free API key. And so I can just go ahead and copy that and then bring it on over. Now, there are limits to these APIs, of course, because this data is really valuable. So if you want to be able to do a lot of things with it, you'll probably need to upgrade your account. Now, I'm going to try my best to keep all of the requests that we do underneath the daily limits. But yeah, there's only so much we can do in terms of free data, especially stock market data that could be really, really valuable. So at this time, what I want to do is I actually want to open up my Jupyter notebooks and just see how I can use the .env package to load up my notebooks here. So for some reason that is opening up another instance, and I see why. It's because I already have it running from that last part. So I'm going to go ahead and open up the one that I already have running. Great. So with this in mind, inside of NBS, I'm going to go ahead and just create a Python 3 notebook. And I'm just going to go ahead and say, hello world, load .env. That's it. So the way this works is we're going to go ahead and do from decouple. We're going to import config. And then the config command here will allow us to bring in our environment variables from the .env file here. So we do something like that, and I hit enter, and I get this key not found, right? So the reason this key is not found has to do with how these environment variables get loaded. So what I need to do is inside of my terminal, I need to close it out, open up a new terminal here, and then just run Jupyter and notebook again, hit enter, and then this of course opens up a new browser window for me. And I really want this one right here, which is basically just a new session. I might even be able to refresh in here and have it run. Looks like everything's still going okay in terms of the notebook itself, but I did a complete refresh and now I see that it's loading in that key. And then we also want to do this same process with our Polygon IO key. So I'm going to go ahead and bring that one in as well. Both of these things are going to work. So basically, I just want to say assert it is not none, and we can also bring in our config, adding in a default of none, and we also can cast it to a data type. So I'll definitely come back to why I really like using these things or using Python decouple again when we come into Django, but actually doing this assert command will make sure that we don't have any big errors with our environment variables or our API keys going forward. But now we want to actually see how to use these API keys with the different services. Now we're going to go ahead and do our first request into the Polygon API. So what I want to do is jump into Jupyter and I'm going to duplicate this hello world here, and let's go ahead and open it up. So now I've got this copy here. I'm going to duplicate these things all of the time, so I probably won't show it every time. But the idea now is I'm going to change this to 2, and we'll go ahead and say hello world, and we'll just call it Polygon. something like that. And there we go. So we got the Polygon API key here. Right now, I don't need the Alpha Vantage one, so I'll go ahead and get rid of that. And of course, it's shift enter or shift return to actually run the different cells. Hopefully you knew that. But even if you didn't, there's a lot of different things that you can do inside of Jupyter. But the idea here is we want to have this Polygon API key. And of course, I'm just checking that it's not none. But of course, I can also come in here and now set it like this, right? So now I actually want to use this. Now, the way I'm going to use this is by jumping back into Polygon.io and then clicking on this quick start here. If you are logged in, you'll see that the dashboard is over here, but if you scroll down a little bit, you will actually see your API key is in here already. So I'm going to go ahead and copy this URL here. This, of course, is the API request. If I open it up in my web browser, I can actually see the data. Now, depending on what actual plugins you have on your browser, you might see it like this, or you might see it like this. But the idea is I can actually really quickly grab some of this data, which is pretty nice. That also means that I can copy this URL, go back into Python itself or Jupyter itself, and import something like Python requests, and then say something like the URL is equal to that. And then we can actually run R, or let's say response equals to request.get of that URL, run that. That actually takes about the same time as the browser. And then we can do something like response.json and see this data. Now, the reason I'm actually not going to go this method is because I actually have an API key I want to use. So I'm going to use just simple string substitution here and pass in that API key. And then I'm going to go ahead and run it again. Same thing. Now, the problem that you might face is running this too many times, because whatever plan you end up using, especially if you're using the free plan, you're going to hit the rate limits or the API request limits that you can have for your account. So do keep this in mind as you run these requests, which that is part of the reason I actually want to actually declare a variable called data and literally keep that JSON data in there. So then we work off of this. We're not doing the full request every single time. In other words, if I go to data and ticker, I can actually see what the ticker is in here from the data results itself, or better yet, I can actually take a look at the results in there. Now, these results might not mean anything to you just yet, which of course we'll look at in just a little bit too. But the thing is, we can now start to parse out this URL to being the data or the things we're looking for. So the first one is we see that there's this ticker here for Apple, or AAPL, which you could always verify this in a lot of different places of what any given company's ticker is. But I'm going to go ahead and say ticker equals to that value as a string, of course. And then we're going to go ahead and pass that in as an argument to this URL. So what we've got here is now another way to get results here. So I'm starting to actually build out my own API request that I might want to have. So what we see here is a date as well. Now, how do these dates actually work? Now, there's obviously ways that we can figure out how this works. One is going to be trial and error. One is by going back into the documentation and taking a look at some of the aggregates that they have in here. So the reason I know it's aggregates is because, well, it's the first thing that shows up. But also, if we look at the endpoint that they have here, you can actually compare it to the URL endpoint that we have, and we can see it says v2 ags ticker, right? Back in here, we see v2 ags ticker. Even if you have no idea what any of these things mean, you can actually start to see the format that's going on here. So I can go ahead and copy this now, and I can come in and say something like the path is equal to this itself. So I'm going to put it in as a string. So let's go ahead and come back and say path equals to that string. Oops, I have the wrong thing copied. Let's go back in here and just copy this. Once again, put it in as a string. And what do you know? So we now see that, hey, we've got all of this stuff in here. One of the things is the to date is this. And so we can really start parsing it out quite a bit. So we can change this path into being string substitution as well. Change this from stock ticker to just simply ticker. The multiplier, notice that we see that there's a multiplier in here that goes from range to time span. So the multiplier, my sense is going to be these two things like this, right? 1 day, cool. Now we've got the multiplier. That's not it. That's going to be our time span. So multiplier is probably going to just be the day, so or the actual number that's in there, which also makes sense for the term. So the time span also makes sense. So day. So we're really close. We've got from And this is going to be, well, I'll go ahead and say the from date, not from because it's a reserved keyword in Python. So we'll go ahead and grab that value there. Notice that I don't need those trailing slashes, but I want to change that. And then we'll go ahead and do toDate and also use this right here. And there we go. So now we've got a new endpoint path here. And of course, we've got this API key, which I'll keep as for a moment, but I'll get rid of all of this, including the trailing slash, because it's going to match that path. So we can actually change this to being a path here. And now the URL should be the same as it was, or close to the same as it was, which we could just print out, and there we go. So there is a better way to do all of this, as of course, but I just want to show you the logic that I go through really quickly so you understand how the API is formulated. The request and the response is going to be the same. Now we can actually go back into the API itself, because we just modified this endpoint, and it even shows you if timespan equals to minute and multiplier equals to 5, then 5-minute bars will be returned. 5-minute bars, that doesn't mean a whole lot to me, so let's go ahead and see it in action, right? So the multiplier in this case is 1 day, but if I change it to, let's say, 5-minute, like it said, let's go ahead and see what the response ends up being. Now we end up getting a lot more data than we did before. It's quite literally every 5 minutes. Pretty cool. Now, I don't actually have really insight as to what these key value pairs are yet, which of course would mean that I just read through the documentation a little bit more and you can see what all of the attributes are. We definitely will be coming back to this. But the thing that Polygon has that I think is really nice is, yes, we have this ability to do this request directly from the URL, but Polygon also has a Python client. Now, you might actually go through the process of doing this Python client and using the REST commands that it has and all of the things that just make it a little bit easier. I'm actually not going to go that route. I'm only going to go the route of Python requests because that's what we'll use with Alpha Vantage as well. Python requests is going to basically do the same thing as their Python client, but we just have to understand all of the arguments and parameters that go into it, which I think is really important if you want to get into this realm of building out API requests and API-based applications, because you need to understand how to make these raw HTTP REST API requests, which is exactly what we did. We just broke it down right here. So all of these things itself should be documented. In some cases, they're not documented. In some cases, they're not documented very well. In the case of Polygon, I think it's actually very well documented. As you can see all of the arguments that are in here right down below for this as well. So these are those parameters that are coming through with that URL, which of course gives us this one right here. So this is actually slightly different than what we did. So if we actually come in and grab this one, we can say URL2 equals to this. And now we can see that there's a few other URL parameters in here, which I will absolutely take a look at on how we can improve that as well. But for now, we're just going to leave it as is and say, hey, we extracted our first level of data. Now let's go ahead and do our first API request with Alpha Vantage. In this case, I'm going to go ahead and make sure that I'm just using the Alpha Vantage API key. And of course, I duplicated the notebook and made all of this happen. So the idea here is making sure that all of this works and there's no issues whatsoever. Next up, of course, you already should have your API key. If you don't, go ahead and grab a free one. Now, in my case, when I was testing this out, I tried a bunch of different emails and those all worked for the free one. But there are limits to it. It's like 25 a day. It's not actually that many requests per day, but it will give you enough to be able to build this whole system. So the idea then is jumping into the documentation, which will end up looking like this. Now, the nice thing about Alpha Vantage, if you scroll down at this point, there are language-specific guides that actually have all of the Python request stuff that's in here. So go ahead and copy that and just bring it into your hello world. Here we are. Nothing is that drastic here. What we've got is a number of arguments. These are URL arguments that are coming in, or URL parameters that are coming in that need to change. So the terminology behind how you use URLs is maybe something you'll have to get used to. Perhaps you know that these are called URL get parameters. Perhaps you do not. The point here is you should be able to look at them and be like, okay, this says function equals, and then this is an ampersand as in and symbol equals, and this says IBM. If I wanted to change that, hopefully you have some intuition of how. The important part is I'm going to show you how to change the API key one based off of our API key. So let's go ahead and do this and make it very Pythonic by saying API underscore key equals to, well, of course, it's going to be equals to our Alpha Vantage API key. Right away, I can do the F string substitution here and bring this in just like that. Now, another thing you could do, and we probably could have done it before, is use .format in a very similar way. You can actually use format equals to and then actually replacing that as well. So you'll see this with older versions of Python, but in the case of URL parameters, this might actually be kind of nice because then you can do your keyword arguments in here, or you could just say your params, and you can actually make it into a dictionary and then say the API key is just like this, and then you can actually come in and unpack those values, which gives us all the same thing. So I just did the same thing a few different times for that string substitution. In the long run, we're going to do something very similar to this, but we're going to make it even better. But for now, we're just going to leave it as is, and I'm going to go ahead and change one other thing, which is going to be our ticker, which in this case, it says symbol, but I'm going to change the ticker back to Apple again, and we'll leave it like that. This right here, I'll go ahead and say ticker like that. With this unpacking as parameters or as a dictionary will, that will set everything equals to. So params makes it API key equals and ticker equals and all that. That's what those two stars end up doing. Of course, I hope you're already aware of that, but if you're not, now you are. Okay, so if I run this, I now can see here is the data. So if I don't print it out, the nice thing about Jupyter is it actually formats it for me. If I just run the cell with that data, it formats it for me. Now, what you should notice is this is quite a bit different data than what we have seen before. Polygon had a much different response here. And so one of the other things that we see here is with this interval that we've got of 5 minutes, we can actually look at the results of our data here. So we've got this date here and it's showing this data, and then it's going to go through every 5 minutes, actually going backwards every 5 minutes, and we can see that the time is ticking down. Now, what if we wanted to change that interval? Well, of course, this means we go back into the API documentation for the time series intraday, the one we've been doing. You can see that these are the interval options here. Notice that there's not one for a day. This is because it's intraday. That's quite literally the function name is intraday. If you wanted daily, you can actually see that changes the function name. You can get then daily values, which of course you can test and play around with by jumping in and changing the function to time series data, which means that in these parameters, then we might want to change it so it's a little bit more keyword arguments, especially in this one because of how this ends up shaking out. So if we change this now to that argument or that key, we now got this function here. And then if I run this now, what I should see is quite literally just daily values. And that's exactly what's happening here. It's now ticking down per day. The other version was ticking down per day as well, but it was ticking down per day in 5-minute increments also, which is fascinating. So the reason that we're seeing it in the way we are is because we've got months. We had actually a times, like actual values for how many days it goes through. So it did an entire month of it. We can and should change the arguments as to how many days that we might want to get. Like what we've got here is 5 minutes, and we've got this month here and all that. And what do you know? There's also a way to download and store CSV files or flat files for any given time period as well by just simply changing the data type too, which is pretty cool that that also exists here in Alpha Vantage, and once again informs us that maybe in the long run, that's how we're going to want to store some of our data. Great, so now we can actually pull this data. We need to start building out helper functions to actually use either API service or both of them. More than likely, we'll pick one and just stick with that. But the idea here is we have to start building out functionality to transform this data into a format that makes sense for what we want to use, because both API services have different formats for basically the same data. So we want to make sure that we are accounting for that. Duplicating the Hello World Polygon notebook, we have the transform Polygon response, which is basically the exact same stuff, but the idea is we have one single result we're going to hone in on. If you look at this result, your intuition might be like, well, I have no idea what's going on here because the keys don't actually explain that much. Now, there's certainly possible, even if the keys were more verbose, like what we're about to do, you still won't necessarily know what they're doing, which is totally okay as well. But in our case, we actually want to transform this response so we can do it at any time for this data, but also any other API service we might end up using. Hey, what do you know? Alpha Vantage was another one that we were using. So what we want to do is we want to actually transform these API responses into being a little bit closer to the data we actually want to store in our database. Now, this also might mean we enrich it with other data sources. In this case, we are not going to enrich it with other data sources, but that is certainly something you could do in the future. But there is another thing that we actually do want to transform, and that's this block right here that is related to the Unix millisecond timestamp. So it's not exactly what the timestamp that we're looking for. This is a millisecond timestamp, which is something we will transform as well. Now, to get this started, what I want to do is I'm going to grab this dictionary here and paste it over. So the idea is I want to actually map it to being something a little bit different. So V, I already know what that is off of the top of my head, and you might already have a guess as well. We're just going to call it volume. And that's it. So V is volume. Once again, you can jump back into the API documentation and you will be able to see that the trading volume of the symbol at any given time period, right? And so what we could do is we could go through each one of these things and change it. So O being open price, C being close price, or something along those lines. And you can just go through and just build them all out. Or what we could do is I could actually just use that same result and come in here and do something along these lines, which is basically grabbing each key value pair and just remapping it to being something different. So if I take a look at this, I've got all of those different prices. They are the exact same. And of course, you could always verify that as well. Now, there is still one missing, which is the T here. But the first thing that I want to do is really just go through all of my results and make them look like this. Not surprising, all we need to do is define a function, and we'll call it transform the Polygon result. And it takes in a result as an argument here, and then it just returns back this dictionary as the primary feature of this particular function. Not that big of a deal, of course. So now if we run this and transform an individual result, we will be able to see exactly what it is that we're looking for. Great. Now it's transformed. Now, there's a lot of different ways on how you could do this exact same thing. You can use the Django REST framework. You can use Pydantic. You can use a lot of other serializers that are out there that will deserialize things or serialize things for us. In this case, I'm just transforming the names just a little bit, but there is one more aspect of this that I want to change, which of course is that timestamp. So if we actually take a look at this, we've got our Unix timestamp, and that of course is going to be result.getT, and we can actually take a print statement of this one, and we can see what the value is, which of course is rather large. So we can actually bring in our datetime object. So I'll go ahead and do from datetime import the datetime object here. And what I could try to do is I could try to run datetime from timestamp, and then just bring that result in just like that. If I were to run this, I get this error here. Year whatever is out of range. That's because the result is in milliseconds. So what we need to do with this timestamp is we need to divide it by 1,000. As soon as we do that, we now have a datetime object that we can now use for this. So what I want to do then is bring it into my return statement here. I'm going to bring it in as simply time. More on this later, but for now, we're going to leave it in as time. So I'm going to go ahead and run that as well. Now, one of the things you also might want to consider doing is ensuring that this is a specific time zone itself. So the way we're going to do this now is I'll go ahead and say underscore the timestamp, and this is going to be equal to this right here. Or we can actually call this one Unix timestamp and change this one to being our UTC timestamp. Bring that in. Basically the same thing. We want to make sure that our result is updated to that. Now we want to jump into our requirements.txt, add in pytz, which is the Python time zone. Go ahead and install that if you don't already have it installed. Then go ahead and import pytz. Come down in here, and then we want to end this from timestamp, we add in the argument of TZ, which is pytz dot time zone and UTC, just like that. And now we have the time zone info in there as well, just to make sure that when we bring this into Django, it is time zone aware. It is aware of the time zone itself. If we did not have that time zone on that datetime object, then when we insert it into Django, it will maybe raise an error or even have some other issues for us. So we just want to make sure that we had that time zone in here. Using UTC is the ideal. Now, a big part of the reason is because the data source itself is coming in as UTC. Django itself defaults to UTC, but as far as I know, UTC also doesn't have anything with daylight savings time. Now, for those of you who actually have it, then you understand what a pain it is. UTC doesn't have that problem. Okay, so now that we've got this, we are ready to transform this same sort of process, but now with Alpha Vantage, with the other one, but still with these same results. Like, this is the goal that we're going to. It might actually have data that's missing, which is okay, but overall, most of this data should be in there. Duplicating the notebook Hello World Alpha Vantage, we now have the Transform Alpha Vantage response notebook just like this. I still want the Polygon response one open as well because we still have this function and it shows the data fields or the keys that we want to transform it into. Now, the Alpha Vantage API data is slightly different. So if we take a look at this and we take a look at the data here, it's not structured in the same format at all. So the first thing that I want to do is look at data.keys and take a look at that. These are the values. We've got metadata and then time series based off of the actual time series value that's coming through in here. So what I want to do is actually want to get rid of the metadata one and then only use the one that's left. The reason for that has to do with if we change the interval, if we change it to 1 minute and take a look at that, that also has metadata, but it also has a different key value for that time series. Now, there's more complicated logic that we could have in there, but the point here is we want to list this out. We turn these data.keys into a list. Then we're going to go ahead and get our data set, is what I'll call it. And this is basically going to be our data set key, which is going to be this list, and it's going to be the first element in that list, right? So if we come in here, data set key, another thing that we could consider doing is just go ahead and say X for X in this list, and then basically something along the lines of if not X equaling to metadata, and we'll go ahead and do X dot lower, something along those lines. Now it's showing us that there's only one value left, and we can go ahead and put 0. There we go. Of course, we could always hard code the data key as well, or the data set key as well, but I want to leave it just like that. Next up is going to be our actual results. So this is now going to be the API request with that data set key, and now we can actually take a look at any given result in here. And so when we see these results, it's a little bit challenging to understand what's going on here as well, unless, of course, you look at the keys and you can tell this is a timestamp, and then at that timestamp, there are values that are associated to it. So that's actually not really that complicated. It actually makes a whole lot of sense in terms of how it's structured. So if we actually take a look at these keys, we can do results.keys. Here's all of the timestamps in this actual request, whatever the endpoint ends up being. So that means I can actually go off of each one of them. So the very first timestamp, I could always loop through all of these. So for example, I can do for timestamp and string in the results.keys. I should be able to print out the timestamp string. I might have to return or change the keys into being something different, but what we see here now is now a list of all of these different timestamps. And then of course, if we actually wanted to get the value for one of these timestamps, we would go based off of the results dictionary. Remember, this is the dictionary value itself. We would then do something like results.get for that timestamp string, and then we'll be able to see all of this data in here, and it's starting to get along the lines of what we want. Now, before I actually go through that iteration process, that's something we'll probably have to come back to, almost certainly will. What I want to do is I want to grab the very first result in here. So all that means is I'm going to do my timestamp str, And this is going to be equal to the list of the results.keys, and then that first element there, just like that. And let's go ahead and get rid of this extra bracket here. And then let's go ahead and make sure our list is closed off correctly. And there we go. So now I've got that timestamp string. So to get the results, then we just do that same sort of thing that I did with the iteration. And now we've got our results. Great. So all we need to do is take these values and turn them into a transforming function of some kind. Now, it's actually not going to be too dissimilar to this print statement here. Instead of being a print statement, it would return back a dictionary of some kind. Now, there's the way I'm going to do it is by going back into the transform Polygon response and quite literally copy that entire thing in here and then paste it in. This, of course, is no longer transform Polygon, but rather transform Alpha Vantage result, right? And that's what it is that we're going to be building off of. Now, just like before, I'm going to go ahead and ignore the timestamp for a moment, but now I've got all of this other data in here. So the actual result value, I'll go ahead and say result value like that. We can now see it's just a variable, and I want to just pass this in to my new function here that we just created. Naturally, we get a bunch of key errors in here because the new key values are, well, quite a bit more verbose. So in the case of Polygon, they weren't very verbose. In the case of Alpha Vantage, they are very verbose, which makes it a little bit easier to map to everything. So I'm going to go ahead and do one open. There's my result. Close price. We are going to go ahead and grab that one. And then we can just go little by little on each one of these things just to have it all working. And what we'll eventually find is something like our, let's grab our low price. I'll still put that one in. We've got our close price in here. I think I already got that one. Number of trades. There's nothing in here that says number of trades. So I'll go ahead and say none. We do have a volume in here. So I'll go ahead and bring that one in. And then we also do not have a volume weighted average. So I'm going to go ahead and say none. Now, my intuition, not knowing that much about the stock market, is these two keys or these two values are probably not that important to ingest, which might mean that I don't necessarily need them on Polygon. My intuition is that if a API service like Alpha Vantage does not have those things, perhaps we just don't need them altogether. But that, of course, is going to be up to you. And at the point, one of the points of doing this is to make sure that we can, well, change the data that we're getting at any given time, and hopefully fairly straightforward. So now with this change and this update, now it's looking a little bit better, but we still have an issue with these data types. So if you notice, they are strings. When we looked at the Polygon responses, they were not strings. They were actually decimal places. So we still want to actually do that. So I'm going to go ahead and do from decimal. We're going to import the decimal class here. And we'll go ahead and do this like that. Okay, and then I'll go ahead and bring this in. Now, one of the things about whenever you call decimal, you might run into issues with the number of decimals you'll need. So there is something called a quantize, built-in quantize function that you could use on the decimal to make sure that it gets stuck to whatever number of digits that are in here. So in our case, we don't need to do .quantize in here whatsoever, which would mean something like 0.001 along those lines. That should give us the same result. But again, I'm not actually going to do that, so feel free to look that up if you have any issues with the 4 digits. But what we have by default is we're turning in the original string into decimal values. The volume itself is always going to be an integer, so we can just go ahead and declare it as an integer. And there we go. So now we have our transformed data, but we're still not quite all the way there. So what I want to do then is go back up to our time string here, and I want to actually add a couple things about this. First off, this timestamp string has a specific format. That format follows a pretty standard format for strings or for date time objects. That is doing something like %y dash and then %m dash %d. That actually follows this portion right here. Those dashes in there correspond to the dash. The %y corresponds to the actual, year, month, or day. And then we've got the next one is going to be our hours, minutes, and seconds, which I can just go ahead and copy and paste here. Like I said, this is very common. And there's a package, I think it's called something like date utils. in Python or calendar. There's a lot of different packages that make it really easy to parse these things and turn them into a date time object, which is what we're doing right here. The next thing is we want to actually acknowledge this timestamp itself. Now, I don't remember where I saw this, but I definitely did some research on this, and the actual timestamp itself is going to be based off of the US Eastern. In other words, it's going to be based off of the stock market time itself, which you can maybe guess by just looking at this. When it comes to UTC, that's what like London time is. We want to make sure that we update this timestamp to UTC, not just because it's a format that's very, very common, but also because the format of our other API requests, as well as our other API data, as well as our database, as well as TimescaleDB, all of these things really benefit from using UTC. So we're going to go ahead and change this into UTC, which means that we want to start off with the Eastern time zone, which is going to be pytz dot time zone and US/Eastern. And we just want to verify that that is a value, so we can come in and do that. Sure enough, it is. Great. Next up, what we want to do is our UTC one, which you might have the intuition to just grab this and go, instead of that, saying UTC, which is technically correct, but there's also a shortcut to that, which is just simply pytz.utc. And so now we've got the timestamp string that we want to convert. We have the format it's in. We have Eastern Standard Time and also UTC. So now we've got our timestamp coming in here, which is going to be the Eastern value dot localize, then grabbing the date time object, which means we need to import that. I don't actually see where I imported pytz. There it is right there. So we did already import the date time object. So we'll go ahead and bring that in. And then we'll do strptime, which is going to go ahead and grab the string itself and then the format that we have it in, which this will give us that data. So we can actually take a look at the timestamp now. This is now in Eastern, but again, I want to have it as UTC, so I can just do as time zone and then pass it in as UTC. There we go. So that is the UTC value of this date here. So it's quite literally the next day on UTC, which is totally okay. When we go to display this data, we can absolutely readjust it once again if we need to. So this is exactly what it is that we're trying to do with this format. So this also means that I'm actually going to copy this part of it and come back down here and paste it in just like that. The next part, the actual timestamp string itself, will come in as part of the function. So then when we actually go back into doing our UTC timestamp, we will go ahead and do something along those lines, which means that down here, this is where we actually need to call that string itself, just like that. And so this actually matches a little bit more with what we were doing with this print statement here, which we could even verify in just a moment as well. But there's all of that data with that UTC. So if we actually just went through and ran through all of the results in here now, we should see that exact same stuff with, instead of the print statement being that, we'll go ahead and say our new data equals to that. We can print out that new data, and this should give us all of the data items in here, and I don't have any errors. There's certainly a chance that there could have been errors with this data, but at this point, I think we're in a really good shape in terms of transforming these two different API responses in here. So transforming is very common inside of data sets, whether it's coming from an API directly, whether it's coming from your database, whatever it might be. Whenever you start working with data sets, you're going to have to transform some data most likely to be in a format that you actually want to start using. So very soon we're going to actually take this data, this format, this schema, and we're going to build out our Django model to make sure that it's all working. Before I do that, what I'm going to go over is a simple way to put all of this together. Basically put both of the different APIs in a simple command that we can just call so we don't actually run through a notebook every single time. When it comes to using third-party data, it makes a whole lot of sense to transform that data so it's consistent in our database. What also makes a whole lot of sense is to have consistent ways of getting that data or extracting it from that API service. So for that reason, we're going to start building out the Polygon API client. Now, don't get me wrong, I know that they have their own API client already for Python, and what we're doing is actually not going to be a whole lot different than what we've already done. In fact, we're going to basically do the exact same thing. We're just going to put it in a way that's really reusable all across the board. So the idea then is we want to be able to create a client such that if we need to switch it out with a third-party service, we can just create a client for that third-party service and then just change the imports, as we'll see very, very soon. So the first thing that we want to do here is we want to actually duplicate our previous notebook on the transforming Polygon response and creating this Polygon API client class or function and notebook that we'll do right now. So what we've got here is these arguments right here. As soon as you see arguments like this, you can know that you can use something inside of Python called data classes. So if we do from data classes, import the data class decorator and use the data class decorator, we can then define a new class here called the Polygon API client, something like that. And then we can actually pass in all of these arguments in here just like this. And then we also might want to have other ones like maybe our API key and pass that in as well. I'm going to leave it as an empty string for the moment. Now do keep in mind this URL right here is sort of being generated for us. So in other words, it's actually based off of other parameters inside of this now class. But before I actually do that, I want to go ahead and run some of these cells here, and we want to just take a look at what this client ends up doing for us. So if I actually go ahead and create a new cell right underneath the client, I can initialize it and do something like .url. As of now, this actually does fill out everything as we would need. So that's actually kind of nice, but that's not how I want to use the client. Instead, what I want to do is define a class called generateURL and have it come in with the self object here. And what this is going to do is basically give us back these two things right here. So we just bring that in like that. And now with using generateURL, since it's on a class, and this of course is how Python classes work, we can reference these arguments here as just doing self dot all across the board like this. So we can actually see and formulate a little bit better of a URL. So now when we do something like this, what we want to do is obviously return back the URL itself. We run this, and now we'll go ahead and say something along the lines of generate URL. And now what we see is the exact same data, but now this is a function that we would end up calling, of course. So the important part about this is now if we want to bring in a different ticker in here, which I think like let's just do it. Goog I think is one that we could use. We can see now that it says, init got an unexpected argument for that value in here for the ticker itself. So let's modify our API class a little bit and put in a data type here and now run it. Now it actually works. So with these data classes, we need to bring in different data types in here. So the multiplier, is it actually a string or an integer? I think it's always going to be an integer. So the default value we actually want to leave as an integer. So we come in here and now we can do the multiplier being 1, right? So we come in there and there we go. So now we've got every 1 minute and we can keep going down this route. And I'm going to leave the dates in here as simply strings, the time span as well as strings, and then the API key itself as strings also. So now we're getting closer to what we want with our API client. Now, the next part of this, though, is we're going to define something called get headers, and it's going to take in self, and it's going to return very specific headers. If we actually go back into the Polygon API documentation, you can actually see there is a call for headers. You can actually pass in headers instead of passing in the API key, which is exactly what we want to do. The reason for this is because then we can inspect these URLs without accidentally exposing our API key. That's one of the reasons for it. So like I did right here, I actually exposed this API key. We don't want that at all. Instead, what we want to do is use different headers. So the way this is going to work, of course, is going back in and we can just copy what headers they have right now and we'll bring them in to this in here and we can just put them in as a dictionary, which is just simply key value pairs in here. And then we just reference the something like this. We'll go ahead and do self.API key. So there we go. So that's one way on how we can do it. We could also bring the API key as an argument in here. So basically then I would say the API key equals to self.API key, or the Polygon API key in here, and in which case it can actually use either one of those values, the argument that's being passed, or it can use the one that's in our environment variables. So we kind of have a little bit more flexibility with grabbing that data. So now we've got our headers, we've got to generate the URL, and then finally we're going to go ahead and do something like perform request. And this will now grab both of those things. So grab headers, and then we just do self.getHeaders like that. And then the URL, the actual endpoint we're going to use is self.generateURL. And then finally, we can actually run the request or the response here. We'll go ahead and say response equals to requests.get. The URL headers equals to headers. And then we can go ahead and return back the response.json, something along those lines. Great. So this is now our API client. It's going to be exactly what we did down here, right? So this is performing our request. We could also think of this as something like fetch data. That's the raw data itself. And then we can also have something that would transform it. So let's actually just take a look at getting the raw data itself in here. So I'm going to go ahead and create this client, run it, and then we see there's that raw data, and it's actually coming back based off of the arguments that are coming in here. And we can also change the dates, of course, which is something we will do at some point. Right now, this works just fine. What if we were to change it to 2024 in here as the default, and we run through? Once again, it's going to give us different data, which we could always validate as well. So the next thing is we've got this fetch data in here. What we want to do is we want to go ahead and say something like we want to get our transformed data, right? Or transformed request. Or we can just go ahead and say something like get stock data, right? Which is going to go ahead and grab our data, which is self.fetch data. And there we go. And then we want our results, which in our case is going to be equal to data and results. And then finally, we want to actually run through and transform that data. So this data right here, I'm going to go ahead and bring up on the client. I'm not actually going to put this directly on the client itself. If I ever need to change how I transform the responses, that's exactly why. So now we're going to go ahead and transform each one of those results because these are individual items. As you see, it's just one single result here. So now what we want to do is we'll say our data set is equal to an empty list for result in results. Then we'll go ahead and do dataset.append and then grabbing the result itself just like that, and then returning back the data set. And there we go. So now we can just go ahead and run those two things. And now we've got our new data. So all of this other stuff we can just now go ahead and delete. In here, we no longer need it. So let's go ahead and do that. Just delete this one and come all the way down and delete the rest. Great. So now the point of this is we can then in the future say something like our stock API client equals to grabbing this client here, and then our data set equals to, oops, little mistake there, our data set equals to that client, and then in the future, what we will hopefully be able to do is just change out this Polygon API client to grab that data set itself. Now, of course, we could always add additional arguments in here. In some cases, you might end up seeing that. So if we go back into the transform response here, we do see that there are some keyword arguments in here like adjusted and sort. So going back into our API client, we can then come in here and say something like adjusted equals to a Boolean value, which we will leave in as true, and then sort, which I think is a couple different values, which we will do as a string, and I'll just do ascending in here like that. Now, there are ways to improve the sort where it is using something called a literal. So we can bring in a typing here. Now, we need to use typing or type classes mostly so that we can declare a type. In this case, we're declaring a literal that will be the difference between two values here. So literally, it would be ascending or descending, which I think is how they did it. And we just set a default value in here as ascending. So that just is a way to declare these data types and make sure that they're working correctly. So now we've got adjusted and sort. So what I want to do is define get params, and that's going to be getting this data. So that's going to return back those two values in there. So the parameter value is going to be adjusted, And let's go ahead and make sure we do that. And it's self.adjusted. And then we are going to go ahead and grab the sort, which is self.sort. And again, we can actually grab these keyword arguments that you might find on their actual documentation. You would just have to go through it and find out which arguments that are in there, which ones are possible, which ones you can do. Here's those parameters. We've got some of them in here with the data itself. But of course, you would just want to unpack it like I did off the video. But the idea here is these parameters here we can now bring in to our request and do params equals to self.get params. And of course, I have some defaults in here. What I want to do though is with these parameters, I want to change them a little bit. And the way I'm going to do that is by importing something called the urllib.parse URL encode, because I want to encode these parameters in here. So what that means is that we'll go ahead and say encoded params equals to URL encode of these parameters here. And then we'll go ahead and actually bring in our URL equals to the URL with those encoded parameters, which means that we just do something along these lines, put the quote in there, and there we go. So that modifies this just slightly, and it will still give us out the same sort of data, but now our actual URL itself, which we can verify with .generate URL, has this data in here, which we want to get rid of that API key. So let's go ahead and get rid of that one and try that again. And let's go ahead and make sure that we are getting the correct data here. It's still giving us the previous one because we are not initializing it. So let's go ahead and initialize it. And there we go. So now we've got that data, that URL coming in here. So it's not exactly giving us the parameters correctly. So what I want to do is bring that into the generated params, and we'll bring it up just like that. And there we go. So this now gives us the parameters inside of the URL itself, which I believe is how they have it sorted anyway. There's a way to put in parameters into Python requests, but once again, I can now inspect this URL just to make sure it is correct, right? And I could also do something like in here where it's like pass auth being false, and we can say if pass auth, then I want to go ahead and add in URL plus equals to the and what was it, API key equals to the actual API key, which will be the value that I need to pass in here and now, which we've got up here, which I'll do the same thing, and then we'll pass that in. Now, once again, this is another one where we can do define get API key and pass that in, where it returns back these values as well. So that might be a little bit better so that we can diagnose and see what problems might be coming through with any use of the API key. But of course, I wouldn't do that until I actually were to expand my API client here a little bit. And so the reason I did this pass auth here is so that now I can generate this URL with pass auth and say something like true. And now I got that where I can then open this up on the actual URL and see if I'm doing things correctly. In this case, it actually says that the API key was not included, even though it's right there, which is pretty interesting. So maybe there's some other things that I would need to improve there. That's actually not something I'm going to worry about on this one. You could always diagnose it yourself. The point of this, though, is to have a way to diagnose problems with any given generated URL and, going back and forth on that. Then you can always use the previous notebook to grab the different results based off of that URL and the things that are coming through. Now, one of the things with this fetch data here, one of the values you might want to have is if there is a failed request, you might want to do something like raise for status, as in if it's not 200 or 201, a successful status, then it will raise some errors in there. But there we go. So now we have the Polygon API client. I'm actually not going to go in much detail for the Alpha Vantage one like we did here because we've already established a number of things about this API client that we're just going to go ahead and borrow and modify from that are based off of the actual response and everything we did in that notebook. Now we're going to create the Alpha Vantage API client, which of course is going to be based off of the one we just did. So let's go ahead and open up that one and we'll just go ahead and copy it. So the entire thing, this entire block, we want to go ahead and bring in to the Alpha Vantage one now and just change the name to being the Alpha Vantage API client. The transform result is not going to be this one anymore. It's going to be the one we created before, which of course is going to be this transform Alpha Vantage result right here, this function. We want to bring it directly into this little cell block here, just like that. Okay, great. And so the first thing is updating our API key, so it's a little bit different. It's going to be the Polygon one, or not the Polygon one anymore, but the Alpha Vantage one now. And now we can go ahead and bring this into this function. First things first, we're in good shape. Next up is going to be if we need to get headers or not. I'm going to start off with saying not. The parameters, in fact, in this case, most of the time it's going to be URL parameters, as we see right here. The base URL is, well, just query, and then we have this function and all of these other arguments in here. So that's absolutely what we want to update, which is very similar to what we were starting to do here, but I want to go ahead and bring this on up into my Alpha Vantage API so we know what parameters to bring in. First off, the API key is going to be a parameter. It's a URL parameter that's definitely coming through. So we're going to go ahead and bring that in to the parameters now instead of the headers. And this is yet another reason to have a function called getAPIKey right there. So we have them in the parameters. Next is going to be the ticker symbol itself, which is going to be just simply self.ticker, like that. Okay. Next up is going to be our function. So not a multiplier, but rather a function. There's a few different functions in here. So I'm going to use this sort literal here, and I'm only going to go ahead and put the ones that I need. I'm going to get rid of some of the other arguments that are in here. So we'll go ahead and do our function. And for right now, I'm just going to do the time series one and only leave that as the only option. Of course, if we look at the API documentation, there are other ones. There's daily adjusted, but I'm just going to stick with that one single one, knowing that that's the main function, but keeping my client with this literal here, knowing that there are other options. It kind of gives me a note for the future if I want to use different functions for this API. Great. Next up is going to be our next URL part. So let's go ahead and take a look. We've got our function, we've got our symbol. We also have an interval in here. So our interval, I'm going to go ahead and bring that one in as well and just paste it in up here. And we've got 1 minute. So this one, I actually know there's another option for multiple values in here. So once again, I'm going to go ahead and say literal, and I'm going to leave it in as 1 minute. And I think the other option in here would be, I think something like 5 minutes or something like that. So you have other options that we want to verify in the documentation. So these are those options. So at this point, I'm actually going to bring all of those in because these ones I might actually switch through going forward, right? So that's them right there. So let's go ahead and just paste them in here and just put double quotes around them. So 1 minute, and there we go. Great. So there's our interval and our function. So the interval now needs to go into these parameters again. So interval and self.interval. And if we scroll down again, we've got our URL, we've got our API key, we've got everything that we really want in terms of the URL parameters that are in here. So there we go. Next up is going to be our URL and our path. So in this case, it's just one thing. I could keep in my base URL because perhaps that changes. So I'll go ahead and bring that in and we'll leave it in like that. And then I'll also bring in my path, which is just simply /query. So if you're well aware of Python, you know that all of these things can be optimized, and even the URL and the path itself, maybe those are arguments that come in here. So one of the things that I know though with the Alpha Vantage API client that I'm creating, I probably don't need any of those arguments any longer now that I've got my URL and my paths that are going through here. Notice that basically everything else so far has been the same. The final one is this get stock data one that we really need to update, which if I scroll in here, I've got, well, a few other things I need to be aware of when it comes to this data. The very first one is going to be our dataset key, which value that's going to be. If you remember back when we were doing it, we actually had a metadata key in there as well as the other value, whatever that might be. Now, in our case, what we could do also is think about how this is being named. It looks like it's being named time series with the interval in there, right? That is possible, but I'm going to go ahead and stick with our dataset key being like this. And so our data is coming through. There's our dataset key. Next up is grabbing our results based off of that key. So basically now just implementing what we did with our iteration through the notebook itself. right? So we've got our data set key. Now I've got my timestamp string. Let's go ahead and bring that in there as well. There we go. And then next up, we want to go ahead and grab, this is actually grabbing maybe the wrong timestamp key. So I'm not going to necessarily do that one yet. But here we go. This is actually it right here. We are going to come back in. We've got our results already. We're going to iterate through everything. There's our new data. So once again, I can go ahead and say my data set is equal to an empty list. This new data here, I can go ahead and just do append. And I'm going to actually just bring in the entire function itself down and do something like that. And then the final thing is just returning back that data set. There we go. So I can go ahead and delete all these old ones. Of course, I still have them in that other notebook if for some reason anything fails. But now what I should be able to do is run the client itself and then do .get stock data like this. If everything was done correctly, we are in really good shape. So these parameters here I want to get rid of just in case I reference them somewhere. The function, the transform function, is still the same. I'm not going to change that at all. And then if I have any extra imports that I just didn't need to redo, I'll get rid of those as well. Okay, so now let's go ahead and restart this kernel here, and I'm going to go ahead and run it. Obviously, I have my Alpha Vantage API key that is already in there, so I want to actually move that one up as well. Don't really need to do it again, but I will. And here we go. So there's that class. Everything seems to be organized correctly. I run this, and now I get this does not have an attribute API key. So I accidentally deleted that one. So let's go ahead and bring it back in as a string, and we'll set it equal like that. And there we go. Python request is not installed or imported. So we'll go ahead and do that one. And now we've got string object has no result keys. Okay, great. So that's a interesting sign because we're getting the data coming back. So it should be returning back something other than this. So the results right now is saying that the string, the actual results are not coming back the way we maybe want. So let's go ahead and take a look at what those results are. So let's go ahead and take a look at the data here. And we've got an error message. The API key parameter is either missing or invalid. Great. So we've got API key as an underscore. Let's verify that that's actually what it is. My intuition is that's not what it is. It has no underscore. So even more important is to just go through, check the documentation, make sure we're doing things right. In this case, I'm just changing the parameter. I don't need to change the argument. I can leave the argument how I want to leave the argument, which is what I just did. And there we go. So the API function, the empty function does not exist. So what do we've got here? Our parameters is missing something. Function. What do you know? Let's go ahead and bring it back. Okay, and so there we go. Function and self.function. There we go. Run it again. Now we've got an invalid API call and for that data in here. So once again, we're getting some errors in here that we want to address, which is interesting that they call the raise for status is not actually working. It's giving us something back, but it's not giving us a status code in here. So maybe that will change in the near future, but let's go ahead and take a look at the URL itself. So let's go ahead and take a look at our generated URL to see what the issue is. So we've got our API key and our ticker, interval, and function, right? So all of these things look okay to me, but let's go ahead and just grab this data here. I'll even open it up, and we've got an invalid call. So let's go back into our documentation for it, and let's just compare what this one is. So I'll bring this in, and we'll bring it into our Polygon API, or rather our Alpha Vantage one, and we'll just take a look at the difference between these two URLs here. And there we go. So we've got our ticker. There's the problem. It says symbol, not ticker. Great. So now I'm going to change this one to being symbol. And let's see if that one works. Let's generate this data again. And there we go. There's our generated stock data. So it printed out the request itself. So it's not the correct print statement. We just run this again. Let's go ahead and run both of those things again. And there is our actual data with the correct values coming back. Great. So now what we can do at any time, we can use our Alpha Vantage API client, or we can use our Polygon API client. Both times we can use the same stuff. In other words, I will be able to do our stock, and we'll say stock client equals to the Alpha Vantage one, and then our data set equals to that client dot get stock client. And that's exactly what we're doing. That's a big part of the reason we have this. both of them, well, if we gave them the same exact variable names even, they are basically giving us out the same data. Now, how we actually put in arguments in here might need to be adjusted as well. At this point, I'm not going to adjust how we put those arguments in just yet. I will do it when I need to do it. The point of these two notebooks is just to flush those things out. This is definitely not the final API client that we would end up using. One of the things that's missing from the Alpha Vantage one, if we go back into the documentation, is the actual dates, right? So we've got a month in here, a month argument that's coming through. So going back into Alpha Vantage, we want to bring in the month, and that's going to be a string of some kind. Let's go ahead and do 2024-01 as in January of 2024. We can now pass this one in as that part of the actual API request itself, and hopefully that gives us a different data set. Looks like it does. Looks like we're getting these things back, and there's no errors. So going back in here, we can actually see exactly what's going on. In the case of Alpha Vantage, it's only bringing us back the month, right? Maybe there's a time frame that we can bring in, but it doesn't actually look like there is a time frame. It looks like it just gives us that whole month no matter what, which is totally fine. Our actual data can work with that. The Polygon one has a little bit more granularity. So to improve both of these API clients, what you would end up doing is trying your best to have the same arguments as well. I'm actually not going to worry about the exact same arguments. That is just too nitty gritty for what we're trying to do here. There's only two API clients. The result is what we're really after. We want to make sure that the transformed result is going to be in the exact same schema, regardless of which API client we're working with. How we call that API client is certainly going to be slightly different as well. But overall, we're in good shape. Now that we have a way to extract the data and transform it into a format that we wanted, we need to now have a way to actually load that data into a production grade time series database known as TimescaleDB. Now, the way we're going to load that data in is through a tool called Django. Now, traditionally speaking, Django is used for building web applications, but what it has is a very powerful ORM, or Object Relation Mapper. All that means is you can write some Python code and it gets turned into SQL that then can go into that production grade Postgres database that is TimescaleDB. So basically, we can take something very similar to these API clients that we created and write out just some Python code that will allow us to store this into that database and use Python to do so. This is going to be very straightforward, but the first process that we need to do is we need to open up this SRC here and actually copy manage.py. The way we do that is by holding down Option or Control if you're on Windows, or you can just do Command C or Control C and then Control V or Command V to paste it in. Now, the reason I have this manage.py here, the reason I brought this over has to do with some of the default things that are already built in, like this set environ thing right here. So I'm actually going to change this to being just simply setup.py. So the first thing that I want to do is get rid of some of the comments, of course, but also I want to go ahead and import pathlib. So I'm going to import pathlib, and then we're going to go ahead and say our mbs dir is equal to pathlib.path of this file and .resolve. And then that's going to be the actual file path. So I can say this file path is equal to this right here. This is going to be the absolute path on any machine, Mac, Linux, Windows. Then the notebook directory is the parent of this. And then our repo directory is going to be the parent of that. As in the parent of this file, the actual folder that it's in, and then the folder that one's in is the repo dir. Then our Django project dir is going to be that repo directory /src, this folder right here. So this is the Django root. We can think of this as the Django project dir, or we can think of this as the Django root dir. Now, in terms of Django itself, if you actually look into settings.py, however you named the Django project itself, you can actually see base dir. So that's often what I would end up calling it, is the Django base dir, just to keep it in mind of what Django is itself. So that's what we're going to be working off of. That's the location we're working off of. So that means then I want to run this command called init Django, and I want to come in here and say os.chdir, or change directory to that directory. So that's the root of the project that we're going to be working on, as you'll see in just a moment. Then we will actually want to do sys.path.insert 0 and the string of this Django base directory here. Then we have the OS environ stuff set up to CFE home. So my Django project name is, or what Django project settings name is CFE home. So you could put this in a bunch of different places. You could call this just simply like project name and do something like this, and then just put in some string substitution here for that project name if yours is not CFE home, which of course, if you're following along with me, yours is also CFE home. So those are the main ones. This next part I simply don't need, so I can get rid of those. I can get rid of the main call as well, but I do want to import Django after this. So I'll go ahead and import Django and then do Django.setup. Okay. So the reason we have all of this has to do with being able to use things related to Django, which we're going to verify in just a moment. But the idea is this is our command that we will use. So let's go ahead and jump into our Jupyter notebooks now. And all I want to do is create a new notebook, completely blank notebook now. And we'll call this 8-Django, setup, something like that. But not Jagno, but Django. There we go. So we're going to go ahead and import the setup Django module, or just simply setup.py. So we'll import setup, and then we'll call setup.init Django right here, which we need to call both of these things every single time. So if I were to run this, we've got this no file or no folder named this. So we've got something wrong with our various paths, and it has to do with this repo dir here. This should be based off of the notebooks dir, so we're going to go and save that. Then I'll go ahead and do the kernel, restart this kernel again, and then run that again. Now we've got this setup process going in. So I'll go ahead and do from django.conf. We're going to import settings, and now I'm going to just go ahead and run settings.base dir or something like that, just to make sure that this is correct. That's the actual location for our Django project. I can also do something like from django.contrib.auth. We're going to import our get user model here, and then I can actually declare that user model and do a query into a database that may or may not exist yet. But we'll do user.objects.all and see if that does anything. We get a problem here because we've got this synchronous only operation. So what that means is we actually don't have this Django allow unsafe in here. So that's something that I need to change. So if we look at this, I'm going to go ahead and grab this value right here. A big part of the reason I actually ran that error was so that we can come back into init Django in here and do os.environ and then set that value in here and set it equal to the string of true, which of course we want it to be lowercase true. So you could put .lower there or just leave it as lowercase. Now, if I go into restarting the kernel again, I can run all of this all over again. Now it'll actually allow me to run Django commands. This time it's giving me a different error, which is related to the database, no such table, which of course we will do very soon. But the point of this is to have the ability to use Jupyter and Django in one place. Now, there are third-party packages that do this, but this is too easy. Now you can just copy and paste this in any other future Django project that you might want to use, just to make sure that you're using the notebooks. And you just want to make sure that all of these paths are correct, because sometimes you have this MBS folder inside of SRC, in which case you would need to adjust the paths as you see fit. And of course, you could always make a more robust function to handle all the various different ways you might want to load Django in. The point of this is now Jupyter and Django are well integrated, so we can actually load some data into Django once we actually create the tables necessary. The stock market is a really good example of time series data. That is data that is going to change over time. Now, the other side of this would be not time series data. I would put a blog post in this category. So a blog post itself might have a timestamp associated to it, like when it was published or when it was last updated. That blog post does change over time in theory, but realistically, that blog post might change 5 times in a year, maybe even 100 times, and at the most 1,000 times in 1 year, one single blog post. That would be wild if it was even that often. But the thing is, if you think of time series data or like the stock market, it might change 5, 100, 100,000 times in a matter of seconds. So that's really the big difference between the two things. And so you need a system that's robust enough to be able to handle time series data. Now, Django itself is optimized for a lot of structured query language database technologies like Postgres, like MySQL, like MariaDB. Django can handle all of those things really well, but none of those databases I mentioned are optimized for time series out of the box. As they stand right now, they're not optimized that way. They are really well optimized for the blog post example because that's what a lot of that data was historically. So what we needed was a more modern and more optimized way to put time series data into some of those databases. So what we're going to be using here is we're going to be using TimescaleDB because it is an optimized version of Postgres. It's optimized for that time series data, which also allows it to ingest a lot of data. If you think about the stock market and how much that changes, we need to know about all of those changes in our database. So for that reason, we're going to be using the open sourced package of TimescaleDB. Now, yeah, I did partner with them on this series, but it's an incredibly practical use case to start to understand how to use time series data in your projects. The stock market happens to be a really good example for this. So you might be wondering, with that blog post, what would be an example of time series data around a blog post? To me, that's analytics. That's like viewership, actually being able to see the data, like what your viewers are coming to, your users. If they're reading that blog post, that is probably going to change over time. And that right there would be an example of time series data. And Timescale is well equipped to handle that. So the way we're going to go forward here is two ways. One, understand that Timescale itself is open source, so you can use it in a variety of places. You can install it on Postgres directly, or you can use something like Docker, which is where we're going to start. We're going to use a Docker container that Timescale actually manages themselves, so we can actually just use Timescale locally. Now, you could probably use it in production, but I don't always recommend using a container in production for critical database services almost ever. It's a lot of things to manage and a lot of things can go wrong if you don't really know what you're doing. Now, if you don't know Docker or you don't want to use it in the long run, you also might consider using the production grade version of Timescale, which is their Timescale Cloud, which we will go over as well. And of course, if you go to the timescale.com website or the links that I have in the description, you'll be able to go and grab and give me credit for all this stuff. But the idea here is however you end up using Timescale, understand that it is still Postgres, so it's still very well suited for Django. And we will also use this package of Django Timescale to make sure that it's even better used with Django, which is actually really easy. So if you've already done Django before, you can see just how simple it is. You just change the engine. You actually add just this single model, which would be the field here, or you could actually just implement the timescale model directly and just go based off of that. That's something we will be implementing for sure by using a hyper table, which are these time series tables that are optimized for that time series data, which we will see very, very soon. But the idea here is we want to go off of Docker. We want to use Docker locally so we can really build out our system before we actually start implementing the production version. I'm going to show you how to implement both of them because they're both very, very straightforward. But of course, if you don't have Docker on your local machine, you might just want to use the cloud version at this point. Now, I will also, at some point with Docker itself, I will also be using Redis. So some systems you can't install Redis directly, so you might have to use Docker there, or you're going to use a managed service as well, something maybe like upstash.com or something along those lines for the Redis portion of this. Now, the Redis portion is to help us assist in extracting all that data so then we can ingest it with Timescale on our own schedule on how we see fit, as you'll see very, very soon. Now we're going to set up Django with TimescaleDB using Docker and Docker Compose. Now, to me, Docker is a lot like iOS or Android in the sense that it's a platform. If you can install Docker, you can do the next step. Just like if you can install iOS or Android, you can do the next step, which is use the App Store. The App Store has a lot of applications that you can just download and use. In the case of Docker, you're downloading a bunch of containers that just can run for you because they are optimized for Docker, at least the best ones. just like the App Store, containers, if they're not optimized correctly, will fail. If they are optimized correctly, they'll work correctly and they'll work really well. So that's kind of how I think of Docker and containers. In the more practical sense, in the developer sense, you can download things like open source databases without installing them on your local machine. They will just run through Docker inside of that container in an isolated environment, similar to apps on iOS or Android. So the idea here is compose.yaml can define a bunch of different apps and various arguments you need for those apps to just let them run. And so that's what we see right here. Now, in my case, I already have Docker installed and I can do something like this. I also, in my case, say that I cannot connect to Docker daemon. This just means that my actual Docker desktop is not open. So I need to open up Docker desktop. So that also would imply that I've downloaded Docker desktop and it's already installed on my machine. As you can see, it's well supported for most, if not all, operating systems that are out there. So it probably even works on tablets and stuff like that, maybe even in iOS in some cases as well as Android. But the idea here is once you have this downloaded and installed, you can then go into Docker Hub and you can find other applications that you might want to use. In our case, it's TimescaleDB that we're going to be using, and specifically the one that's based off of Postgres 15. Now you can always download Postgres directly as well if you wanted to, but as soon as you want to use time series data, TimescaleDB is the way you go. That's my opinion, at least. So the idea here now is once we have the Docker running, I can see if I do Docker PS, I have other things that are running in here from my own testing. So you won't have anything in here. It might be just empty. But the idea is I now want to use this compose.yaml file in my local project here and just run something related to Docker Compose PS. So that's showing me some other things related to Docker Compose based off of what I was using. So if I do Docker Compose down, I can bring all of my old stuff down, and then doing -v actually takes down the volumes as well. And if I do Docker Compose up, it's going to rebuild everything for me. Now, if I hit Control-C and just close those things out and do Docker Compose up -d, this puts it in the background. So it actually will just always run basically, so that when I do Docker Compose and PS, I can see everything that's running. And then of course we can do Docker Compose and stop. That stops those databases from running. Notice that it didn't necessarily take them all down, so we just run down. That takes down the network with it as well. It doesn't just stop the application from running, but it takes everything down as well. But one of the things that just down does is it keeps the data in there. If you do -v, it will remove the data as well. Now, this is one of the reasons why you might not want to use Docker Compose in production, is because that's how easy it is to just delete a bunch of data you might have in your database. While that is really great for local development, it's not so great when you want to actually go into production. So I'm going to go ahead and bring this up with Docker Compose up -d, and that's going to start everything in here. So I can do Docker PS, and I can see all of my applications running. Here's my Timescale one. Here's my Redis one. Of course, I've tested other things as well. So, feel free to change things as you see fit in terms of your own Docker package all set up. Now, a lot of you that are already well familiar with Docker already have an idea of how this works. This is meant for those of you who are a little bit newer to it. There is so much more to Docker that I'm really glossing over, mostly so that we can just get the practical use case of Timescale on our local machine, and that's where we're at. That's why I'm using Docker Compose as well, because it keeps track of all the versions, all the different things that we need to use with the various databases, like with Redis, which we'll use at some point in the future. But for now, what we've got is a database service here with TimescaleDB. Notice that we've got a Postgres user, password, and database. All of these things we need to use for Django to connect to this actual service. So what we could do is we could hard code these things into our Django project. I never recommend that. You can also have them decoupled or separate values into .env, or you can use one single value, which is available in the sample itself. This single value is called a connection string. This is my preferred method of using the database URL stuff, or any sort of databases, whether it's our Postgres database or it's something like a Redis database, which we'll use, like I said, later. But the actual database URL we now need to implement. So if we actually take a look at the Django timescale package, do a quick Google search for this, so check the links below, you will be able to see some examples of how we configure this. And those of you who are known or well known with Django and all that, you'll have an idea of like, wow, I can use this right away, and it's pretty straightforward. But of course, what I want to do is I want to modify my database setup now inside of Django settings.py and just optimize things just a little bit. The first thing I want to do is I want to go ahead and do from decouple, we're going to go ahead and import config. Once, just like we did in the notebooks, the config itself is going to load .env, and then if we're in production, it would load os.environ, .get, basically, with some sort of fallback value. So what I'm going to do is I'm going to scroll down to where my database definition is by default from Django and just do database URL equals to config of that same argument of database URL. We're going to set a default being an empty string, and we're going to cast it as a string. So basically, I'm going to go ahead and say if database is not equal to an empty string, then we're going to go ahead and update our configuration here. And so I'm going to go ahead and tab this over a little bit. So what I could do is I could use the Postgres configuration for this database URL. But since I'm not going to do that anyway, what I'm going to do here is I'm going to import a different package called DJ database URL. This is quite literally made for Django database URL decoupling. If I look into requirements.txt, I don't actually see it in here, so I want to bring it in. So DJ database URL, we'll save that, and then we're going to go ahead and run our pip install -r requirements.txt to get that installed. Maybe I need to make sure I have install spelled correctly, as well as txt. Okay, there we go. So now it's in there, it's now installed, it's ready to go and ready to be used. So the way this works is we've got our database URL here now. In this database configuration, I can actually get rid of this dictionary here and just call my DJ database URL.config and then pass in the arguments that I want. In my case, the default is going to be our database URL. So this right here. Next up, we can actually do a connection max age, and I'll go ahead and say something like 600. This is in seconds, so if you want less time connected, like 300, that's 300 seconds that would be connected. That's probably pretty good. Okay, so you're going to want to tinker with this on how things are being ingested, but overall, I think 300 should be plenty. Next, we're going to go ahead and declare the engine. So when we actually look at the Django TimescaleDB package, we can see that engine is declared in here. This is what we absolutely want to use. If you don't implement this, it's not going to set things up correctly. It will just treat it like Postgres. That's kind of the idea with the DJ database URL. That's because this string itself is a Postgres string. That's it. It's not anything different. It's still Postgres. We're still using Postgres completely. It's just optimized for time series, which is why we end up using this backend right here, just to make sure that everything that relies on this backend is also using the TimescaleDB optimizations that come through. And so now that we've got this, let's go ahead and just run our installation. So I'm going to jump into SRC and go ahead and do Python manage.py, and I want to run migrate. This is going to create all of our database stuff, and then we might as well go ahead and run Python manage.py create super user, and then we'll go ahead and create one. I'm just going to go ahead and use my default username of CFE. I'm not going to put in a password, an email. I will put in just a whatever password in there because I'm in local development mode. That is totally fine. So with that in mind, I'm going to open up another terminal window, and I'm going to navigate and go ahead and run Jupyter Notebook again. All I want to do is verify that this is working. So if you remember my actual timescale or my actual notebook itself, I needed to change it from localhost to 127.0.0.1, and that should allow me to jump into it. So I'm going to jump into my notebooks, and I'm going to go to the Django setup package, and all I want to see here is there is a user. Now we see that not only is Jupyter integrated with Django, and that works, but we also see that our actual database is working correctly, and all of that is stored inside of the Docker composed managed version. So one of the things I could do right now is just verify that again by doing docker compose down. Notice I didn't do -v, I just took everything down. I can run this again and it's going to have an issue trying to connect to that database. So if you saw this, that just means that you did something wrong. If you bring it back up, and we'll just go ahead and do that with docker compose up. I'm not going to have it in detached mode for a moment. I'll just leave it as up like that. And then I run it again. What I will see, if I set everything up, it should be able to actually run it. So the connection is closed. So in this case, I have to restart the Jupyter kernel because that's how Jupyter works. And then we actually go through, we get that query set, and now it's connected again. Once again, if I were to take it down again and try to grab it, it gives me the same operational error that came from before. So once again, I'll just leave it in detached mode. So at this point, it is now ready to be used in other contexts. That next context is I'm just going to show you how to do this same thing, basically, but now with using the managed version of Timescale directly from Timescale Cloud. Now we're going to set up Django and TimescaleDB with, of course, the Timescale Cloud. Now you can always jump into my links right here if you want to give me credit for it. Even if you don't, that's totally okay. The idea here is we jump in here, we're going to try it for free. Once you try it for free, you're going to see something like this to set up your very first service, your very first Timescale database. So what I'm going to do is I'm just going to use the new service here, and we want to use time series and analytics. That's the one we're going to be working off of, so I'm going to go ahead and collect that one. And then you want to select a region that's nearest to you physically, unless you're going into production, of course. If you're going into production, choose a region that's nearest your production server. Ideally, you're picking stuff that's closest to your end users at that point. But in my case, I'm near Oregon, so I'm going to go ahead and say Oregon. The actual amount of compute doesn't really matter for what we're doing here. I think this should be plenty. Of course, if you start seeing degraded performance or slowing down or something, then just go ahead and create a new service with more performance. All of this is in the dev mode. We're just testing things out. We're really learning how to use all of this stuff. So you're going to change these quite a bit. Next up, we're going to do non-production because we don't need production. You can do connection pooling, but it's not something I'm going to implement at this time, so I'm going to leave it out. Next up, the service name. Go ahead and rename it. In my case, I'll call it my stock trading bot. Hey, what do you know? It's already auto-filled there. And I'm going to go ahead and run create service. Now, do keep in mind that when you do create a brand new account, you get a 30-day trial of it, which is great. You get plenty of things that you can do in 30 days. In my case, I actually went ahead and went over those 30 days and just created a new account so that I can actually continue to test. And of course, if you have issues, always hit up the support. They're very fast and they will definitely help solve that problem with you, and just let them know that I sent you, that you're just trying to learn more from my series. I'm sure they'll hook you up. Now, the idea here is we've got this connection string. What do you know? Yet again, another connection string. So we can just literally copy the connection string once again, jump into our .env, and right underneath this, I can paste in that connection string. Now, do keep in mind, this is obviously unique to mine itself. Now, as soon as I change anything with .env, I want to make sure that my terminal is just flushed. I want to restart my terminal altogether because it does cache things here and there whenever using .env. So with this in mind now, all I need to do is jump into my SRC here, run Python and manage.py, migrate. This will, of course, create those database tables all over for me. Now, it does take a little bit longer than Docker Compose because it's not on my machine. It's in Oregon. That's a whole other state beyond where I am currently, but yet it's still really fast. So that's a key thing about all of this, as well as there might be some latency issues that you have locally in your local development when you're using a cloud service in general. And of course, if you're not that close to the actual server, it's going to take a while. So that's why when you go into production, you want to make sure that you're using a region or an area that's as close as possible to where your database is stored, where that TimescaleDB database is stored. So now that we've run that migration, what I also want to do is I want to create a super user just to verify this as well. So Python manage.py, create super user, hit enter. Once again, I'll use that same username, but now since I'm using a cloud service for my database, I want to have a robust password here. So the way I'm going to create this robust password is I'm just going to go ahead and create a new terminal window. I'm going to use OpenSSL for this. A lot of you already have OpenSSL on your machine, even if you didn't install it. So if you do have OpenSSL installed, you just do rand, then -base 64, and then do some character digits in there, and this will create a pretty secure password for you. Now you can also use Python for this. There's a secrets package and stuff like that, but I like using OpenSSL at this point because most machines have them. So I'm going to bring that in as my password twice, and then I'm going to go ahead and run the server here. So I'll do python manage.py run server. I'm going to open this up on my local machine, and I'm just going to verify that I can log in by going into /admin and then just typing out my username and that password I just added, which should allow for me to log into the Django admin. This is one of many reasons why we like using Django, is because there's this admin in here that allows you to do all sorts of really good stuff. The other reason we like using Django is how easily it integrates with Jupyter, as we've already seen. So let's just go and verify that that's working. So once again, with another notebook or another terminal open, let's go ahead and open up Jupyter Notebook as well and just verify that that stuff's working as well. In my case, all I need to do is refresh in here and refresh in Django setup and just go ahead and run this. Once again, we should be getting that same sort of query set that we did before, but now, of course, my database is actually connected. So one of the nice things about this and the database URL of it all is if I ever wanted to run things on this cloud-based version of the database, let's say, for instance, we have GitHub Actions that you might want to run, or something called CI/CD, you will be able to do that. You'll be able to use that same connection string elsewhere to automate all sorts of things that come from this database as a result. You can do it directly on your Django code. You'd be able to run your notebooks. You'd be able to do all sorts of things just because you have this cloud connection string, which is fantastic. It makes things really, really effective for building out your tool and whatever service you're trying to build out. But now that we've got this, it's time to actually implement the service we're working on, which of course is ingesting stock data. So you're going to want to pick one of these two. You're going to either pick Docker Compose or the actual Timescale one. It's going to be completely up to you. I'll probably flip back and forth at some point, but the idea overall is just use one of them because we want to use the optimized Postgres version that Timescale gives us. Looking at the results of our stock market API clients, whether it's Polygon or Alpha Vantage or any other ones that you have found, you will see that we've got this data right here. So this is the result data that we want to now define inside of our Timescale database. The way we're going to do this, of course, is through Django and Django TimescaleDB. So the first thing that I need to do in order to make that happen is I need to actually create a Django component called a Django app. So if we actually go into the Django project itself and run python manage.py start app, and we call it whatever we want to name this app, which in my case, I'm going to name it Market. Inside of Market, we're going to have two different database tables. The first database table is going to be simply the company, and it's going to take in models.model, just like that. For now, I'll say pass. The next one is going to be a stock quote, and this is also models.model for now, and it's going to be related to the company using models.foreign key and the company itself. And then we have to define a few things related to this foreign key, like something like on delete. What do we do with this stock quote data when any given company is deleted? In my case, I'm going to do models.cascade, and then we'll go ahead and give a related name of simply stock quotes, something like that. Okay, so what this is doing now is it's starting the process of defining database tables. So these database tables are going to be automatically created for us thanks to Django's core feature. That's what the Django ORM does. It will define these in our TimescaleDB or in our Postgres database. Right now, there's nothing about this that is TimescaleDB specific. So what I want to do is build out the company data and really highlight why I have a company table and a stock quote table. One of the reasons is that companies themselves can have a lot of data that's beyond a stock quote. So it makes sense to have one source of truth for that company data. Another reason is a little bit more practical, and that is that stock market tickers can change. So like Facebook and Meta, for example. Facebook, I think, used to be under the ticker FB. Now it's under the ticker of simply Meta. So that changed slightly. And this happens from time to time. But their historical stock market data, I think, is still the same. I believe that's when Facebook went public. But of course, now it's a different ticker. So you kind of want to have a different model specifically for that. That's part of the reason to do this. The other part is the company itself is going to be assigned in other places. So there we go. That's why we're doing this. So the way this ends up working in terms of the actual database is this table, in a sense, relies on this table to make things happen. We might see how we can break this and how there might be little issues here and there. But overall, we have the basic structure of what we want to do. So the idea of the company, then, we will pass in something like a name of the company, which I'll just give it a character field, and we want to pass in a maximum length of, let's say, 120. That's probably plenty of characters for a name. You could also add in something like a description, which if you want a longer description, you can use something like a text field. In my case, I'm just going to say blank equals to true and null equals to true, meaning I don't actually have to fill it out. The name I will have to fill out, so we're going to leave that there. The next one is simply the ticker itself, which we'll go ahead and do models dot. And in this case, we'll go ahead and leave it as a char field as well. And I'm going to give a max length of like 20 characters. This one I want unique being true in here. And I also want to define this as a database index. So we'll go ahead and say true there as well. So that's it for the company data that I want. Probably in the long run. Maybe one other thing I might want to have in here is whether or not this is an active company, something that I actively want to track. I also might want to say what the timestamp is, like when was this actually added to the database. For that, we can do a date time field, and we can do auto now add being true. Now, do keep in mind this will also know about the time zone itself. So I did mention the time zone before. If you go into the settings.py for the Django project, and if you scroll down a bit, eventually you will see time zone information. So what's going to happen here is when it does store this, it's going to be in that time zone, whatever it is. In this case, the default is UTC. You can also do something very similar to this called updated, as in the last time it was saved, and you just change this to being auto now. Great. So there's our company field. And now our stock quote field is going to be a little bit different. And hopefully you already have a sense as to what it's going to look like. Now, if you don't, we can just jump back into either one of our stock market APIs and we can see exactly what we're going for here. And that's going to be this data right here. So whichever one you end up using is fine. I'm going to use Polygon because it did have another field in here, this number of trades field. So I want to have all of those in there. So I'm going to go ahead and copy this. And I'm going to bring it into the stock market quote. And I'm just going to put a triple string in here, mostly just for reference purposes of what it is that I'm trying to build out. Now, all of the price fields, all of them are going to be decimal fields, the exact same kind of decimal field. So I'm going to do open price equals to models.decimal field. And what we want to declare here is a number of things. First off, max digits. I don't think you'll ever go over 10 digits. That certainly could change in the long run, maybe. But if it did change, you could always update this with database migrations, which we'll see very soon in terms of database migrations. So decimal places, we're going to go ahead and do 4. Why are we doing 4 decimal places? Well, some of the data, depending on which API you're looking at, will have 4 decimal places, right? And so in the case of the Alpha Vantage one, we actually did talk about this a lot. The Polygon API doesn't have those 4 places, which is fine. It's not fully necessary. You could probably do 2, but overall I'm going to go off of 4 because of some of my APIs. So now what I'm going to do is actually copy and paste that a few more times, and we're going to bring in each one of these values in here based off of what we did with our API clients. Now, these column names are a lot more verbose. They're a lot more descriptive than the API had itself, right? So that's actually kind of nice, I think, having a little bit more descriptive names in terms of the columns. But let's keep going. Next up is going to be our number of trades. So this is the one that I know is going to be possibly an empty one. So I'll go ahead and do models dot, and we want to do this as a big integer field. If I scroll down a little bit, you can see there's big integer field. I'm going to go ahead and say blank equals to true and null equals to true. So it's not a required field. Next up, what we're going to do is volume. There we go. So we're going to go and bring in volume, which is also a big integer field. In this case, I probably need it to be required. I think it's going to be true on both of them. And I haven't seen instances of it not being true. Like both of them, both of the API services have the volume in there. So I'm going to go ahead and leave volume in there. The final one is the volume weighted average. Now this one looks like a decimal field as well. So in this case, it's a 4-digit one again, or 4 decimal places. So I'm going to go ahead and use the same values as before. So at this point, I think I have all of them with the exception of the time field. Now there's a big reason why I don't have the time field yet, and has of course everything to do with TimescaleDB. If we were to go back into our the actual Django TimescaleDB package, what we can see is after the setup process, which we've completed, we now see the timescale model. So there's two different ways on how we can define a timescale model. One way is we can define things directly. Another way would be to actually use the abstract model itself. So it's going to be up to you on how you want to go about doing this. One of the reasons I actually like having the non-abstract model is just so that I can see all of the fields at any given time. So what I mean by an abstract model is actually fairly straightforward in terms of Django. For those of you who aren't aware of this process or what you can do with Django, is you can define a model like this and then just pass into the meta information called abstract being true, which means you can inherit from that model. You can take all of the properties of this model and apply it to your other one. So you can just kind of make it reusable, a reusable model, and you would just change different things about it, which is one of the default values that it has. In our case, I'm just going to go off of this model, and I'm going to go ahead and augment our model. So back into our models.py, I'm going to bring this in here. We've got our timescale date time field. So I'm going to go down into my stock quote, and we're going to go ahead and call this time, and it's going to be our date time field. This time value, the column name is time, like all of these are the column names. So open price is the column name, close price is the column name, and so on. Time is required by Timescale. That's the column name. It has to be in TimescaleDB for this kind of data. It's going to be chunked together based off of an interval that we set. So I'm going to go ahead and set an interval here. And this interval, I'm going to go ahead and say something like 7 days. I think we could probably even use 1 week here. So we're going to leave it in as just simply 1 week as our interval. Now you might recall the actual stock quotes themselves, we might get them on different intervals than that. So if we look at the Polygon API, we've got maybe like a minute or 5 minutes. I can't remember what this one said, but basically if we look at both of them, they have some sort of interval that we're getting that data. It's not about that interval. It's about how we actually chunk these things together. So when we do it in terms of a whole week, it will chunk all data in terms of weeks instead of in terms of like minutes. If you do it in minutes, the actual performance will go down a lot if you're not actually storing it in minutes. So if you had hundreds of thousands of items coming through within a minute, so a lot of millisecond data, then maybe an interval of 1 minute makes a whole lot of sense. But in our case, we won't have that. We will have like, how many stock are we going to track? Maybe 500 in any given minute. That's not enough. We want to have a lot bigger of a chunk, so we're going to go ahead and use 1 week. You could also use 1 day like the actual repo says itself at this time. Okay, great. So that's the field that we want. The next thing that we want to do, going back into the Timescale, the Django Timescale package, we've got objects and also timescale. So there's different methods and stuff that we might want to have on here. The timescale manager is coming through just like that. Objects I actually don't need to define because by default models.model already defines objects. So I don't need to bring in the models manager in there because that's done on its own. So I'm going to go ahead and save that. But this is generally speaking the abstract model that you might use. If you don't want to have to rewrite time and use the default of 1 day, you could just come in and use that abstract model, which is what this is doing right there. And then you just bring it in and all of a sudden everything's going to be chunked based off of that single time in something called a hyper table. That's what's actually going to be created here with this field. It creates a hyper table, which is a table that's optimized for this time series data. That's one of the things that Timescale has pioneered. So with this in mind, we now have a stock quote data that's coming through. So all we need to do is go into settings.py and we're going to go ahead and create this. So inside of installed apps, we're going to go ahead and bring in market. and then we'll save settings.py. Now that we've got that, we need to run our migrations, which is python manage.py, make migrations, and then python manage.py migrate. And so what this should do is actually create the hyper table for us, which we'll verify in a little bit. But for now, we've got migrations in here. Inside, we've got initial. The point is we see that Timescale is being imported inside of this migrations. And if we scroll down, we can see all of the things that Django is doing to create this table in our database, in our TimescaleDB database. That's exactly what's happening with all of this stuff. So if you ever need to make changes to your database, this is what you do. You do migrations. It's the same sort of idea. So let's say, for instance, we wanted to change the volume. We'll change this weighted volume average to decimal places to being 6. I don't know why we would change it to being 6, but let's go ahead and just see what that looks like. After you make the change on the models.py, you run make migrations. After you do make migrations and verify the change, like, oh yeah, cool, I want to do this, then you run migrate. That's how it works every single time. Now, over time, you can also squash these migrations and get rid of all of the extra ones that you just don't need anymore, but that's kind of the point. A big part of the reason we use these Jupyter notebooks is for rapid experimentation without having to open up the Python shell to experiment. Jupyter does it really well. So what I want to do now is I want to start breaking out my API clients into their own modules so we can actually just run them anywhere within our Django project or within Jupyter. Now, I actually want to store these modules inside of the Django project still because this is still very much a Django project, even though I have this notebooks folder. So inside of SRC here, I'm going to go ahead and create something called helpers. And inside of there, I'm going to go ahead and create something called clients. So inside of helpers, I want to create an init file to turn it into a Python module. And that init file is also going to go into clients as well. So right now I've got helpers, clients, and inside of here, I'm going to go ahead and create Polygon.py. Now, before I go much further, I will keep in mind that Polygon.py might conflict with a pre-existing package. In the case of Timescale, if I called it Timescale, it would as well, right? So we've got a package called Timescale. So I typically don't want to name my clients based off of something that already might be a client that I go and install, especially with these helper functions that might be reusable. So if you were to go through the Polygon API stuff, you'll see that if you installed their API client, it is quite literally called Polygon. We don't want that. We want to just change it a little bit. The way I'm going to change it is just by using an underscore. That's it. So along those same lines, I'll do the same thing for Alpha Vantage because I would imagine they will have their own API client at some point. Maybe, maybe not. Either way, just using that underscore kind of solves that problem for me for both of these. So going back into my notebooks now, I'm going to start with the Polygon API client. I'll go ahead and copy this whole thing out here. The actual API client that we created in this single cell. This hopefully has all of the imports I need. It doesn't actually look like it does. So there's a couple of them that are missing. The obvious one is config. So we'll go ahead and do from decouple and we'll import config here. That solves that import problem. But also I noticed that Python requests is not in here, but rather it's up a little bit. So I'll go ahead and bring that one in as well. And here we go. Great. And so I'll leave that as is for just a moment. The way we define the API key, we might want to change this at some point as well. For now, we'll leave it as is. I do notice that I am in the wrong module, so I'll go ahead and cut this out and paste it into the Polygon one. There we go. So let's go ahead and do the same thing for Alpha Vantage, and I'll go ahead and copy this whole thing and bring it into Alpha Vantage. Once again, decouple's not in there. Python request is in there this time, so we'll leave that in there as well. And then I'll just go ahead and do from decouple, import config. Now you probably should reorganize all of your imports and all that. That's something for another time. But at this point, what I want to do is I want to update how I can actually access these different clients. So inside of my init file here, I'll go ahead and do from dot Alpha Vantage. We're going to import the Alpha Vantage API client. And then from dot Polygon, we're going to go ahead and import the Polygon API client. Now, the reason for this is going to be very obvious soon. Next up, we'll go ahead and do this all method here, or the dunder all method. We'll go ahead and bring this in and set it equal to both of these things so that it's easy to use these clients. So let's actually take a look at this now, and I'll go ahead and jump into my home value here, and I'm going to duplicate the Django setup. Let's go ahead and duplicate this, and we'll rename it to being something like helper API clients, and then we'll go ahead and open this up. Now, the reason I duplicated the Django one was because of this setup call right here, and that's pretty much it. So if I get rid of all of these and just go ahead and do from helpers, or let's go ahead and actually say we're going to import helpers.clients as helper clients, and then I'll go ahead and do helper clients dot, and then one of these values here. Go ahead and run that. Oops, let's go ahead and run both of them. What do you know? There's that client right there. And then we can do the same thing with Polygon as well. So helper clients and just like that. So the reason this actually works is because we're importing the helpers module, this entire module right here, and then the init method, all of this is being imported. So using all allows for this to actually work. So what we want here is the data set and the data set, right? And what is the data set that we're going to be having, or how do we actually get that? Well, there's a lot of different ways on how we can think about it, but if we go back in here, we can just use the get stock data, and both of those should be available for us on both of the actual API clients themselves, right? And of course, this is in the long run not how we're going to call both of them, but now we've got a data set, and well, this is actually not great, so I'll go ahead and say a data set and B, or data set A and then data set B. Let's go ahead and just change it a little bit so we know that we are still getting both datas in here. So data set A, there we go, and then data set B. Great. So now both API clients work and we can use them in a lot more places. So then in the next part, we can now start to actually implement this data into our Django project. Now we're going to load our stock quotes into our Django project. Now, the way this is going to happen is, of course, using one of our API clients and then creating the things we need to create in Django. I want to start very simply, and then we will get it to be more and more robust. So the very first thing I need to do is decide which one I'm going to use, which API client I'm going to use. I'm just going to stick with Polygon for now, although either one could be chosen. So the first thing I want to do, though, is I want to actually declare the company ticker I'm going to use. So I'll go ahead and say something like this, and I'll say AAPL for Apple. Then I want to go ahead and create the various arguments that go into that client, which of course where the from date, to date, and the multiplier, all of those things we want to bring in here. So going into our load quotes. At this point, these are just fine. These should actually be okay in terms of our client itself. So I'll go ahead and say client equals to that. And then our data set is going to be equal to the client of those data. So in here, we're going to go ahead and pass in the arguments. The first one is going to be the ticker argument. We will pass in as the company ticker, and we'll keep on going all the way through. I'm going to do the multiplier as 1. The time span, I actually don't need to change. I think the minute being default is fine, so I'll get rid of that one. And I will actually bring this in as a argument as well, so I can just quickly change it. And then we've got our from date and our to date. Okay, so at some point our historical data will be a little bit different than what we're doing here. But the point is that we should be able to do basically that and then get our data set back, whatever that ends up being. So what I want to do is get the first item in here. So we'll go ahead and say new stock data, and this is just going to be equal to the data set and the 0th element in there. So the first item in the list, there it is. Okay, so I actually want to store this data into my Django database. So the way we're going to do this is by going from the market.models. We want to import our two models that we have. So going into our Django project, market models, we're going to import our company model and then our stock market model, or our stock quote model. Okay, so first off, we actually need to create the company itself. So the company name, we'll go ahead and bring this up as company name being Apple, right? And so now I'm going to come down here and say company obj and created equals to company.objects.get or create name equaling to company and name, and then the ticker being the Apple company ticker. Okay, and we'll grab that one. There we go. So we run this one. We got company name not defined. So let's go ahead and try that one again. I'm actually going to change it out to where the client has its own cell. Let's go ahead and run that again. And there we go. So now we got our company object in here. It's the very first one. not that big of a deal. Next up is going to be our stock quote. So the way we can actually create this is a few different ways. So we can do stockquote.objects.create, and we actually already have some data here, so I can unpack this data, but I can also have to pass in the company data in here as well. So I'm going to go ahead and bring those in, and that will actually give me this ability. So what I notice here is my stock quote has no attribute objects. So the actual stock quote model does not have objects, which is interesting because the actual company model does. So when I mentioned that you actually probably don't need to write objects, looks like I was wrong. So let's go ahead and bring those objects back in and see if that changes anything. Now I did make a change to models.py. So whenever I do that, I like running python manage.py make migrations and then python manage.py migrate. Notice it quite literally did do a change. This didn't also always be this way, so I had to make a slight change, and now there we go. So let's go ahead and go back into this, notebook itself and restart the kernel here, so we can just rerun everything as need be, and now it should actually be able to create that object. Now, if I were to go create it again, it actually does create it again. This is a big problem that we definitely need to solve. Now, before I actually do solve this problem, I want to point out a couple things. The first thing is, inside of my model here, I've got a time field and I've got really no uniqueness going on. In other words, it's not actually checking that this time has already been taken for this company. We only want one instance per company for that time. And also in our company, we've got a ticker that's unique. That's nice, but our stock quote does not have that. So that's, of course, a problem. And so at this point, this is where we should have designed this before. We should have thought about this before, but now that it's coming up, we need to do it now. So I'm going to go ahead and do class meta, and we want to do something called unique together. And what unique together does is it will allow you to combine two different fields and make sure they're unique. This creates a brand new index to ensure that they are unique, a new database index in there, which also helps with querying data. So we want to bring in the company field and the time field. So we'll go ahead and do company and time. So as soon as I do this and go to try and run the migrations again, I run migrate. This might work. It also might not. Now, the reason it's not working is because I should have done this in the first place. My database already has some data that causes this to have an issue. So there's a lot of ways around how you can actually solve this problem. But since we're in development mode and we're learning about this together, we can actually do something that I think is pretty easy to do. And that is literally removing our old database and starting anew. So what I'm going to do is, first off, for those of you who are using Docker Compose, you can just do Docker Compose down and then remove the volumes, and then you're going to want to do Docker Compose up again, and you can put it in detach mode 2 with -D. Right? So in my case, I'm actually using the Timescale version for another reason. So I'm going to do two things right now. The first thing I'm going to do is create a brand new Timescale database, and then I'm also going to go ahead and verify the hypertables themselves. So going back into Timescale Cloud, I'm going to come in here and I want to just delete this database. So going into services, if I click on these three dots here, I can go ahead and delete this service, and we'll just go ahead and type out delete and delete that service. Boom, just that easy. So in this case, I'm just testing it out. It's asking for a few things. It looks like I have this data already in here. And so what I want to do is create a new service. So let's go ahead and do this all over again. And hopefully you already have an idea of what to do. But overall, I'm just going to come in and just recreate this as the stock trading bot and create that brand new service with the brand new data, right? And so this is obviously very fast. And so I'm going to go ahead and copy this, come into my env file, and we're going to go ahead and paste this in. So now that we have the schema correct, right, with our new models.py, I can actually just basically refresh what I was trying to do, right? And so all of that means is I'm going to come in here once again. I don't really need to restart Jupyter. I actually might need to, so let's just go ahead and restart it. And so what I want to do is jump into source. I'm going to run python manage.py migrate. Let's just verify that it actually does migrate. At this point, it's maybe not available just yet because it's still being deployed. So it's definitely something that we want to wait a few moments for before we can actually run our migrate command. And then also in our Jupyter notebook, it's not going to be any different. So this is where if we design our systems in such a way that we can recover like this or delete databases, we're on the right track. We want to be able to have the ability to delete stuff and then re-bring them back up. Now, one of the things that after you actually have data, you're going to want to learn how to export it somewhere so that you will be able to completely bring it back up. But in this case, I now have that database service up, and I can now migrate the database tables once again. And now I should be able to run my Jupyter notebook. So let's go back in here and do Jupyter notebook and come back in. I could just refresh on my old notebook that I had open. So let's go ahead and refresh in here and run everything that's going on. Once again, we get these stock quotes in here, and now I can create that data. I try to create it again. Now it creates an error for me. This is great. This is exactly what we wanted. We wanted it to prevent creating the same data all over again. And so this is the simple way to load it. We don't actually want to go one by one. We want to actually load in a ton of data because this is really inefficient. But we needed to get here to verify this unique constraint being a problem. The main thing here is the reason we want the unique constraint in this case is because each stock quote is unique for that specific time. So regardless of what API service we're using, we want to make sure the stock quote is accurate for that time. And the more granular the time we can get, the more accurate it would end up being, which is also another part that's kind of cool. Now that we've got this, we now need to see how to bulk load stock quotes into Django so it's a lot more efficient using batching and all of that. Now we're going to take a look at how to do batching and bulk creating of our data. So what we want to do here is we want to run some of these items as we did before. So it's really just about getting the company object, and then instead of doing a single create, we're going to go ahead and do something called bulk create, which means that we actually pass in a list of objects in there. So let's see how we actually create that list. So we'll go ahead and say new quotes as an empty list here. Then we want to iterate for data in the data set, basically each one of those items from our stock request here. Then we're going to go ahead and do that bulk create. The way we do this though is we grab the stock quote itself, and we're going to initialize it basically the same way, just without objects and bulk create. So just like that, but of course, instead of it being new stock data, it's just going to be simply data. And then we just append that to our new quotes here, that new list in there. And so of course, what this will end up giving us is a bunch of stock quotes that do not have an ID. The reason they don't have an ID is because they weren't actually created. We just prepared them to be created. So all we need to do now is just say stockquote.objects.bulk create, and then grab all of those new quotes in there. One of the other things that we'll want to do is something called ignore conflicts being true. This is going back to what we did in the last one where we had this unique constraint failure. This will take care of that for us on all of these items. So if I go ahead and run this now, it should actually ingest everything for me. And so at this point, we should have a lot of stock quotes in here, and we can run that as we see just like that. Great. So that's the simple way of creating a bunch of data really, really quickly. But the thing is, I want to batch some of this data. So in the case of the data set, what we have right now is not that much data. So we probably don't have to worry about batching too often. But I'm going to go ahead and take a look at this. It's only 818 things. It's not really that big of a deal. But if we were to extend our API, let's say we extended our dates quite a bit, then we will need to batch it. So in that case, we want to just prepare for that batching process. So it's not necessarily just like this. So for that reason, I'm going to go ahead and copy this, and we'll come down and do something like our, let's go ahead and say our batch size, and we'll set it to 1,000. So the idea here is we're going to go ahead and do for I in range 0, the length of the actual data set, like that. And then we'll go ahead and bring in our batch size in here. And what we can do is we can print out I, right? So this is going to give us a bunch of information about this entire thing, which of course our batch size is maybe a little too big right now. So I'm going to go ahead and turn it to 100. And now once I chunk it down a lot, you can see that these are the batches now. So the idea, of course, is if we change our dates, this will actually help us a bit. So we have a much bigger batch. So let's go ahead and change our dates. So it has a few months in there now, and now our data set is much larger. So if we actually were to come in and take a look at all of these items now, I'll go ahead and comment this out for a moment, and we'll bring this down a little bit. But now if we look at the batch size, it's quite a bit different. So if we were to change it to 1,000, we can see that there are now 5 batches. So that's the idea behind the batching here. And so what we want to do is we want to grab a batch, and we'll call this a batch chunk. And this is going to be equal to the data set. And that's going to be our data set, and it's going to be I to I plus the batch size. So it's basically just taking a little chunk of that data set in there, and that's when we're going to go through and actually create new quotes. In other words, we're going to do that entire batch right in here. So I'll go ahead and tab this over. This is now our batch chunk in here, and there we go. So then I can do my bulk create in here just like that. And that will actually now run through each one of those items, and then everything should be generated as is. So what I just want to do, though, is I'll change this from new quotes to just being chunked quotes or something like that. And then that way it's just a little bit different than the previous one in our Jupyter notebook. So now if I were to run this, I should actually get quite a bit more quotes in here. And we could do that as well and just do .count on here. And we should see that there's 5,000. If I were to run it again, it's going to actually just ignore a bunch of data because it already exists. So it's not doing it at 10,000 or whatever. So that's also pretty important. So what we really need to do, though, is kind of combine all of these things together. Have our API client, have all of the arguments that are going in there, and then have the actual quotes going through as well. And we're going to want to do this on a regular schedule, of course. But the idea, though, is just to make sure that we can change things. So let's say, for instance, Google, we want to just verify that one, use the capital stock ticker in there. And now we'll go ahead and run this. Should be the same amount of data because it's, well, the same amount of data from the stock market, right? It's not going to be any different. So now if we go through and batch everything again, it's really fast. 10,000 items are now inside of our database, and all of these things, of course, are stock items. Now we just want to turn this into a regularly updating thing that we run at any given time or any given interval. In order to automate this notebook, we need to turn it into a task. Now, eventually this will be a Celery task, but we're going to start off with just simply a task itself. So the idea then is to grab everything in this notebook as a task. So let's go ahead and open up our project here, and I'm going to go into market, and we're going to go ahead and do tasks.py. Now the reason it's called tasks and it's inside of market versus helpers is so that we can actually use it in Celery later. Now the first thing that I want to do is I'm going to go ahead and do from Django.apps, we're going to import apps, and we're going to define something like sync stock data, something along those lines. And so the first thing that I want to do is grab the companies that are inside of my different apps. So if we do apps.getModel, we can call our market app label and then the model of company. Now the reason I'm doing it this way is so that if I need to in models.py, I can actually call these tasks in here, which is actually fairly nice because we are calling it from apps instead of from .models import company. This basically means that we don't have some sort of like loop that's happening or basically dual imports in the same place. So in other words, if we go back into models.py and do from.tasks import our task, we totally could do that. So that might be something you do at some point. I do it with all of my tasks all of the time for that exact reason, as you'll see with Celery once we get there. But the idea is now we've got our company data. We're going to grab our query set, which is going to be company.objects.all, or more specifically, filtering it down to active being true. Basically, we would now have control over all of the companies we want to update based off of, well, our database, right? So we can just use this flag right here on whether or not it's active, and that's going to propagate into this right here. So the idea then is this is going to be more like companies, and then we would come through and say for company in companies, and then we can print out what that company might be. Now, there's not a whole lot about this that's really that surprising, hopefully. So what we want to do now is we want to make another task that basically takes in the company data and then does everything that's in this notebook itself. So let's go ahead and do that now. So we're going to go ahead and do sync, and we'll call this our company stock quotes, something like that. And then in here, we are going to pass in the company ID. So instead of the print statement down here, we're going to go ahead and do the company.id. Now, when we come along this, I'm just going to go ahead and say pass for just a moment. One of the things that's important to note is we can also just do a values list of the IDs. And then that way we just have our company ID coming in here. And that's just a simple and easy way to pass things around, especially when we are talking about Celery tasks, which we'll look at very, very soon. So the idea then is, since we now have these companies in here, I'm going to go ahead and bring this company model up. And now I'm going to go ahead and do the company obj is equal to company.objects.get, and ID being the company ID. Now, there is a chance that you call this function here without a company ID. So we can also just go ahead and say try and then accept pass, which basically means that you did something incorrect. But now with that in mind, I'm going to go ahead and actually say company is none. And then we'll go ahead and say if company is none, then we'll just go ahead and return back the function doing nothing else. Okay, so now we actually need to sync these quotes. So let's go ahead and go back into the notebook and see how we're going to go about doing that. Well, it has everything to do with this right here. So if I paste this in here, we're pretty close in terms of the data set, but of course, I still need to grab that data set. So now it's kind of up to us on how we grab the data set. But before we even do that, we can also go ahead and bring in our, the model itself with apps.get model, and once again, market, and then the model name. Great. So the data set itself, this is something else we will definitely need to adjust. So the question here then is going to be something along the lines of defining batch insert stock data. This is probably actually how I'd rather do it, and just pass in the data set in here and then the batch size of whatever I want the batch size to end up being. And that's actually what I'll want to do. So I'm going to go ahead and cut this out again, and we'll paste it in up here. So this is actually a good time to turn this into a utility function. This is no longer a task. This is actually doing something for me. So that's actually what I'll end up doing, is I'll go ahead and bring in all of this stuff in here. We still need to bring in the company object as well. So I'll go ahead and say company object is none. Ideally, the company object will be something. So we'll go ahead and say if company object is none again, then we'll return again. Okay, we would probably want to actually raise an error here, but for now, I'll just leave it as is. Okay, so with this in mind, I'm going to go ahead and create market and utils.py, and we'll quite literally bring this entire thing over. So bring it in here. The nice thing about having it in utils as well is we could bring it back into the notebook and test it out, ensure that it actually is working correctly. But I mean, I copied everything directly from the notebook, so it should work just fine. And then after that, we could also do something along the lines of how many things were created. So I'll just go ahead and return back the length of the data set, something like that. Now we can also verify a bunch of things with the actual store data itself. That's outside the scope of this one for now. We'll just go ahead and leave this as the name there. It looks like I accidentally cut out some of this. So we'll go ahead and do from.utils. We're going to import that batch insert stock data again. And now we'll just bring all of that stuff in. I still need the data set itself. So we'll go ahead and bring in that. And then we'll do a data set being equal to something. So the data set is going to be equals to an empty list. Okay, cool. There we go. Okay, so far so good. We've got our data set in here and then a way to batch this in. Nothing about this should be that surprising. The only thing that might be new to you is getting apps in this way, getting the actual model itself in this way. That's the only thing that I would imagine would be new to you. But everything else, I think, is fairly straightforward. So the idea then is the data set. How do we actually grab that data set? Well, if we come back into our batch load one, we've got our Polygon API client, which of course you could use the other one as well, but this is absolutely how we're going to grab that data set in here. I'm going to go ahead and grab the import as well. There we go. And now, of course, we need the company ticker. There's no surprise here with the company ticker. That's going to be equal to the company object.ticker. No surprise there. Once again, if that is none, then we'll go ahead and say we'll return it. Now, again, we would probably want an error in here. We would probably want to raise an error because, well, that is a problem. This is poorly formatted in terms of what you would actually want to have happen in the long run. But in the short run, we just need to make sure this stuff is working out. So we've got this multiplier in here. What we had before was 1 minute. I'm just going to leave that. I'm going to leave the default there. So this kind of brings me to my from date and to date. How are we going to do this one? Well, what we want to do is the start dates. From date is the start date, right? So that's going to be in the past. So we'll go ahead and say that this start date, well, there's a lot of different options we have here as well. So I'm going to go ahead and do from Django.timezone, or rather, we'll go ahead and do utils import time zone, and we'll do time zone, and then we'll also go from date time import time delta. Okay. So what I'm going to do here is I'm going to say days ago, and you're going to basically set what you want for your days ago. I recommend doing at maximum 1 month. If you do it longer than that, you'll have to implement pagination here. So all I'm going to do is say 32 days. This covers everything. I mean, you could also just do 31 days, but I'm just going to do 32 days. So it's really just a rolling of 32 days. This actually might be a good argument to bring in here in terms of the actual syncing and how that's concerned. So what that means then is the end date is going to be timezone.now, and then the start date will be the end date minus the time delta. So time delta and days equals to days ago. So now we've got the end date and the start date. So basically, the end date needs to be adjusted to be to date, being end date, and then the str f time, or the string format of the actual time that we want. It gives a few examples in here, but of course the idea is we do %Y -m, or %m, and then %day, or lowercase d. So that of course is the format that we saw already, so I'm going to go ahead and use that format, and I'll just say date format equals to that, and I'll go ahead and put a trailing quote on there, and this might be an argument we bring in as well, because I'm positive that the other API client does this slightly different. So anyways, we got our date format now, and we'll go ahead and use that for our to date, and then our from date is going to be the start date and that same setup. And here we go, we put that right there. Great. So now it's all almost working, or it seems like it's working. We need to test things out for sure. We need to make sure that it is actually working in terms of all of this data. There's a lot of things that can go wrong here. So instead of having these return none items in here, I'm actually going to go ahead and raise exceptions. So we'll go ahead and say raise exception, and we'll go ahead and do the company stock ticker invalid or something along those lines with this, and we will bring that into our company stock ticker thing right there. Then we will also go ahead and the company object, something along those lines as well. And we'll go ahead and say maybe the company ID is invalid, so company ID invalid. And then down here, that should probably be okay. And then also maybe if I want to have something a little bit more verbose, I'll go ahead and add in verbose being false. And we'll just go ahead and say something along the lines of if verbose, then we'll go ahead and print out the data set length and the length of the data set. And right away, I already see something that's a problem. We've got our data set, and then we reset it to being nothing. So we'll get rid of that as well. I will also pass in verbose as an argument to the bulk insert here. And so we'll go ahead and do that as well. Going back into our utils here, we'll go ahead and say the verbose is false, and then basically say something along the lines of, if verbose, then we'll go ahead and say print doing chunk, 0 or whatever I is, and then maybe down here print out again if verbose, print out finished chunk, whatever that is. Of course, we could always get the batch size in there as well, and that should not be a 0, that should be an I. And there we go. Okay, so that might be a good way to just verify that these things are all running based off of the different dataset items. Now, this also might be another thing where we raise an exception and basically say, hey, this is not an actual company. So we would go ahead and do this same sort of exception in here. So this time I'll go ahead and say something like batch failed company object invalid, something like that. Great. So now that we've got some of these errors and we've got these tasks sort of built out, let's actually bring it on into a Jupyter notebook so we can just test these things out. We will test them as just standard functions, and then we will also test them in the same notebook at some point with Celery involved. With Jupyter still running, we want to verify this stock syncing data tasks. The way I'm going to do this is by duplicating the Django setup one, and we'll just go through this because at minimum, we just need Django installed and we just need to verify that those tasks are working, or those soon to be Celery tasks are working. So I'm going to go ahead and, remove a bunch of cells in here and just initialize Django. I'm going to go ahead and do from market.models. We're going to go ahead and import everything from here because what I want to do is I want to make sure that I have companies. So we'll do QS equals to company.objects.all. And I just want to make sure that I have a count of companies in there. Sure enough, I do. Next up, I'm going to do my stocks, and I want to go ahead and do the stock quote.objects.all, and we want to verify that some are in here as well. Now, in my case, I actually tested things out, so I actually don't have any, but basically I want to go ahead and say, start from scratch and be able to delete things being true. So if that, then we'll go ahead and grab this query set here and delete it. This way we can just verify that those tasks are actually working based off of the companies that are there. Now, of course, I could also filter active being true just to see that as well. Now, this is just a very simple way to verify this stuff. Obviously, we could have more verbose and more robust ways to test them as well. So what I want to do is come in here and rename it to something like, verify stock sync or something along those lines, or just maybe just do stock sync. We'll just call it stock sync. Let's actually make it, I think, maybe 13 or 12. Okay, cool. So we'll leave it in as 12. And my tests are gone. Okay. So with this in mind, we'll now go ahead and do from market. We're going to import tasks as market and tasks. I like importing it this way, very similar to the helper functions that we saw before with those clients, so they can call either one of these things. So the very first thing I want to call is maybe the entire part. So that's going to be sync stock data like that. And so what we hope to see is something like this. We get an error in here right off the bat. So that means that I did something wrong in here with our data. So let's go ahead and actually take a look at that. I'm going to copy this whole thing right here, or maybe just part of it. Either way, I'm going to go ahead and come in here and we're going to run this once again. This time I want to just make sure that my list is actually working correctly. And so all I'm going to do is print out this value and run that because I get an exception. So it seems like I did something incorrect, and I did. That's this values list here. This needs to be flat being true. Once you do flat, then it just works with that one single thing. When it comes to this query set of values list or values, Django can actually grab only certain things. So if you did something like name in here, flat can't be used with more than one field. But if you were to grab values list of the name, now you see that tuple is back. So that's all that happened. I just didn't put the right argument in here. So I'll go ahead and say flat equals to true again. And there it is. So now I know exactly what I need to fix in here, which is going back in here and just saying flat being true. Great. So with this in mind now, I'm going to go ahead and get rid of this. And we're going to do the kernel restart and run all cells. So we're going to go through that process. And once again, now it's actually taking a lot longer for syncing the task, as it should. So what we should see in here is stocks. If we actually called this again and did a count on here at the very end, we should see a lot more stocks coming through, because now it's going off of the last 32 days or so for both of those companies that are in there. So that part is definitely working. I think all of it is working. And if I were to run this again, I should see the exact same amount of data in there. So let's actually go ahead and add in another company in here. So I'm going to go ahead and come up here and just do company.objects.get or create. And I think the name is going to be Meta. And the ticker is, I believe, just simply Meta. Okay. And so once again, now I have another company in there. And if I were to run this multiple times, I've got no problem. The start from scratch now, I'm going to go ahead and change that flag to being false so I don't delete my old data. But now I can go ahead and run all of this and see what's going on with the data. This time it should be a lot more, but we get another problem and we've got no results in here. So this is getting that data from Polygon. We're getting no results probably from the Meta ticker as it is. So what I want to see here is the fact that the Meta ticker is incorrect. It's not lowercase. It has to be uppercase. This actually brings up a new point that maybe we should force the ticker to be uppercase, right? So another reason why we test things out in these Jupyter notebooks. So in models.py here, I'm going to jump in and define a save method here that takes in self args and keyword args. And so what we can do is we can say self.ticker equals to the self.ticker and then .upper. And the ticker itself has to be uppercased, right? So that has to be in there. So we can feel confident that this will definitely be in there because it's not allowed to be blank or null. So I can easily do this. If it could be blank or null, I would have a condition in here saying if self.ticker. But I don't need to do that. So with this override method, I now want to do super and then .save and args and keyword args. Granted, if I were to keep that ticker part out, this would be doing the exact same thing that it did originally. So with this in mind, jumping back into my notebook here, I'm going to go ahead and grab the object and created, and then I'll just go ahead and call obj.save right on here, just to make sure that that ticker is working correctly. Okay, so let's go ahead and do kernel restart. I'm going to actually leave this as a lowercase because that's what I started it as. So let's go ahead and do restart kernel and bring this back and run that again. This time, I believe we will have the correct one. The correct results will actually come through. Now, this actually brings up another point that we might want to consider going into our actual helper functions in there. So if we look at the Polygon one, which is what we were using, the ticker itself, we should probably just force that to be uppercased as well. So it's kind of two ways on how we think about doing this. One is how we store it into our database. The other one is how we actually call it in here. So once again, I'll go ahead and put it in that same sort of setup as .upper. That way we don't actually have that problem in the future when it comes to calling the API. This might be true also in Alpha Vantage. This would be something worth testing on your own. But at this point, I now have a really good sense that the Polygon API is going to work correctly. One other thing to note is down here is it said it had none of those results in here. So what I want to do is I'm going to go ahead and say get results and like that, or none. And then we'll say if results is none, then we'll go ahead and raise another exception saying, that the self.ticker is not correct. So we'll go ahead and do something like this. Self.ticker has no results, which of course is what happened with the incorrect ticker. But now we'll go ahead and actually see it. So we can just go ahead and say something like ticker, self.ticker has no results. Great. All right, so back into that Jupyter notebook here, we're going to go ahead and clear and restart all cells, and then we'll go through this each one and see what's going on. Now, right away, this company objects get or create has a new problem because I'm looking very explicitly for a lowercase ticker when it should be an uppercase one. As soon as I change it to an uppercase one, everything else can run as expected. And that, of course, has everything to do with the fact that if I am creating one that's not the same, it's technically not, it is actually unique still because they're not actually the same. So lowercase and uppercase are not the same in the case of the database and this unique clause, which is exactly why we want to do something like this as well, just to make sure that that doesn't cause an issue for us in the future, even if our API service is changing it a little bit. Now, another thing that we could also consider is just lowercasing everything. That's another option as well, just making sure that when we do call the stock data, that we change it to be the correct one, which in the case of the actual stock tickers, the correct one is uppercase. That's how they're always stored and displayed. So we're going to go ahead and leave it as is. But now that we actually have all of this stock data being synced and we can actually create new companies, we can actually start the process of integrating this into Celery, because all we need to do is a few configuration items, and this thing's going to be ready to run on a schedule or on demand as we see fit. We are now going to implement a background task queue that is called Celery. So Python Celery is its own program. It can run completely independently of Django, of Jupyter, but the point here is it's a task queue. That means I can tell it to run specific functions at any given time. So we've already seen some of these functions, but I think a fairly good analogy would be to jump into a Jupyter notebook and hit kernel and run all cells. So right here, this is like a micro version of what Celery does. I just told Celery to run all of these different tasks. So in Jupyter, it goes cell by cell, and that's essentially what a task queue is to go, task by task. Now, the other cool thing about Jupyter as well as Celery is, I can run a specific function, or I can actually just go out of order and run a different one. I can kind of pick and choose on how I run these things. And so that's why we actually want Celery to be in our Django projects in general. One thing that's a little bit more specific to what we're doing here is the fact that we want to sync our stock data at some sort of interval. Now, you might want to sync it every single day. It really depends on what your goals are with the stock market data itself. In other cases, you might want to sync it every month or every year. It really just depends on your strategy and all sorts of things. The point here is to learn how to implement all of it so it works as best as it can for us. Now, I will say Celery is not the only way to accomplish scheduled running of a specific function. We can also do that with GitHub Actions and the cron scheduler in here. So GitHub Actions workflows, which I cover in the SaaS Foundation course, you can actually see you can run Python management commands or Django management commands. As long as your database is cloud-based, like ours is, you can absolutely run a GitHub Actions workflow to schedule out the way we want to sync this stock data. That would mean that you don't have to set up Celery whatsoever. Now, on the other side, we could actually just have this entire project be based on Celery and only use Django maybe for the Django admin to manage a few things here and there. Or we can actually implement a web application within Django and have that run alongside of the Celery application as well. So as we've been seeing with our Jupyter notebook, we have a full-on process dedicated to running the Jupyter notebooks. We need to do the same thing with our Celery workers. So let's go ahead and take a look at how we implement this process. The first thing that we want to do is jump into requirements.txt, and then we're going to go ahead and add in Celery. We'll also add in Redis, and there's a few other ones that I also want to add in that are related to Django and Celery, which is Django Celery Beat and Django Celery Results. These two are the ones that we would definitely need. These two are optional, but I highly recommend. Beat would be recommended, especially if you are going to be doing scheduling, which is what we need. So I'll go ahead and have those in. Results actually just stores the results of tests that you run inside of Django with Celery itself. So with this in mind, I also want to go ahead and go into my root project here. We'll go ahead and install these requirements, of course. I also want to bring down my Redis database that I currently have. It's certainly possible that another item on my system is using Redis at this port. So if I want to, I'm going to go ahead and just change this to simply a different port altogether and then update my .env with that new updated port, as well as I'll also update the sample as well. So with this, I'll go ahead and do docker compose and down-v. Now, of course, I am still using the actual cloud-based Postgres version, so feel free to get the cloud-based Postgres TimescaleDB going. Otherwise, you might have just taken it down. But the idea now is we are going to go ahead and do docker compose up, and we'll bring it back. And now I've got my Redis database actually running, so I can implement my Celery configuration. So first and foremost, before I jump into this in too much detail, I will say this blog post will be really helpful to just copy and paste certain things if you need to. One of those things that we need to do is jump into CFE home. We need to bring in Celery.py here. We're going to go ahead and bring in from Celery. We're going to import the class of Celery, and then we're going to go ahead and create the Celery app, and we're going to name it the same as our Django project. So we're going to name it CFE home. This is the name of the Celery app. Before I do any more configuration here, I want to jump directly into the init module here and just go ahead and do from .celery import app as Celery app. And then we'll export that as well. And you want to make sure that it is as Celery app. There you go. Okay, so now that we've got this, let's go ahead and figure out the rest of our Celery configuration. The first thing is going to be app.config from object, which is going to take in django.conf:/settings, and then using the namespace that we decide. But in this case, I'll stick with the default, the recommended one, which is Celery itself. Now, this means that we're going to actually configure Celery based off of Django. So the actual Django configuration will also configure Celery for us. We also want to run app.auto-discover-tasks. This will look for things like tasks.py once we have all of that all configured. So we're almost done, but now we need to just jump into the Django settings and install a few things here. First off, of installed apps, we want to go ahead and bring in our Django Celery beat and then also Django Celery results. Notice that they are underscores instead of, the actual dashes that we had in requirements.txt, as one would with Python projects. Great. So with this, we're now going to go ahead and scroll to the very bottom, and I want to grab my Redis URL, and this is going to be equal to config of Redis URL, and the default here is going to be the default Redis URL, which is localhost 6379. Great. So this is a general Redis URL. For Celery, I often have another version of Redis running for Celery and another one for caching. But right now we're just using Celery. We're not doing caching, or at least Redis caching. So we're going to go ahead and just stick with that Redis URL, which means that our Celery broker URL is going to be equal to that Redis URL. Great. So Celery and Django now know about Redis, and they're going to be using it in the same way. Django can call things that are related to Redis and are related to Celery, and that will go into Redis. And then Celery, while it's listening, will be able to actually use that same Redis database as well. Cool. So after this, we have a few other things that I'm going to go ahead and just copy and paste. That's going to be our Celery result backend here. So the result backend itself is where it's going to store things, which is going to be in the Django database. The beat scheduler is also going to go based off of the database as well from that Django Celery beat, actual installed app that we just added in. So this one up here. Great. So now that we've got these things, all I really need to do is maybe a few other configuration items that have changed over time. I'm just going to go ahead and copy and paste these as well. A lot of times what you'll see inside of Celery is something where it's like app and then those configuration items in there, like app.config, and then a few of those other items that I just added in here, such as like broker, SSL, or use SSL, and that being false. This is certainly another way that you can configure it. I don't think that's the exact setting, but there is a way to do it that way. I don't recommend that. I recommend using settings.py for this. So at this point, we should have Celery completely installed. The way we verify this is by going into the root of our Django project and quite literally running Celery-A CFE home. What do you know? The CFE home module is right there. And inside of init, it is actually importing the Celery app itself. That's how we can actually call it. So this is calling some of the baseline stuff of the app. Then we can call worker, we can call beat, either one. Worker is going to be the main one we will use for the time being. And then I'll go ahead and do -L as in log level for info. We'll go ahead and hit enter, and we get this error here. I put name paste, not name space. So let's save that and update it. And there we go. So now we've got another issue where it's saying that the variable Django settings module is not found. Now, this is actually something we saw when we set up our Jupyter and Django configuration as well. I'm missing a key configuration from this. So what that is we're going to import OS, We're going to jump into manage.py. We're going to copy this setting right here and paste that in before we set up Celery itself, just so Celery knows where the setting module is itself. This doesn't tell it anything. This tells it everything. Now, if we run it again, now it's actually going to attempt to configure with this. So this is actually using the wrong environment variable. I probably need to update something. I don't need to update .env. I probably just need to go in and create a new terminal, go back into cd-src, run celery -A, cfe home, worker-l info, and like that. And now it's actually running and it is ready to go. So all we need to do is actually test that this thing is working by converting a task into a Celery task or a shared task. That's something we'll do in just a moment. If you're not able to get this working, then perhaps you have to get a new version of Redis on your machine, or you're using some sort of managed Redis service. Because if you can't connect to Redis on your local machine, then yeah, that's obviously a big problem and you won't actually have the ability to do the scheduling. Now, the cool thing about all of this is something that is worth knowing is this Redis URL, if it is a managed project, if it's a cloud-based managed Redis version, and you have your cloud-based managed TimescaleDB, if both of these are cloud-based, then your Celery project can run anywhere in the world. It can run next to where your Django app is running, or it can run on the other side of the world. Now, latency still might be an issue. That's not really the point. The point is they don't have to be right next to each other. The other point is you can actually run a lot of versions of the Celery worker. So you just come in here and do CFE home worker. I now have 2 workers running. Now, it would be better to configure this a little bit more, which is beyond the scope of this one, but you can absolutely have a bunch of different Celery workers running at the same time and have the ability to execute all of these different tasks at the same time, which gives you a lot of concurrency. So Celery, unlike something like Django, Celery can really scale very, very easily with different services. Django can scale pretty easily too, but it requires a load balancer of some kind to then leverage Django. Celery doesn't need that. Celery can just do it on its own. It's pretty neat. So, but now that we've got this, let's actually start with those shared tasks so we can actually put our stock market syncing in an actual scheduled task itself. Let's see how easy it is to turn any given Django function into a shared Celery task. Of course, we want to keep it in tasks.py. That is actually what this auto-discover tasks is all about. It will look in tasks.py to find and import from Celery itself. So if we do from Celery and import shared task, we can actually use this decorator on all of these different functions that we might want. As soon as we use that decorator, these are now ready for Celery, which we'll test in just a moment. Now, one of the things that's really cool about shared tasks is you can call other shared tasks within shared tasks. So in other words, I can actually call .delay here, and that actually makes it managed by Celery. There's also another one called apply async in this, and you can pass in different arguments with it as well. But just doing delay is the best one, I think, because it's such a shortcut that makes it really easy to just use other kinds of tasks in here. And so now that these are shared tasks, let's go ahead and open up a Jupyter notebook and just call them. So notice that I need to have a couple things running now. One of them is going to be our Celery application. So let's go ahead and navigate into SRC, run Celery -A, CFE home, worker, and then I'll go ahead and do my log level of info. As soon as I do that log level of info, I can see there are now 2 tasks in here. Celery is now very well aware of these 2 different tasks as they fit. So I'm going to keep that open. I'm also going to go ahead and open up my Jupyter Notebook again in the root of my repo. So Jupyter Notebook right next to where MBS is, of course. And so I'm going to go ahead and now open that up. I already have it open, so let's go ahead and just refresh on the stock sync page. So what I want to see here is I just want to see the different data items. Right now there's 4,000 items in here. I'm going to go ahead and start from scratch. I'm going to delete all of them, run that again, and now I have 0. So I'll go ahead and put this back in as false. Now we're going to go ahead and actually run the task itself. The way you run that task is by doing .delay that will turn it into an async result, which gets sent to Celery, which we can go and take a look at Celery and see that we've got some of these things going on. Now, I actually made a slight mistake with Celery in the configuration. That slight mistake is very obvious right now. For those of you who are not familiar with this error, it is very much a Django migrate error. So I'm going to go ahead and hit Control-C, close out Celery itself, and then run python manage.py migrate, just to make sure that all of my database stuff is all synced up with all the Celery application stuff in here for the Celery beat server and Celery results. Now that that's in there and is the case, I'm going to go ahead and run that worker again. I don't actually see anything related to that sync call itself. Let's go back into Jupyter again and actually see if anything did sync. Look at that. It actually did sync. So I want to start from scratch again with no errors anywhere, ideally. So we'll go ahead and run this again, run delay. It's a new async result, and there we go. So it's actually showing me the first one is going to be up here, the stock data. That might be the first one I called ever. The next one is going to be this one right here. So this might be the one I just called. There's 3 companies. It iterated through all 3 of them and did a new task for each one. Looking at our shared task here, that's what this delay is doing. It's literally calling a new task up here with this shared data. Pretty fantastic. It's actually running through. And of course, if, like I said before, if we actually had more instances of a Celery worker, they would be distributed against different workers in there as well. Right now, I have one worker that can do a bunch of different processes, especially with the machine that I'm on, the MacBook Pro that I'm on. It can actually handle quite a bit of throughput and also functions that it can just run. But that's as simple as Celery gets. We've got this shared task here. We can run it at any time and it will just run as need be. Now, there are some caveats to this shared task, and that is everything that we call in terms of functions need to be JSON serializable. In other words, I can't pass in the Python object as one of the things I can delay. That's not how it works, which is exactly why I have this company ID in here to make sure that I can still call it and I do the lookup in here. So if you ever need to do database lookups, you do it inside of the shared task that needs it. In other words, if I were to come down to this batch insert stock data here, if I wanted to make this a shared task, I would have to change a number of things about it. Even the data set itself might not end up working in there. So we might have actually reached the limit of the number of shared tasks that I can do and just leave this batch stock insert stock data in here as is. I think this is a better way anyway, so that you don't have to do too much different stuff. But overall, the idea is now we have all of this stuff all synced up. Part of the reason I define the tasks in this way using Django.apps is because now I can jump into models.py and I can do from import tasks, and I can quite literally run after the save method here. I can sync everything, so I can do tasks and then sync company stock quotes .delay to make it async and make it Celery based, and then do self.pk in here, and that of course will run that Celery task whenever I save this company data, which is actually really very straightforward. Now, what I could also consider doing is having a Boolean value in here called like sync data and have the default being false. Then when it goes to save it, we can go ahead and say something like self.sync data being false, like as in it's always going to be false. But in other words, I can also just check if self.sync data is true. Then I'll go ahead and do something like perform sync in here as being false. And then if it is self.sync data, then we would say true. And then basically after all of that's said and done, after everything is all saved, then it runs that sync. So that would be another thing that I could absolutely do in here. Now you could also use Django signals in here for this, the database signals, or you could do that sync data like I did right there, or you could just run it every single time. It's going to be completely up to you. The other part about how this is set up is if I did want to have a start date, going back into thinking about our actual helpers in here. So we have our start date that comes through from our stock quotes in here. right? So we could also think about how we might want to call that as an argument in here as well, or like days ago. All of that can still be based off of models.py using these tasks in here as well. So if you want to expand it or use it in a completely different model, it doesn't have to be in the company model itself, but there's a lot of more options on how we can use these tasks as soon as I start to use them as Django apps like this. And then do keep in mind that all of these need to be able to be serialized in JSON format, which all of these can, because this is going to be an integer, a string, a Boolean value. So yeah, that's pretty nice. So with this in mind, jumping back into our Jupyter notebook, I can run all of the saves that I want to, and it will sync all of that data when I go to save it, which we could always verify as well. The point here, though, is to have a lot of different ways on how we might want to go about creating any kind of data that we might want. So for example, let's go ahead and do Microsoft stock ticker, just something like that, which is, here's the Microsoft Corp, it's MSFT. So let's go back in here and I'll go ahead and create a new one. So we'll go ahead and do objects or company.objects.create, name being Microsoft, and then the ticker being that ticker. You run that created it, and now it's going to sync all of those stock quotes in there, and it does it pretty quickly, and there they are, right? So that's actually the reason why we might want to have that actual trigger inside of here like that. So then whenever you need to, you can just refresh things as you see fit just by saving the company data, which is pretty nice. This also means that if you're familiar with Django really well, this right here could be on a Django view. It doesn't necessarily have to just be in the company model. It could be on a model form. It can be on a serializer. There's just so many different places we can put this task, knowing that Celery itself will pick it up and run it. It's a very, very effective way to drastically improve the performance of your entire project just by being able to sync data in such a way. It's pretty cool. Now I want to verify the stock quotes inside of the Django admin. This makes it a little bit easier to make sure that all of the data is syncing correctly, like we have today's data. So the way we're going to do this is by jumping into our Jupyter notebook first to just clean out the old data and then start some new data. So of course this means that you need to have Jupyter up and running, and then you can see what your stock market count might end up being. And then we're going to go ahead and start from scratch, deleting all of those old ones, and then just verifying that 0 is the current count. Now, if I were to run the market tasks, I should get this async result, and it should actually load in this stock data pretty quickly. But the thing is, mine's not loading in. Why is this? Now, on one hand, this is actually Django and Redis and Celery working like it should. That is, from Django, you can actually send something to Celery in this way. Now, the reason we're not seeing it actually running is because Celery itself is not running. Inside of my VS Code, the only thing I have running right now is Jupyter itself. But the cool thing is what we see here is this async result. This means that Django has let Redis know about it through Celery, but Celery itself, the actual worker process, is not running. This is actually a really good sign that Celery can scale up, but also may give us false confidence that something is working correctly. So every once in a while, if you need to run the function itself, you totally can. That's not something we're going to do at this point. It's just more to point out that, yeah, these async results can be stored inside of Redis, even if you don't have access to it with Celery itself, or Celery's not working. So what we've got in here is we're going to go ahead and jump in and rerun Celery with Celery -A, CFE home, worker. The log level, or -L, is going to be simply info. As soon as we turn it back on or scale up our worker processes, we can see that a bunch of tasks start going. I actually ran this delay call a few times. And of course, at the end of the day, we're going to have a certain set number of stock quotes coming in here. Now, right now it says it's a maximum of 5,000. In my opinion, 4 companies with like 32 days worth of async requests or stock market requests should probably have more than 5,000. So if we look at the API client, we've got a multiplier of 5 minutes. We have a start date and end date and all that. So I think it's actually not doing something correctly. At least that's my intuition based off of the number of quotes that are coming through. And again, we can go into the API itself and verify this as well. that we should be getting more data. There is a limit in here, and the default is 5,000. So the intuition would probably be updating this limit. But either way, we need to verify that some of this data is coming through based off of how we currently have the data being fetched, or the actual results being fetched in here. In part, it's with the API client itself. The other part is going to be in tasks, how we actually called it or how we formulated the to and from date. This is 32 days worth of data, or at least in theory, that's what it is. So one of the ways to verify this would be going into the Django admin, just doing from.models, importing the stock quote one, and also maybe the company model as well. The first one we'll do is admin.site.register of the company model. This, of course, is not the only way to register the actual models themselves, but it's the way we're going to use it right now. Next up, we're going to go ahead and bring in a class for the stock quote admin. And this is basically saying what we want to put in to display the stock quote model admin itself. In other words, if I went ahead and did something like list display, I can do company underscore ticker, and then I could do something like close price, and then I can also do time. Okay, so these are all fields, of course, directly correlated to the model itself. We've got our close price, we've got time, those are two of the fields, and then we had company and then two underscores, which is going to this model itself and the ticker for it, just to make it a little bit easier to read that one. Next up, I'm going to also do a list filter for some of this data, which of course is going to be the ticker itself and then also the time. I'll point out what each one of these things do in just a moment. Then we're going to go ahead and do admin.site.register, the model itself, and then the model admin we want to use. Now, for best practice, you would also do class meta in here and say something like model equals to the model you're using. But of course, if you leave that out, registering it will put them together. And you could then reuse this in other models if for some reason they have the exact same fields, which they don't, but that's the idea. So now that we've got this, we have two processes running. We have Jupyter and Celery. We finally need to bring in our Django project in here. And so I'll go ahead and run Python manage.py run server. Now, of course, if you need an admin user again, if you somehow deleted the database, now is a good time to create your admin user with the create super user call like that, and then you'll go through all of those processes. Now, if you see just the username, there's a really good chance that you already have a super user. In other words, sometimes you'll have a default in there. If the default's not in there, there's a good chance that you already have that super user created. So now that we've got Django running, I'm going to go ahead and open it up inside of my browser. I'm going to jump into the admin, and then I'm going to go ahead and log in. In my case, I actually did this in the test, so I did log in already. And here we go. So we've got our companies and our stock quotes. If I come in here, I should be able to see all of these stock quotes that are currently available. And so what I see is the time is at October 23rd. Today's November 12th. That actually doesn't work really in terms of the time. The time is incorrect. And so if I were to change this, I should see something from at least yesterday, if not, the most recent Friday, if it's like a Monday, so I want to be able to see today or the last 7 days. I'm seeing nothing. So the thing that I think about this is I'm like, okay, well, clearly I'm doing something wrong with the lookup. As I alluded to earlier, it's probably something wrong with all of this data. So there's a lot of different ways on how we can solve this. One of the ways is by going into Polygon itself and updating some things about it itself, right? So updating, let's say, the parameters in here. I could come in and do a limit, and we can set this limit to 50,000, right? I'm going to go ahead and comment that out for a moment. And then the other part of this would be in the tasks themselves on how we actually sync the stock quote data. Right now we have it at 32 days. That's probably too much. We probably don't need to sync 32 days worth of data because we have a worker process that can sync daily data or weekly data. So that's another area that we probably want to update and make sure it's working. But at the point of this one, we have now it in the Django admin, so we can start solving some of those problems that are happening. Now, of course, we could also do this inside of Jupyter Notebook, and I would recommend that you play around with it in there as well. But in my case, it actually gives us the opportunity to improve the client and all of the shared tasks to make sure that they are working as we intended, not just working in general. Now we're going to bring in our scheduled daily sync. What this is going to do is it's going to adjust how our tasks.py work in conjunction with Polygon.py. Now on one hand, we can update the Polygon's API client limit so that we get more data. Now, when it comes to a daily sync, we probably don't need to get that much data. The default limit is probably enough. But you could always just add in this limit in the parameters of Polygon. This is probably true or similar to Alpha Vantage, just making sure that you're getting as much data as possible so we don't have to do pagination. We don't have to do multiple lookups to grab any sort of data that we're looking for. So as soon as I update this limit and understand that pagination is going to occur at some point, I want to then also update my task, how I'm actually doing the lookup in terms of the dates themselves. So right now what we have is we've got this days ago argument in this sync company stock quotes data. So that days ago thing, I also want to bring in the sync stock data as well and have that as an argument as well. But now we want to think about this in terms of a daily sync that we're going to be doing. So the maximum is probably like 5 days, more than likely 1 day or 2 days. So I'm going to go ahead and leave it in as 2 days as the default argument, which means that I'm going to bring it down in here and pass it into my delay as well. Just making sure that I'm doing up to 2 days. So as soon as I do this, I'm going to go ahead and save it for a moment. I'm going to jump back into a couple things. First thing is I need to actually restart my tasks themselves. So I'm going to go ahead and close this down. Celery tasks have to be rebooted when you change the code itself. Like in the case of this, we changed the shared task to have a new argument in here based off of these days, which will now go into this old one. Okay, great. So now that we've got these 2 days ago, this might actually be plenty in terms of our Jupyter Notebook, which is still running. So I'm going to go ahead and do kernel, and we'll restart and clear all outputs. And once again, I'm going to go ahead and start from scratch, being true. And now I'm going to go ahead and sync all of this data. Okay, great. So I'm actually running this on a Tuesday right after a holiday, so there's a good chance that you might not have that much data. But as soon as I change the limit, I actually get so much more data than I was getting. So it should only be 2 days worth of data. So if I go back into the Django admin now, I should see something along those lines of 2 days worth of data for now 4 companies. Now the dates are exactly what I expected. It says November 12th, which it is November 12th, but these are UTC times. We got to keep that in mind. So this is actually yesterday, even though for me, it's today. This is the date for today, and this is in the future of what I'm doing. That's, of course, because of the UTC time zone. But the point here is it's now showing me stuff for this month. It has a lot of data for this month. And, of course, in the Django admin, it does have pagination in here, as we can see. And there's a lot of stock quotes going on overall, which is great. So we now have a way to do a daily sync if we wanted to, just based off of this minor change. So if we actually come into our periodic tasks here, what we can do is a periodic task. We create a new periodic task, and this, of course, is going to be stored in the Django admin. We can grab the task we're looking for. In our case, it's sync stock data here. And we can go ahead and do our daily stock market sync. And we could run this every day, even though on the weekends, it doesn't really make sense. So you could always do a cron tab schedule if you wanted to change how this is done. Now, for me, I always recommend for anyone who's new to cron tab, just go to crontab.guru and play around with it if you want to do a cron tab schedule, which is a little bit more advanced. Instead, what we could do is not a cron tab schedule. Instead, we can do an interval schedule, and we can run this on a certain period. So let's say, for instance, we wanted to run it every 6 hours, which may or may not be something you want to do. That's not exactly a daily sync, but it's closer because it's only going to run a few times every single day for all of our stock data. Do keep in mind that the more you run this, the implications it will have on all of your API lookups, however many lookups you end up doing. So as soon as we've got this, I'm going to go ahead and save that. That is now going to run every 6 hours. Now, every once in a while, you might want to do another one, which you would call a one-off daily sync. And all that means is you grab that same data, the same exact arguments and everything. We say it's enabled. You can use an interval schedule again. In this case, I'll just go ahead and do every 1 minute. But now what I'm going to do is instead of it being every minute, I'm going to make it a one-off task. So notice that if I check that as a one-off task and hit save, it will run immediately. And you see that it's enabled. If I refresh pretty quickly, it will start to say disabled, assuming that it actually ended up working. And so it's not working. After a few refreshes, it's just like not running either one of these tasks. And this has to do with the fact that we only have our worker going. So if we jump into the terminal inside of our Celery, we can see that if I close it down and press up, I've got a worker running right here. So in order to have the scheduler working, whenever you want to schedule anything, whether it's a runoff task, whether it's an interval schedule or cron tab, any of those things need to be done using a beat server, a Celery beat server. And there's a couple different ways on how we can do this. Number one, we can actually have a single worker and a single beat server running at the same time. Having a process like this is nice if you only intend to have one worker and a beat server. So at any time, you will only want to have one beat server, but every once in a while, you might want to scale up the number of workers. Remember, workers actually do the tasks themselves. A beat server is just really monitoring to make sure that a task may need to be run. So that's one way to run it, is just by doing --beat. Another way to run it would be to do Celery -A, CFE home, and simply beat. This is a new process that is for the beat server itself. Notice that it's going off of the database scheduler and it's running off of the same Redis broker. All of those things make a whole lot of sense. But of course, even with the beat server working, I still need to have a worker process running as well, which we can add another process to do that by just doing Celery -A, CFE home worker, and then the log level again as info. As soon as I do this, the actual tasks should run, because the beat server is going to make sure that they are running. And in this case, I don't actually see one just yet, but let's go ahead and jump into our admin. And we now see that there's a Celery cleanup process that's in here. Let's go back into our daily sync. I'm going to go ahead and add a start time to literally right now. We'll go ahead and save that and see if that ends up triggering that one. And it looks like it did, like almost immediately ended up triggering that one, which I can now refresh. And there we go. It actually did run this one in there. So as soon as I added that start date, it then ended up working. So whenever you want to run these one-offs again, you need to enable it, and then you might have to actually change the start date to literally right now so that that runs. And it will run every single time you need it to. So if you ever need that sync, that's the way you go about doing it, just to make sure that it's on, and you just jump into the periodic tasks for that. Now, of course, going forward, we're going to also see this daily stock market sync happening, and all of that will start to come out as well. And of course, you can always verify that these things are working by going into the task results themselves and taking a look at making sure that these tasks are going on. Now, there's more customization that we might want to run with those things, which is what I'm going to leave out for now. But the idea is we have these periodic tasks working, which require us to be able to, of course, have a Celery task function, right? So something like this. Then also to have a beat server as well as a worker. So I'm going to go back into just make it one thing. So it's a log level of info and then --beat so that there's one worker and one beat server all running in the same thing. I don't really need to have two. I could do that, but it's just not necessary. It's nice to have them both in the same place, which we can see that it is running with this info beat starting, just like that. Great. So now we have a way to schedule our daily tasks, and what we should be able to have now is all of these old stock quotes in here. So one of the things we might want to do with all of these stock quotes is we actually might want to have historical data. Right now, I don't have any historical data. I just have some data in here. So that's one thing that we might want to start to update. The other part is just adding in new companies. When you add a new company in, maybe that's another thing you want to have historical data. Now, there's a lot of different ways in how we can think about automating this, but what it will ultimately come down to is creating periodic tasks that we want to run, whether it's on a schedule or one-off when we decide. So what I want to do now then is actually update so I can actually have historical data working without really overloading the API or the database or the worker process. Do it in as efficient way as possible with all of the companies we might want to include in there. Let's take a look. Now I want to grab historical data for any given company, and I always want it to come up to today, whatever that might be. So one of your intuitions might be, okay, let's jump into the sync stock company data and actually just change days ago to like 500, and that will give me the last 500 days. But this actually creates a new problem with our API specifically. So with our third-party API clients, there's going to be a limit to the number of results it will give us on any given range that we're passing. This is true for any API. And realistically, even if we were to get hundreds of thousands of results from the API itself as one single request, it's not going to be that efficient to then insert it into our database. It's much better to also batch out how that ends up working. Now, the way we batch it is by the dates themselves, which this will be a lot more clear once we actually do the years of historical dates. So the idea then is if we actually jump into Python, I want to give you an example of this and basically say something like years ago being 5. I want to get data from up to 5 years ago. So the way I'm going to go about doing this is I actually want to call the API itself based off of months. So I want to grab that month data. So the way we're going to do it is by doing something like for I in range, the start day, which could be 0 days ago, or we could start at 32 days ago. So starting at the number of 32 would start 32 days ago then, as we'll see here soon. Then the next one is going to be the amount of time we want to run, the actual endpoint as to what we want to do, which we would say something like 30 days in a month times 12 months times the number of years, in this case years ago. And if I were to keep the range just like that, we will see continuous values, as in 32 to however many this is. If we print that out, we will see all of those values. That's not how I want to chunk it, because these sync company stock quotes, if we do it correctly, could go based off of a number of days. As in, instead of just days ago, it could go off of 30 days or 40 days or 32 days or whatever range we want. So going back into that range, what I can then do is chunk it, and we could have it chunked at something like 30 days. Now, I realize this might actually cause a little bit of an overlap, but this is actually how we're going to do the API requests going forward, where we can now see that it's chunking, it's jumping up 30 days at a time. So in order for this to work, we need to update our sync company stock quotes just slightly because of the date ranges. So we don't always want it to be up until now. We want it to be based off of the past for sure, but the end date won't go up until now. So the way I'm going to change this is by updating our to date just being based off of our start date. So in other words, our to date now is going to be going like this. We'll go ahead and say our to date equals to our start date plus that same time delta, and then we'll just go ahead and add in an extra day in there just to make sure it's just covering a bigger range. This is our new start date, or our to date, which is basically the same thing as it currently was, but now it's just slightly different. So this end date here, I'm going to just change this to being now so that it's not confusing, hopefully, or too confusing as to what's going on. So in other words, we go back in time with the start date, and then from that start date, we create the end range, the end time, the to date, and that's what we get. So this is almost going to be the exact same thing, but now that we have this time delta, we can go back to the days ago being 1700 days ago, and then it's just going to add an extra amount, or 32 days on top of that. So now we have a way to build out this historical stock quotes. So very similar to the sync stock quote data, we're going to come in here, paste this in, and again, it's still sync stock quote data, but it's going to be a little bit different than what we've seen before, because now for each company, we will then want to go in the number of days that we're going to be using. So this is going to be years ago now, and let's go ahead and leave it in at 5 years. So once again, within the company IDs, we now want to go through and do for I in range. Right, so starting at day 32, which is going to be our new days ago, the start date of that range. So we can also say something like the reason it's 32 is because of this one as well. So we can just keep it simple. Let's keep it simple and leave it at 30 days for now, which doesn't necessarily give us the best results in here, but what we'll then do is we want to go ahead and build out the batch itself, which is going to be the number of days. We'll go ahead and say days starting ago equals to 30 days times 12 times years ago. And so there's that. And then we want to do our batch size, and we'll go ahead and give this equal to 30. And there we go. So now we have our new range in here. So I'm going to go ahead and tab this one over. And now days ago is going to be related to simply I. And so now we've got a new one that's going to be sync stock historical data, or maybe sync historical stock data, something like that. And now it's going based off of the same companies. We could always update this as well if we wanted to. We could also pass in company IDs in here as a list. And we could then say something like if the length of that is, greater than 0, then we can filter this down a little bit more. So we would do something along the lines of QS equals to all of these companies by default. And then I'll come in and bring this down a little bit here, put it down there to get that same values list based off of the QS. And then of course, if the length of those IDs are in there, we would then say QS.filter ID in equaling to the company IDs. This would allow us to have, more specific companies if we wanted to do longer than those years. But overall, this is still giving us a lot of that same data and based off of the number of days ago. Now that we have the endpoint also based off of days ago, then we're in really good shape for this historical data. Great. So the actual range itself, maybe you start at 30 days ago, maybe you start at 32 days ago. Either way, either one will work just fine. So now that we've got that, let's go ahead and save it. And we're going to go ahead and restart our worker and beat server. Just let those shut down. Again, I have them both working in the same spot. Now I've got this sync historical stock data in here. Let's go ahead and jump into the admin, the Django admin, of course, into our periodic tasks. We're going to go ahead and do, historical sync one off, make it enabled, interval schedule every minute, one off task, start time right now, and we'll go ahead and hit save. And we want to give it a name of this one, and that means that I actually just need to grab the historical data itself because I have one registered. You can also just hard code that, which we'll see in just a second. So I'll hit save and continue now. With that task in mind, this is the hard coding version. It's just dot notation. So this basically fills that out for you. But once this actually runs, if I refresh, it should disable pretty quickly. And what we'll end up getting is a lot more stock quotes. All of this data over that 5-year period will start to be in here. So you'll be able to actually have all of that historical data, which is actually super cool. And it's going to happen really fast. Of course, the intervals are 5-minute intervals, which you could verify in a bunch of different ways. But now we've got historical data for 5 companies, and it's all of the data we might want. Really nice that we can do all of this. So the next thing that I want to do is I want to update the display here and then actually add in a range so I can see the stock quotes for a company and a range based off of a couple other packages. Now that we can sync historical data, we're going to start to have a lot more of it, especially with only 4 companies and dating back to 2021, I can scroll down and I can actually see I have well over 700,000 instances of stock data. So there's a couple challenges we'll face going forward. One is efficiently doing these lookups and using caching to make sure it happens a little bit more efficiently than what we've got right here. The other one is how we deal with the date objects themselves. All of them are in UTC, or at least that's what they should be stored in on our system. Our Django admin is also in UTC. We actually want to keep that value true so that the consistency stays no matter how it's displayed. What we want to do now is take a look at how we can display it differently, but then actually narrow down these results based off of those different changes. And it all comes down to the Django time zones like utility function that we'll end up using here in just a little bit. So by default, we actually have useTZ being true. So something that's cool about using the time zones inside of Django is it's actually fairly straightforward to change what's being displayed to the user without changing the results in the actual database itself. So now that we've got that out of the way, let's go ahead and actually modify this time field here so that we can see it just a little bit differently. The way we're going to do this is by jumping into the stock quote admin here, and I'm going to define my localized time, and it's going to take in two objects, self and obj, and then we can return back an object itself. So inside of the display here, I can swap out time with localized time, save that, and then we can refresh in here, and what we would end up seeing is the time field being changed to something different, which just says localized time. But it's basically the exact same thing, but we can actually do one more step here, and that is using the str string format time, or strf time, and then passing in a valid string format within the Python datetime object, which in this case, I'm going to go ahead and just give it to you. But you can always look these things up with going into the Python datetime and doing a quick search for that, and then going into skipping to format, and you can see all the various formats in here. Feel free to play around with them, but the idea is I now have this capital or %Z, which will give me something interesting, and that should say on these as simply UTC. So I actually did refresh the admin. It does take a moment, but there it is. Now, part of the reason it's taking a moment is because it's calling obj.time on all of the items that are coming through here, on all of the query set items that are coming through here, which adds some, complexity and also compute resources needed. It needs to be able to compute all of these things on our machine to make sure that this is working. So with this in mind, I want to actually adjust the time zone to being based off of Eastern Standard Time. So the way we're going to do that is we're going to go ahead and create inside of localized time. I'm going to go ahead and say TZ name equals to US and Eastern. Now, before I used PYTZ, I'm going to go ahead and show you another one called the zone info. And zone info is built into Python, at least newer versions of Python. So we're going to import zone info, and then we're going to do dot, and it's capital zone info. And then we pass in this TZ name just like that. So in order to turn this obj.time into this time zone, what we just do is say local time equals to obj.time.as time zone. And then we pass in user TZ. And now we can swap out obj.time to local time just like that. So I can save it, and then I can refresh in here, and we will now have a display that's based off of Eastern time. And so we see right now it was at 9 something, now it's back to 5:10. So that's actually pretty nice. We can now see that it is on Eastern Daylight Time. So it's not actually on the correct Eastern Standard Time, which is what we're at right now. Now, this, I think, is because of the time of year. It actually is Eastern Daylight Time. Nevertheless, we now have a way to reformat how these dates are coming through. That's really nice, but that's just formatting. That is not actually changing the time zone in terms of Django itself. In other words, if I were to bring back the time field here and then refresh, what I will see is the newly formatted one in Eastern Daylight Time or Eastern Standard Time, but I'll also see the UTC value as well. So there is a way to actually change the UTC value, which is actually very obvious inside of Django itself. If you go into Django, what you can see is there's time zone stuff, but you can also do time zone, do a quick search for timezone.activate, and you can see there's a way to activate different time zones. Now, there's a way to do it in the more advanced way and more complicated way. There's also a way to do it in a little bit easier of a way. The easier way would be to come into the Django admin and define get query set. And inside of this get query set method here, this is where we can actually set the time zone, quite literally using the same things. So what I'm going to do here is I'm going to grab this TZ name here and also the actual time zone info again, like that. And then I'll go into Django. So from Django.utils, we're going to go ahead and import time zone. And then we're going to just run the timezone.activate command. So timezone.activate, and it's going to be the user time zone, or maybe the stock market time zone. But with that in mind, now I can actually save it, and then we'll jump back into the Django admin. We'll refresh in here. These two should now display the same time. One will actually show the time zone, the other one will not, right? And there we go. So this is going to be true whenever we're looking at this time zone. So this is activating it as if it was the end user. There are more complicated ways to allow the user to select this, but that's something I'm not going to cover at this time. The Django documentation for time zones actually has something that's pretty nice for this, but it takes a number more steps to make it work and make it work well to where you actually can allow the user to have some sort of drop down in there. Now, a big part of the reason that we want to change these time zones too is if we want to end up using something like the Django admin range filter, so we can actually filter by a specific range. So now let's go ahead and add those two things in, as well as the Django admin interface, just to make it look a little bit better. So the way we're going to do this is by updating our requirements.txt to a few new packages. The first one is going to be the Django admin interface. The second one is the Django admin range filter. So with this in there, we're going to go ahead and open up a new terminal and just run our pip install-r requirements.txt. Let those install, jump into settings.py. The very first one, the one that's basically required for this, is going to be simply range filter, and that's got to go at the bottom. The next one, the one related to the Django admin, needs to go on the top, I believe. It might actually not. You can play around with it. But the idea is we want to have it above the Django contrib admin based off of their docs. Perhaps there's a reason for that, perhaps not. Nevertheless, we now have the admin and color interface in here. So the next part of this is to actually run our migrations. So let's go ahead and run python manage.py migrate. Hit enter. This will run some migrations for you. In my case, I did some tests already and it didn't actually run the migrations, but yours most likely will based off of the admin interface. As soon as we do that and change it, we go into the Django admin, we can see that it actually looks quite a bit different. And that's because of, well, that admin interface. We can change the theme, we can change the colors, we can do all sorts of cool things in here in terms of our styling for our Django admin. That's really the reason I brought it up, is so that you can change it and make it more of your own, while we are also using like the Django range filter, so we can go in our stock quotes, look up and actually filter down our data just even more. So jumping into the Django admin then in admin.py, we're going to create a new range filter in here. So this range filter is going to be based off of time as well. But the nice thing about the Django admin is we can do something like the field name itself and then bring in a filter itself. So this is how you would customize or bring your own custom filters in. In this case, the filter we're bringing in is from rangefilter.filters. It is the date time range filter builder. And so the way you use it is just like that. This is so that this filter is applied to this field right here. So as soon as we save that, we can refresh in here and we now should be able to filter things down based off of the time zone that we have activated. So if we came in here and just selected yesterday in my case, and we can start yesterday at 6 a.m. and then yesterday to, let's say, noon. Let's go ahead and do a quick search for that. This should filter things down based off of that Eastern Standard Time and all of that. Now, do keep in mind that the filter is up here showing us exactly how it's attempting to filter it, right? And so one of the things we might need to actually diagnose is if this is working correctly on the database side. So this is something that we'd have to do outside of the Django admin. So what I want to do though is I'm just going to do a quick screenshot of the first 4 things on here, which basically have that same time zone here. Notice it's to Google, to Apple. So hopefully what we'll get is the exact same thing when we go to change the query set from US Eastern to just simply being the UTC value. So once we run the UTC value and do a quick refresh in here, I think that the data is going to be different. So let's go ahead and take a look. I'm going to go ahead and open up that screenshot I just took. And right away, I already noticed that it seems to be different. So between 6 and 12, we've got these things in here. So the Eastern time is different than this one. And also the results are slightly different, right? So hopefully no surprise there because it's a different time zone. As you might imagine, there's a lot of things that can go wrong with this, which is why you might consider just always using UTC time for all of this. But now you can see how you can do both things. Either way, it's probably a good idea in the Django admin to have the local time with the time zone showing up, or basically any time you're rendering out that has a time zone, just have it be rendered. The other part about this too is we can actually create something called a read-only field and bring in that localized time as well as the original time, save that so that when we go into any given stock item, we can see those 2 items as well. And notice that this one is just slightly different, but still different nonetheless. Notice that it's also showing Eastern Standard Time now because that's true about November 11th. It is no longer daylight time. So that's the point here, is these time zones make a big difference. This also makes me think, hey, I probably need to bring in that raw timestamp in here as well so that I can audit it at any time. Now, the big part of this is really the fact that these things are sequential and they are changing over time. So the time series data is still going to be good even if the time zones are slightly off. Because if they are slightly off, they are going to be slightly off consistently based off of how we're bringing it in. Now, this might also be another opportunity to, actually check that data based off of another API service like Alpha Vantage, like we've already seen. But those are things that are just well outside the scope of this video. Now that we've got these things, we want to actually go down the path of just building this out a little bit more. One of the first things is definitely bringing back that original timestamp and making sure that that's in there as well so that we have both sets of data, the full raw data, as well as the augmented or modified data as well. Modifying the source timestamp from the API services made a whole lot of sense when we were doing it. It made sense for 2 reasons. One, both APIs had different approaches to using the time itself when that data was coming through. The other is efficiently and effectively storing this data into Timescale Postgres required us to make at least a slight change to the field name, if not more than that. In our case, it actually was more than that. So it kind of made sense, we don't need this timestamp anymore. But now that we've been playing around with the time zones themselves, this actually might be a good opportunity to be like, well, was that correct thinking? Should we actually have stored those original data points so that we can now verify them against our new admin, which is what I'm going to do. I want to do this as a way to ensure that we've got this raw data in the future. I might not be auditing it now, but in 2 years, maybe I want to audit it, or maybe I have other members on my team who are challenging the actual time itself because we don't have control over this time. Now, if we had a bunch of sensors of our own, we probably wouldn't need to store the raw data because the raw data would be the actual timestamp itself. But since we don't have that, I want to update my transform here and do something like raw timestamp and then just bring in that result value that's coming through. And that's going to be our new data set. Now, of course, this is only for Polygon. If we actually take a look at the same idea in Alpha Vantage, that raw timestamp is different. It's coming in from a different time zone. We did all sorts of things with it. So I need to bring in that timestamp string instead of what we had before. So this also shows us another reason as to why we never stored that in the first place, is because the data types are simply different. The formats are simply different. So going into models.py, how would we have decided that? Well, it's hard to say because there are other API services out there that can get stock data. So to me, I'm just going to go ahead and put in raw timestamp in here and do models.char field and do max length of, let's say, 120. And then we'll go ahead and do null equals to true and blank equals to true. Realistically, they should not be null, but since we already have data in the database, we can leave it as null. This would also be a good time to scrap everything, start with a fresh new database, and then making sure that these are not null or blank. But since we are, just experimenting and doing a lot of trial stuff, I'm going to go ahead and leave it like that, and we'll run python manage.py, make migrations, and then we'll go ahead and run python manage.py migrate. With this in mind, I also want to go ahead and start Celery again. So we'll go ahead and do Celery -A, CFE home, worker --beat -L, info, hit enter, and there we go. So we should see the beat server starting. It looks like it is, and we've got some info going on. So that part is working as well versus just this blue part. Okay, so now we've got that, and we've got Django running. I'm going to go ahead and start Jupyter now in the root of the project itself. The only reason I'm starting up Jupyter is so that we can do a stock sync. Okay, so one of the things, of course, I could do is just say start from scratch being true again and just delete all of this old data just to make sure that everything's coming through, which of course is what I will end up doing. Now, the actual historical stock market data should still be in there. I should be able to call it. In fact, it probably will be running in the near future as well. So that also is kind of cool too. So there we go. So let's see here. It looks like it's attempting to do things, and there it goes. Sure enough, it did. And in a short amount of time, it's starting to gather stock market data from the actual Celery process that we called just a moment ago. But we want to take this a little bit further, and let's go ahead and grab that stock quote historical data again. So going back into our stock quotes, we probably won't see nearly as many results this time. It's probably quite a bit less. And sure enough, it is, just like inside of the actual stock data itself. How many companies we have, let's just verify. Still 4, that's good. Next up, we're going to go ahead and bring in the periodic task, and we'll go ahead and do our historical sync one-off. We will enable it, and we will go ahead and say now at this time and hit save. And of course, what this will do is bring us a lot more stock quote data in here. As we'll start to see propagated here in any moment in terms of the stock quotes themselves. So jumping on over into that. The key here is just to make sure that that stock data is working, which I probably should have checked in the Jupyter notebook. I probably should have just grabbed one of the quotes themselves just to see if that raw data is coming through. I think it probably will. It just might take a moment for us to grab it. So let's go ahead and grab one of the values that came in, and we should see there's our raw timestamp now. And so one of the things you might want to do is turn that raw timestamp into a datetime object so it can be compared against these other things. If you are so interested, it's going to look something like this. We would grab this localized time here. We would then go ahead and change it from localized time to display raw time or something like that. Put that in as a read-only field, and maybe even the raw timestamp as a read-only field as well. Then, of course, what we need to do is use these same ideas, but turn our original raw timestamp into the time zone itself. So this is actually where the source of the data is going to make a big difference, right? So if we were using Alpha Vantage, this raw time would be a lot different than Polygon. And so maybe we want to actually have something like define transform our time zone or our raw time stamp and take in the result or whatever we're trying to transform. We might want to have that same function on both of these things so that we can then reuse it. That is not something I'm actually going to cover at this time. Adding the transforming of these raw timestamps is really just outside the scope of what we want to do. But the idea, of course, is just doing the same process all over again, but for what's stored in the Django model itself. So if I were to do it, it would be something along these lines where we brought in our time zones here. And so we can still use the datetime object, but basically turning in the obj.raw timestamp, and this would have to be the data is that, and then we would have to turn it into a float because it's a char field or a character field. So we would have to do something along these lines, and perhaps using this user TZ here, which would be like that. So that's essentially what we would then end up having to do in terms of the timestamp itself, and then we could display it. Now, again, I'm not actually going to show that one because it's just outside the scope of this one, but having that raw timestamp is still something that we're going to want to keep regardless of whether or not we are showing it on, to actually check between these two. Because the other thing is you can go ahead and say something like Unix MS timestamp to UTC, right? So you can do that quick search and do current millis and just paste that in, and you should see the same data that's coming through in there. So let's look at this one. It says 1655, May 15th. So now if you jump back into the Django admin, we got May 15th, 455, which is the same thing as 1655. So it's working correctly. So we actually can see that now. But having this raw timestamp allows for that auditing to happen, even if it's fairly manual and you're just spot checking it. Even spot checks can sometimes notice a trend or a pattern that's failing us. Of course, in this case, we used so much automation to make sure it happened. So the key thing of adding in this raw timestamp was really just to be able to audit it in the future. Because as you're collecting this data, just making sure that you're storing that will be, I think, really, really helpful in the future, whether it's Polygon or Alpha Vantage or whatever. You could even say something like help text being a, something like non-transformed timestamp string or int or, probably string or integer or float, right? There's not a whole lot of data that's correct there in terms of what it can be. It's a little too vague, but it at least allows us to check this data at some point in the future if we really need to, which in the case of stock market data and timing, it obviously makes a whole lot of sense to be able to have some sort of backup that's right inside of our database. So if we do decide to switch to a different API service at any time for whatever reason, we can, and we'll still have all that historical data and the correct raw data as well. Realistically, all of this data is the raw data in there. So one of the other things that we probably want to do is make sure that all of these are read-only fields inside of the Django admin so that we actually never touch them or change them. I'll leave that up to you on doing, but at this point we now have a lot of these stock quotes well flushed out, as well as extracting all of the data we will need going forward. Now we're going to go ahead and analyze some of our stock market data using a term called moving averages. This is an indicator over a window of time on how any given stock price is doing. So what the average price is going to be over some amount of time. Now the way we're going to do this first is with Python, a manual look at it. Then we're going to start using the database functions that Django has, as well as what Timescale and Postgres can help us with. So the idea then is to start off, we actually grab a query set of all of our stock quotes, and then we just build out a total here, and then we can find out what that average is by grabbing this total and doing qs.count, which gives me all of the number of quotes that are in there. So if I were to run this, what I get is this value right here. And so this actually takes a long time and it's not that efficient. If I were to run it multiple times, then it doesn't. But the very first time you do it, it will take some time. So that's the average price of the stocks that I have, of all of the companies that I have. If I wanted to parse it out into individual companies, it's going to look a little different. So to do that, we use from Django.db.models, we import the AVG function. This is a database function that can help us with those averages. So once again, we can take these query sets or that query set value. I can also do dot values. I actually have to do dot values with this data type. I'm going to bring in based off of the company. So I want to separate it out based off of the company. And then we'll go ahead and annotate the average price equaling to AVG of the exact same field that we just used. So AVG can work on fields that actually can calculate an average. And so this right here is going to group all of the data to the company and give me the average price. If I were to hit enter, let's go ahead and make sure that it's imported. We run that. Now we can see all of that average price data given the query set that is actually showing up. So of course we could take this a little bit further and say, okay, well now I want it to be based off of a certain time. So what that means is I want to filter down that query set. Let's go ahead and say days ago being like 30. So that means that now is going to be timezone.now. And then can go ahead and say something like start date equals to now minus time delta days being 30. I'll add the imports in just a moment, but then we can also do end date being just simply now. Now the reason I have a start date and end date is because a lot of times what you'll end up seeing is a filter, and this being time in the range of start date and end date. It's a really easy way to just range down that query set. So of course we need a few imports here. I'm just going to go ahead and copy and paste some of these imports that we will be using here very soon. F, row, range, and window are coming soon, but we've got time zone, time delta, and decimal. So now if we run this, what we should end up getting, assuming that I have a trailing parentheses there, I have a different query set altogether. So I can actually take a look at the count. It's a lot less data in there because all of these stocks, all of these companies haven't generated that much data. But once again, if I were to do .all and see what that data was, that's a lot more data. It's over 600,000 for me at this time. Yours might be different than that altogether. But now 19,000, this is going to be a lot easier, a lot faster to get that new average that's going on with the different companies. But now I can actually annotate all of these averages going in here. That's great. But these are average prices for the entire month. They are, in theory, sort of moving because we can change the day, but they're not what a moving average actually is. A moving average is based off of like the last however many in a certain window. So let's say, for instance, we want to get the moving average of the last 5. What I'm going to do here is I'm going to start with a count. And I'll go ahead and just say my rolling QS is equal to basically this count. So I'm going to do a query set, and then I'm going to go ahead and cut it down to that count. But the thing is, I want to make sure that I'm getting the most recent ones. I want to make sure that it's the last query set item. So the way I do this is by doing a reversed order of time. And so what we get here is now the most recent ones coming up first. And so this is okay, but the problem with this is if we look at the IDs here, we've got a whole range of IDs. This is absolutely a problem as well. So I'm going to go ahead and come in and say ticker equals to Apple so that hopefully the range of IDs are not that big. So I'm going to go ahead and filter this down and say company ticker equals to, the Apple ID there. And now if I go in, I should probably be able to see this out. But what it's giving me now is, this should say company __ ticker. Now what we've got is hopefully IDs that are sequential. And what we see is the most recent entry is at the very top. We actually don't want it at the very top. In this case, we want it at the very bottom. So the only way to really do this is by turning this into a list, at least with Python directly, turn it into a list and then reversing that list. So we come like that. Now, if we look at the reversed version of the list, 1 is at the very bottom. It was at the very top. Okay, so why is it that I'm doing this? Well, I want the very last price to show up very last. So now, very similar to what we did up here, we're going to go ahead and say the total is 0. Now I'm going to go ahead and use enumerate so that I know which item I'm in. So for I in the actual values that I'm going over, which is going to be obj in the rolling query set. So this is going to be the last 5 things, which we can verify by just going through obj.id and then obj. Maybe something like our close price. Right. And so if we were to iterate through this, we should be able to see all of these things out. Cannot unpack the non-iterable stock quote. Oh yeah, so we need to do enumerate here just to make sure that we get I being set. And so it gives us the index value. If I do I plus 1, it just gives us the last 5. So 1 and 2, 3, 4, 5. All of that stuff makes a lot of sense with the averages. So if I were to do the average now, I'm going to go ahead and add to the total. So the actual total itself, I need to go ahead and do plus equals to obj.close price. This again is the rolling average, which means that it's going to take the grand total divided by its current iteration. So that's why I'm doing that grand total there. Very similar to like what we did up here. This is taking that grand total and then dividing by what's happening at that time. But since this is rolling, it's going to grab it at each individual window, which hopefully makes sense, but it might not. So I'm going to go ahead and do I plus 1, right? So I plus 1 needs to be in there to get the average, just like what we did with that print statement. And then now I can say the average at that time. And so what we see is this is now the rolling average over time. The very first one is exactly the same. There is no average. The next one combines these two values and then averages them. The final one, takes all of these values and then averages them. And that's how we get this number right here. But this, of course, is using Python, and it's not actually that efficient, right? There's a number of things that are good about it, but there's a number of things that are not. So what we need to do is we need to use a different approach for our rolling average. The most important thing is this right here, but keep in mind the average itself still needs all of these other data points, right? Because we're trying to get the average over, in this case, 5 iterations. We are going to need to change the average at some point, but for now, the window itself is over the last 5 whatever. So the way we actually go about doing this is by using window, then the row range, and also something called F. Now, this is where the rolling average is what we're going to end up using in the long run. So I'm going to go ahead and copy the query set again, the one that we had, and this time I'm going to go ahead and bring in the ticker right at the very beginning, so we make sure that we have both of those things in there with that filter, just so the next part makes it a little bit more straightforward in terms of the query set. So what I want to do here is I'm going to go ahead and say that my A value, or my moving average value, we can also just say MA val, is equal to, we're going to grab our query set here. Now we're going to go ahead and use something called annotate, like we saw before. We saw annotate up here. We're going to do some functions on our database now. So what I want to do is I want to do my moving average as in MA, and I'm going to start it with just simply MA, moving average, and then the actual values. So we want to declare a window. Now, the reason we're declaring a window is so that we can get a certain number of rows. So right off the bat, we want to declare the frame as well, being the row range. And this row range is going to be based off of the amount that we want to get. So once again, I'm going to go ahead and do this count. But this time, I'm going to go ahead and do my frame count, or my frame start, and this is going to be based off of that original count, then whatever it is minus 1. This is going to the index value now, very similar to what we've seen, but of course I want to grab the negative version of this. Okay, so this right here is critical to get right, because it's a lot like grabbing the up to a certain point and then reversing it. It's basically doing all of these things inside of a certain frame. So we're going to go ahead and say start is equal to that frame start, and then we're going to go ahead and give our end being 0, as in the most recent one in there. So that now gives us our window of opportunity to grab basically all of this same data. So we're almost doing the same thing, but now what I want to do is I want to set what this MA field is going to be worth. So the way we do this is by doing an expression, and we set the expression being equal to AVG and the close price. Okay, no surprise there. That, of course, is going to be the close price that we've had. This right here is going to go on the entire query set, that entire query set, and that is important. It's also important that we make sure that the order by is going in the correct order of time. So the order by is now going to be using the F value of the field time and in ascending order. This again is very similar to like what we were doing with the filter. So when I reverse the order, this is so I can get that window. Then when I actually cut the query set down to this count with that reverse time, that's to grab the original window. When I reversed the list, that was to make sure that it is in the actual order that it actually happened. So the original order, the time order itself. So we're basically doing the same thing here. We are making sure that it is in that order. There's a chance that it might not be, depending on how your query set's set up or how your model is set up. This will make sure that it orders it in a sequential order, as in the oldest ones are way in the back and the newest ones are way at the bottom. Or the oldest ones are way at the top, the newest ones are way at the bottom. So that we then grab the frame based off of that order, which is, I think, hopefully very important and understood at this point. Hopefully it's not too confusing here. I mean, I understand that it might be confusing if you've never done something like this, which is exactly why I needed to go through this process here. So hopefully you understand how this is working, because that's what's going on in this window right here, but it's happening on the database side. Now, as soon as I do this, I can actually come in. Oops, we need a comma. This partition here, I'll explain that in just a second. But we come in here and I can now grab the max value. This is for everything. So it just annotated every single thing in here. So if I were to go to obj in that value and just print out ma, or rather, let's go ahead and do obj dot, we'll grab the ID and then obj dot the ma value, which we put here, and then we can do obj.close price. And I'm going to go ahead and just do maybe the first, 5 or so in there. And we'll go ahead and take a look, and there's our first 5. So again, this is the very first item inside of this filtered value, based off of how that filter is ordered as well. So the window itself is going to go off of that. Notice that the very first one is, what do you know? It is quite literally the exact value. This is what we already have seen. It's this up here. So, but it's now doing it on this entire query set instead of the small amount of it that we did. But the important part here is it's actually not giving us the most recent one. That's what we really want. We want the most recent of this rolling window. So the way we can do that is by grabbing out the last items. So now this is still just a query set. If I were to just go ahead and do order by and something like the negative time, I am now reversing that so that the newest ones are first and the oldest ones are last. So if I were to run this again, it now has flipped everything. Notice that we see the ID of 361 and the ID of 361. And so now it's actually giving us that same average that's coming through in here. And I actually have it reversed from what we did up there. So let's go ahead and reorder it so that the moving average at least looks a little bit like the one above it. So what we've got here is we've got our original items here. That's the price and the ID. And then we've got our actual calculated one on the database level. And what do you know? It's identical to the one I just calculated up there manually. Now, why is this so important, or why is this so useful? Well, this is because what I can do then is I can change this out a little bit. I want to change the frame itself. And the way I'm going to change the frame itself is by coming down here. And now I'm going to go ahead and say MA5. And then we're going to go ahead and grab that same window. And then we'll go ahead and paste it right underneath. And we'll go ahead and do something like MA20. This time what I'm going to do is, instead of having some variable here, I'm just going to go ahead and declare 5 in here minus 1, which of course is just simply 4. And then down here, the frame is going to be 20 minus 1, which is 19. We want to take the negative version because of indexing. And then I can go ahead and grab the first item in here. And now I'm going to go ahead and say, vowels, moving average vowels in here. And then now we can just go ahead and print out each one of those things. So we'll go moving average vowels.id, and then .close price, then .ma underscore 5, which is this value right here. Then we're going to go ahead and do MA and 20. So we can see all of those things coming through, and it's just incredibly fast. So now we see the moving average over the last 5 ranges, which in this case, it's quite literally the last, however many minutes or whatever our interval was when we actually calculated all of these things. Which of course, if we go back into our tasks here for getting all of this data, we have a way to grab a certain amount of data itself. But of course, then we want to go into our stock quotes and see what our range was. In this case, we're using the default for Polygon. That range in here is based off of this multiplier, so 5 minutes. So what we have here, this moving average range is like the last 25 minutes. This is the last 100 minutes because 20 times 5, 100. So this is not quite the daily moving averages like the last 5 days, but rather the last 5 iterations that we've stored in our database. So in other words, what we can do is we can always print things out up here just to see what those data look like by saying obj.time, right? So we can actually see what that time is. And there we see the minutes counting down as they were designed, right? So the most recent one is right here, and then it's counting down by 5-minute intervals. So that's not the moving average we may want. We may want the last 5 days, which is going to be very similar to this, but slightly different. So again, the important part is the expression here grabs the average price of a field that's on our model. So being able to go into that field, we can actually take a look here. In here, we've got all of these different models, all of these different fields here, right? So we can use each one of them. All of them can be calculated because they're all decimal fields. You can also do a big integer field, of course, but the idea is you actually grab a field that can be calculated. The ordering is very important that it actually grabs this order so that we can get the tail end of it. So that means that the oldest one is at the very top. If we want the tail end, we use that row range here to grab, backwards, basically 4, which it actually starts from the index value. So it's actually 5 values total, including the current one. So yeah, it's pretty cool. So this idea of moving averages and windows and all of these annotation functions is something we're going to continue to use so that we can grab all of the different indicators we might need, or at least some of the fundamental ones, so that we can have logic to make a decision whether or not we want to purchase, but also so we can feed all of these values in to an actual AI. So an AI can make the decision for us based off of all of these different values. Now we're going to take a look at how we can do daily moving averages. That is basically changing our queries a little bit so that it for sure is using a daily moving average regardless of what our API interval ends up being. Now what we just did is exactly what you need to do to create moving averages for a certain frame or a window frame. So that window frame still counts, right? So we've got this count in here, and that count was used in this window for this frame right here. And then of course we expanded on that to have 20, but this frame itself is based off of the number of items in any given row. So in our case, what we did was we actually called and stored data into this time field here. This data is going to be variable depending on what API service you ended up using. Now, we definitely make it a timestamp, but the point here is, depending on what you used, you might have a multiplier of every 5 minutes. You also might have one that is 1 day. If you have one that is 1 day, the previous section would have been a daily moving average. But in our case, we have one every 5 minutes, which really meant that we are doing a moving average. In this case, this is 5-minute intervals of 5, right? So that's the 5-minute intervals. This is the 25-minute intervals. So not quite every day, but again, that also depends on how you stored the data. What we're going to do now will almost certainly work depending on the fact that if you have actual daily data. If you don't have daily data, it's not quite going to work the way you might want. But if you have at least a daily data and more granular from there, what we're going to do now will almost certainly work, and it's barely different than what we've already done. So the way this actually works out is we want to bring in a couple new functions in our imports. The first one is going to be a max function, very similar to average. And then we're going to go ahead and also do another one called truncate date or trunk date. So from Django.db.models, we're going to import trunk date here. Okay, so let's go ahead and make sure we run everything here. And let's go ahead and do .models.functions rather. And there we go. And so everything else we can just run, and all of this should work just fine. So all I really want to do is update this query set right here. I want it to be filtered down a little bit more than it currently is. So what I'm going to do then is I'm going to go right above it, and we're now going to go ahead and do latest daily timestamps. And we're going to put a parentheses in here. And now what I want to do is the similar query set right here, just like that. And the goal of this query set is to get the final time of the day. So basically taking any given date and getting the final entry that's in there. In other words, the actual final model that's been stored, whatever time value is for any given day, that final one that's actually available. Of course, we could always say midnight or something like that, but that would just be a guess, a shot in the dark. We actually want the final one in here, and that's exactly what this query set's going to help us do. So the first thing that I want to do is put .annotate, and we're going to go ahead and bring in the date equaling to the trunc date of that time field, and that's it. So once we actually run that, we should be able to see potentially some of those data items. So it's still annotated, so let's go ahead and just bring one level next and say something like values and company and date. And if I run this, I can now see that the company shows up, which of course is going to be the same company as the ticker, but then it also shows me a bunch of dates. And it's showing me a bunch of versions of that same date, right? And that's because we haven't got to the max time just yet. So the next thing that I want to do is annotate that maximum time. So if I go into annotate and then you go ahead and do the latest time, we're going to set this equal to max of the time itself. And then we're going to go ahead and close off that parentheses and then go ahead and grab the values again using the same company and date stuff, but then also using the latest time as well. So we bring this in here and then we just pass in latest time. Now this is grouped by values. So if I run this again, I'm now seeing that there's going to be a date in here and a latest time. And the date is not redundant. It's not happening multiple times because we did this group by time, which we could verify in just a moment as well. But then the next part of this is going to be something like, we could probably do values list in here of the latest time and say flat being true as well. If I were to run that, I should now only have a few of these times. So what we could be able to see, since it says query set in here, I should be able to do .count on this. And I run that and I see that there is quite a bit of dates in here. So if I do, let's go ahead and get rid of this latest time here now and just do count again. Now I've got a lot less. So we're going to leave it at these values here. And what I just want to do is I'm going to go ahead and say my actual timestamps are equal to the X and that value, and then 4X in there, just like that. Get rid of that count. Actually, since it's a query set, I probably don't need to use the dictionary value. I probably need to use dot notation. Let's actually take a look. Either way probably works. And there we go. So these are all of the actual timestamps of the final of the day itself. They're not actually in order right here. It actually doesn't matter that much if they are in order or not because of what we still will do, which is going to the next one, and that is filtering down our final filter, our actual filter. What's important to note here is these should all be unique. Let's actually just go ahead and order it. We'll just do order by, and we'll go ahead and say the date itself. Now, if I order it, I should see a unique one per, actual entry. The other thing is it actually is skipping over the weekend, or really just dates that just aren't in the database at all. They're still based off of the same time range. We could also get rid of that time range, and it would still give me all of those values. Or I could expand the time range quite a bit by just adding in a time delta. So if I did start date plus time delta and like days of, 50, and I actually think it would be minus days of 50, then I can actually even go back even further in terms of the actual timestamps that have final data and that are at the very end of the day. So it's really up to you on how you actually go about that part, because the next part is really what we want to use, and that is using these timestamps. So now what we're going to do is we're going to say something along the lines of time in those timestamps, the list of those timestamps. So time 2 underscores in equaling to that list. Now our query set is based off of days because we only have one timestamp per day. And so now all of the other things, all of the other frames are going to work based off of the actual day, as we can see in here when we print out that time. So now our actual previous annotation of those moving averages should absolutely work. Now, the thing about this is the information still might be slightly incorrect, But taking the closing time of that final day, I think is plenty enough for the average itself. The average that gets more granular is probably the one we just talked about. But also, if you were to look at any sort of stock market third-party service that has moving average listed there, you can actually go off of what they have there and compare it to your own numbers. So the 5-day period that we see here is 225.60. If we look at ours by scrolling back up or scrolling right here, we've got our 5-day moving average is this one right here, which is 225.446. Very, very close. It's definitely off, but it's not off by like several numbers. It's off by only a few. And then we've got 228.72 here. And then we look at ours, it says 228.019. So again, this has to do with the fact that maybe they are doing the more granular moving average and getting a more accurate representation. And maybe they're not even doing a 5-minute window. Maybe they're doing a 5-second window, which would take more computation power. But we now have the groundwork of how to do either one. Now, the reason we have these actual timestamp or day of timestamps is only because of how granular our data actually is. More than likely, these actual timestamps you can probably use on all stocks. It probably doesn't even need to be on this ticker itself, because realistically, even if your single stock ticker doesn't have those actual timestamps, that's okay, because this query set right here is going to look for that ticker and look to see if it's in those timestamps, in which case this one might have it, it might not. So if any stock company doesn't have something in the past, then you might run into issues there. And so that's pretty cool. That's pretty nice that we're able to do that. We're able to get that sort of granular look at these things and just make sure that it's all working. So going back in here, let's just go ahead and make sure we've got all of that up and working. Looks like I actually did need to filter it down. Otherwise, I got duplicate values in here. So maybe it's a good thing that we filter it down based off the ticker, so we would actually bring these things together. So it is a little bit more accurate to that specific company, because other companies might work a little bit differently, or we just run the risk of getting duplicate values, which of course we don't actually want to have. So this is probably a little bit better in terms of how we actually display this for our actual data. Now we're going to take a look at a couple functions for volume trend and price target. Now, of course, we are building off of what we just did, but I also implemented the Django timescale queries so they are more efficient and effective at grabbing our data. So the idea here is our latest daily timestamps. We are now using stockquote.timescale instead of .objects, and then we just bring in the time bucket itself. This is going to be more efficient than it was before. Now, one of the things that is important is we do want to get these timestamps based off of the ticker. That is absolutely important, because it will make sure that we are using actual timestamps that we have as the latest ones for any given ticker. If we don't do that, then we might get other data that just shouldn't be in the query set itself. So now that we've got this in here, we've got 51 total things. Notice that I did list and set. Using set means that it will be unique data inside of that list itself. Next up, we actually do our query set. This is obviously based off of those daily timestamps. If you want more granular data, you're not necessarily going to do this. Instead, you'll just stick to the exact range. It's going to be really easy to switch in and out of these things, as we'll see in just a moment. Now, the idea here is we get this volume trend. We've got our window here. We're just doing a 5-day trend here. This is an actual 5 days. This should probably say more like an interval instead of days, because if you were to take off the day timestamps, then it would just be an interval and it'd be a little bit different. But since we have those day timestamps, we can use this one. But the idea, of course, is using that same frame. It's grabbing the object from that data. Notice that we're getting average volume over that time frame, whatever that query set ends up being, which is this one. It's going to be the whole thing. It's going to get that average volume. That is a trading volume itself. It orders it by the time, as we've seen before. In the terms of the volume, this probably doesn't matter nearly as much as something else, but in this case, we just wanted to make sure that it was doing the oldest to the newest. Then we actually use the no partition. Now, the partition itself would be if you wanted to have multiple companies in this. So you would partition it by company, for example, or other data you might want to chunk together. Now, this also might work in terms of date itself, like the annotated date. But even that might cause some issues and stuff like that. So for that reason, we don't use any partitions. We just basically partition the data by filtering it down first, and then we can do this later. Now, there are probably ways to optimize this. If you know those, please let us know in the comments, but this is a fairly straightforward thing that we already have seen. Now, the reason I do dot first is really just to grab that data. We don't need all of it. We just need the most recent one, which is also why we reorder it as well. Now, if you did keep the order as time, you would just change this to last. Not that big of a deal. Either way, both work. If there is no data, it's going to go ahead and return that back. So if there is nothing in here, that's a good sign that maybe we need to update our data set altogether. Next, we just take a look at the change itself. So the most recent data of the volume, whatever that might end up being, if it's 1,000 things that are being traded, then it's going to have 1,000 in there. Then we subtract that rolling average, the average over that time range or that window. Then we get the actual percent change by dividing it and then multiplying it as well, which gives us those values. And we can see those values right here. This is the average volume over the last 30 days for Apple based off of our time stamps and our time frame, and also the end of the day. So this actually might be missing some of the volume from the entire day. So perhaps that average volume is a little bit different than that. I would suspect that it probably is different. And of course, I think this is in thousands, not ones. So I think the volume's in thousands, which you'd have to check in Polygon. The point is that it's going off of the data that's actually stored on this one right here. So 488,000 trading or 300,000, that makes a lot of sense to me versus 304. Anyway, so we've got our actual percent change over that time period. So it's not trading as much or as frequently in recent days. Next up is our price target. This one's also very similar, but this time we actually bring in the ticker itself, and this is also going off of the time buckets altogether. And so we see what the actual values are. This, again, is one of those things where we're not using the actual time frame, the actual date time stamps themselves. This is more of just the average over the last few items, which is probably not going to give us a very accurate representation of this. So what you might want to do then is you might want to do our timestamps in here as like an empty list like that, and then basically say, our lookups then will be like this. We'll go ahead and say lookups equals to a dictionary value in here. We'll use the company ticker, and that will be our ticker. Right? And then our range, we'll go ahead and cut this one out and paste it up here, put some quotes around it, and turn it into something more like that. Okay, and then our final one would be basically if the length of the timestamps is greater than 0, then our lookups will be our time and then in those timestamps. Okay, and then we update our filter here to unpack all of those lookups, and there we will be able to now bring in those timestamps to get that simple target. So you could do that same thing or that same idea with this volume trend. Now, the reason I don't actually pass the query set in this one has to do with the fact of how I'm annotating everything. I don't need to pass in another query set that's annotated differently or used a little bit differently than this. And this is also based off of an aggregate as well with those same sort of filters that we had before and the number of days that we might want to use. So in the case of the timestamps themselves, they're probably optional because of the end date and how we're actually calculating all of these things and then aggregating them, right? So we probably don't still need that timestamp. It's a little bit different than what we've been doing up until this point. In fact, the volume window might change as well. You might want to consider that one. But the reason we have the volume window has to do with that frame range, and it's going to be closer to those moving averages, where the price itself, we can just take the max, the average, the highest, the minimum, and we can get all of that data. Then we basically just do some minor calculations in there, and then we are able to get that. I wouldn't be surprised if we take these timestamps, if the data is just slightly different, as in not as accurate. So if we bring it in, we should probably get similar data, just not the same. So let's go ahead and run that. We've got our conservative target is 244. If I bring this back in, we see that. Let's go ahead and actually put them next to each other by running two cells here. And there we go. So yeah, the actual timestamps don't give us nearly the granular data that we might want in it. So that's an important part about this, and perhaps even our trend volume itself also would be a little bit different in terms of how it comes out in terms of the data. Looks like it's actually quite a bit different because we're not now filtering this down even more than we maybe don't need to based off of volume and all that. When the moving averages are in there, that one's actually really important because of how those moving averages end up working in terms of the actual granular data itself. But in this case, we probably still need to keep it for the volume trend because of the days, the fact that we are using days as our metric. And so that volume trend is over days instead of that same interval. Whereas this simple price target itself is not going based off of those frames at all. It's just grabbing some of the latest data and then doing some aggregations for it, which calculates the data in here just like that. So we probably don't ever need those timestamps, but it's nice to know that there's an easy way to bring them in if we wanted to. Now we're going to take a look at the relative strength indicator. This is really saying whether or not the stock has been oversold or undersold to make a decision based off of that. Now, this is calculating based off of the volume of sales. So we're going to take a look at a notebook that I created along with an LLM on how to generate this relative strength indicator. But realistically, you would probably use an API service like Polygon or like Alpha Vantage to get this indicator. Now, a lot of these API services have a lot of other technical indicators you might consider using for any given stock based off of any given interval. So keep that in mind when it comes to actually trying to implement this on your own. What we're about to do is really just a look at how you might accomplish it inside of using Django's built-in features with Postgres and Timescale. So first and foremost, we're not going to go step by step on this one. Go ahead and jump into the GitHub repo. If you go to just cfe.sh/GitHub and navigate into the stock trading bot, you'll go into the notebooks here and you can go ahead and grab the final two notebooks, analyze stocks with the relative strength index, and then stock services. If you're going to do stock services now with me, there's one more thing you're going to need to grab, and that is inside of the SRC, inside of market, services.py. This basically puts everything together as Django-based generated functions. Realistically, what I'm trying to do here is to make it so we don't have to rely on API services for everything, while also learning how to calculate a number of things inside of Django itself, which of course was the reason we went down this technical analysis in the first place. So the first thing is the relative stock index. If I open up this Jupyter notebook in here and run everything, what I'll end up getting is this kind of data. Now, I already know that this data is not fully accurate because if you were to go to maybe a live version, you can see that the RSI for it on this website in particular, moneycontrol.com, which may or may not be accurate. It's hard to know for sure, but we see that the RSI in here is a little bit different than the one that we have. Now, is this going to make a major difference in your decisions? It could. It really depends on how long you're considering this RSI and how much weight you're putting to it. And that would be true with the other analyses that we have done as well. But the point here is you can actually go through and see all of the complexity that would be needed with doing this in our database itself. First, what we do here is we annotate the closing price itself. This, of course, is not fully necessary because we do have a closing price. But then something that's really cool is we've got a previous close. Django has a way to work with a Postgres database to get the previous value based off of these arguments here. So it's going to lag one value, which is super cool. And it'll do that across the entire data set. And that's exactly what's going on here is it lags one value there. And then it orders by a time bucket, which of course is this right here, right? And so what we've got then is that time bucket is still based off of the date. So we could probably still use just time here as well. It's kind of up to you on how you go about doing that. But this is meant to be a more efficient request into Timescale itself for that actual time, argument itself. Next up, what we've got is a way to generate a new value, right? So this is a delta that's happening, again, on the query. When we actually run this, it's happening on the database side. It's going to calculate the difference between the close price and the previous close price. That previous close price is the lagging price. It's the one from the row before this one, basically. In some cases, it won't actually have any value. If you go, old enough back or far enough back, it won't have any value. But that's actually pretty nice. Next, what we see is a gain. We can actually see a conditional value and set a new value based off of that condition. So price change here is based off of this right here. If it's greater than 0, then we're going to go ahead and do this expression, which is just getting the price change itself, the value of it, as a decimal field. Then we get the default value if it's not. So basically, if it does not meet this condition, here's that default value that it ended up being, which is 0. And then, of course, that's going to be the gain. And then on the other side, it's a loss. It's basically the same idea, but now it's the negative version of that price change, kind of inversing the gain and loss. Makes a lot of sense. So next up, what we've got, when I say negative version, I don't mean that the actual number is going to be negative. I meant that it'll be the inverse of whatever this is, which will likely make this a positive number, but it's still a loss. So it's still considered a negative number. It's just not returning in that way. And of course, if it's not less than that, then the default's going to be 0. So basically, either one of these are going to always be positive numbers, but the actual field itself is going to indicate whether it's a negative or a positive. That's the point. Next up, what we've got here is the average. We've got an average going on. This does a lot of things related to what we've just looked at, the gain or loss. It's going to go ahead and make sure that those are executed and then creating the average gain and the average loss. This is a very complex function that I don't know how often you're going to end up doing some of these things. You might, but you also might not. And so the next thing is just grabbing out other data that's coming in here based off of the period. Again, what we see in here. And this is an aggregate, so it's actually going to calculate these things. It's not just an annotation. Now recall back, annotations themselves actually have values put on the query set, whereas an aggregation aggregates all of them up and gives you the final value. It turns it into a dictionary. It's not a data set or query set anymore. Next up, we've got some of this values being calculated, and then we can see what's happening with them, and they're finally calculated, and these are the data points that come out. Now, there's a lot of things that can go wrong with this. Now, these calculations could be incorrect. Like I said, I did this with an LLM, so it's a really good chance that they are incorrect. All I wanted to show you here was what you'd be working towards if you were to do this all on your own without using a third-party API. And also, this is also a really cool and practical use case for more complex queries that you might need to do in Django, in the Django ORM. Now, some of you might be like wanting to lean more towards just doing pure SQL, which if you know it really well, then yeah, of course, go ahead and do that. Django can run pure SQL within Python itself. It's just a SQL statement that you have to write out, and you can just run it, which is really nice. And you can still calculate a lot of these same things and get this same sort of output. So the reason this is in a notebook is just so you can play around with it and you can mess around with the different ways that this is created and all that, but also that there is a function already on here. This function I took out of this particular notebook, and then I turned it into services.py on the market app. Now in here, I did all of the imports. I also am importing the stock quote model itself. I have a dedicated function for grabbing the query set based off of a number of aspects to this. And of course, if you need a time bucket, you can do that. And then of course, if you go into each function itself, these are basically results of what we did in the other notebooks themselves. And each one of these things will give you values that we already worked through, with the exception of the RSI, which is what we just did. So that's the point of both of those things. And then once we actually have the stocks notebooks going, we can run all of these values and get them. These values are what we're going to feed into an LLM pretty soon. But in the short term, I'm actually going to go ahead and do a manual way of grabbing these values and making a decision based off of this, more of like a programmatic way. Then we're going to use that programmatic way in conjunction with an LLM to make a decision on whether or not we should buy any particular stock. And that's really what we're going off of here. Now, like I said, the important part here is to see how it's done, technically speaking, how you might be able to calculate this. But it's also important to understand that these third-party API services, they have teams of people to make sure that this is working well. right, and working incredibly well. Now, when you look at Alpha Vantage, you can see there's a lot more technical indicators in here than what I found on Polygon. So if you want to add a lot of technical indicators, yeah, consider checking these things out. Now it's time for one half of the bot part of the stock trading bot. Now that we're able to collect all the data, we're able to do a little bit of analysis on that data, or like at least generate some of the analysis. Now we're going to do a logic-based recommendation. We're taking all of those indicators we created and then making a recommendation based off of that. Now I will say, of course, I'm not a financial advisor, so this is not financial advice legally speaking, but the idea here is we can still take a lot of this logic and the things that we've learned to kind of play out scenarios that you might actually want to buy or sell any given stocks. Now, the other half of this would be to use an API service to actually purchase those stocks. That's outside the scope of this series, but the idea here is taking a look at the logic that I created here to actually generate some sort of buy, sell, or hold recommendation. Now, first and foremost, what we've got is our averages here. If we were to look at our averages, again, we see that we have our moving averages of 5 days and our moving averages of 20 days. So if it's lower than the 20-day average, then perhaps that's not what we want. Perhaps that's a negative signal then. In this case, it is lower. So in the last 5 days, it's been less than the last 20 days. So maybe it's on a downward trajectory with that. So maybe we do want to consider that a signal to, well, we don't want that. We want it to be on the other way. We want it to be going up, not going down. So that means that maybe we're like reaching towards the bottom, or we're going towards the bottom. This might also mean that there's other signals or other moving averages we might want to add into the mix. You know, maybe we have 30 moving averages in here based off of whatever we come up with. This is something that you'll want to play around with, or could play around with on your own, now that you understand how to build those things out. And of course, you could also use the third-party API services for those same things, or for a lot of this stuff. But that's the point of those averages. Next, of course, is looking at the price target itself. Now, once again, the current price being lower than the target might be a good indicator. So if the current price is lower than the target, I would say, oh yeah, maybe we should buy that because the target is to go up. Or if the target's to go down, that means we haven't hit the bottom yet either. So I'm going to give that a positive one in this case. The current price is lower than the conservative target or the aggressive target. It's also lower than the average price as well. This might be really good. Next up, we can take a look at the volume trend. In this case, I want to do the percent change. So if it has changed over 20%, perhaps that's a really good indicator. Maybe it's higher than normal volume. Maybe there's a lot of trades going on that we want to get in on in terms of the action. Or if it's lower than 20, maybe that's not a good sign. Maybe it's slowed down for a good reason. And so we come in here and then we create that signal. Finally, the RSI data. So if we take a look at that, we can just see that the RSI, there are a lot of different indicators as to what is a good RSI and what's not. Again, not a financial advisor. This is just going based off of some of the research I looked up. The idea here is if the RSI is greater than 70, it's probably overbought, which is a negative indicator. If it's lower than 30, it's oversold, which is a positive indicator. At least, like I said, what I looked up. Next up, what we've got is we are going to go ahead and summarize all of those signals. In this case, I get a -1, which based off of my logic is a hold. You might change your score based off of your tolerance. Maybe you change it to something like that. Or maybe you change it if it's less than or equal to 0, then you sell it, right? And it's going to be completely up to you on how you end up doing this. Now, whatever your score ends up being, it has to be based off of the number that you have here. So 1, 2, 3, 4 indicators in here. So this score right here will never go above 5. So that's not even possible. So 3 is probably a good one on whether or not we want to buy. So if it hits 3 or 4, great, we're going to buy it. If it's less than, 0, or what I had before, which was -2, that might be a good recommendation. But there's the programming logic that comes into it. So at this point, you could then add in other indicators. So maybe it's other technical indicators, maybe it's other market indicators as well. And then you can just decide, the inflation is going up. So I'm actually going to consider it as a not buy or some logic along those lines as well. And this is how you'd be able to build all of that out. So taking this same sort of concept, what I want to do is I want to feed a lot of this data in to a LLM and see what that logic would come in. So then maybe we combine this logic-based recommendation with what the LLM might say. So let's take a look at how we go about doing that. Now we're going to take a look at how to do an LLM-based recommendation. The idea here is to take all of the stock data we've collected, as well as all of the stock market indicators we've generated, and then we're going to go ahead and feed that into an LLM. So jumping into a notebook here, we now have this function called get stock indicators. This is taking everything we did in the last part and turning it into a simple function that just brings those all together. And we can see the results just like that. So these are the results we're going to go ahead and feed into an LLM. In our case, the LLM we're going to use is OpenAI, and we're going to go ahead and go through with the chat completions in here. So the point of this is to make it really simple to get a buy, sell, hold Boolean value from the LLM itself. Now, the way we can do this is by using these structured outputs and more specifically the JSON schema that it has for us. So we can actually pass in stuff like Pydantic and get a schema that way, or we can just give some more manual version, which is exactly what we're going to end up doing. So at this time, go ahead and go into OpenAI, grab their AI API login, and then go into the dashboard and then create an API key. Notice I already have one. Go ahead and bring your API key into the .env, paste it in there as the OpenAI API key. Then in your requirements.txt, go ahead and install OpenAI in there and add those to your requirements. Once you do that, go ahead and restart your Jupyter Notebook so you can run through with all of this and you can get your OpenAI key loading like I did right there. Okay, and so notice that I have the results as a dictionary. I also have them as a JSON string. Either one should work just fine. Putting it in as a JSON string might be a little bit preferred when it comes to sending the data into OpenAI, but I think either one should work just fine because even as a dictionary, it's going to be turned into a string down here. So in that case, I actually want to turn it into a JSON string. So with this in mind, I have my OpenAI key, and then I also have the OpenAI client being generated by passing in that API key. Of course, you can also put this in as an environment variable where it's loaded directly from the client. I always like doing it this method so I can use Python decouple to make sure all three of these cells are working correctly. So next up, the model we're going to use is GPT-4o Mini. And the reason I'm using that model right now is one, I have access to it. Two, it's actually the least expensive one that you can get right now and has a really good performance for that price. We also might try GPT-4o, but using Mini is going to be a good idea because if you have a lot of stocks and you end up running this same sort of prediction every hour or something like that, or every day, you're going to want to make it on the lower side of how much it ends up costing. So with this in mind, here's my two messages. First off is giving the prompt that it's an expert at analyzing stocks and it returns it in JSON data. Then we just pass in our actual results in here and ask for a recommendation. The response format is up to us. In this case, I did it manually. Like you saw in the actual documentation, you could use something like Pydantic in here if you want to. So Pydantic is great because you can build out stuff like this and it will respond in that actual result, and you can even parse it out like that as well. It's super cool that they're pushing this in terms of a structured format, but in our case, we're just going to use it where we manually write out everything in here for our format. So we've got buy, sell, and hold, the three values we want to know about from the AI given these results, and give it some sort of description, and of course the data type of Boolean. Those are the important ones. If you look back into the actual documentation, the JSON schema, it should actually be in here somewhere where you actually give the different supported schemas in here. There we go. So these are all of the values that you can use in place of the type that I have. So I've got Booleans because that makes sense. I want a true or false on either one of these parameters or these properties. Then I also want an explanation, which is what we've got right here. And that's it. That's all I really want. So now I'm going to go ahead and run this prediction given these results. And then I'm going to go ahead and load them in because I can load them based off of JSON. Since it is JSON data, I should be able to do this result right here. If I were to not use the JSON format at all, then you might not be able to load them in. The reason we want to load them in is because then I can do something like result.get and hold, and I get a true value. And we can say something like is true, and yes, we still get true. That's really the only reason that we are using JSON, is so that then we can automate this process. So one of the things that's pretty interesting is I am getting a result here to hold it. It did not say buy or sell. Let's go ahead and actually change the model itself and see what result I get now. Now it's saying to sell it based off of whatever reasoning. So the actual LLM itself, the results are going to vary, and of course they're going to vary based off of the things we're feeding into it. One of the ways we can improve the performance here would be to maybe add in, instead of MA_5, we write in moving average _5, and then we can say that like our risk tolerance, or we can add other criteria we want in here. We could say based on the moving average by, yes or no, and it can take in all of that stuff as a result and then give us a different example right here. But realistically, what I would do is I would take this data here, I would create a brand new model for this data, I would store it in that brand new model at any given time. So basically taking this data, whenever it's generated, store it. Then have another model that's based off of this stored data, and it be based off of the response from any given LLM. Right here, of course, this is going to be the actual OpenAI one, but there's a lot of different LLMs out there that might perform just as well, if not better. But either way, you could store multiple LLMs as a different data source and basically getting these three values back, the main ones of these three, and then its reasoning would be nice as well. But then you can start to compare these over time to see how well they're actually performing given the data and how that data might change as well. That's definitely outside the scope of this one, but what we got here now is an LLM-based recommendation. Thanks so much for watching. Hopefully you got a lot out of this one. I wanted to leave you with a few challenges as to where you can take this project next and really bring it to the next level, including your skills. Number one would be to actually store all of those recommendations, whether it's the logical recommendations based off of the conditions that we built out, or it's the LLM ones, or a combination of both. Once you start storing these in your database, you will be able to analyze how they perform over time to see if there's things that you need to tweak to improve those recommendations. This also could be done through AI and machine learning. You could actually figure out ways to improve those recommendations. So having a historical record is a good idea, even just for analysis. Speaking of analysis, you could go to the next level of that, which would be providing visualizations. Visualizations like charts and graphs are great because you can just at a glance look to see how things are performing. Sometimes the visualization can really lead you to something that's wrong in your system. So like if it's constantly recommending a specific stock and it actually shouldn't be recommending it, it should be telling you to sell it. Those things start to get fairly obvious when you can chart them versus just staring at numbers all day long. Now, the way you might do that is with Matplotlib and Jupyter. These are both Python tools, of course, that can help you visualize this data. Once you want to go to the next level and you want to share those visualizations, you might look at more JavaScript libraries that can integrate with Django, whether that's like Chart.js or even React.js with a few of the different charts that are on there as well. Or you could even use something like Python Reflex. Reflex can integrate with Django through an API, just like JavaScript can, and then you can visualize things with purely just Python itself. All of the visualizations are meant to help you make better decisions based off of what's going on, or catch ones that are flawed in our automated system. From there, we want to build out some sort of agent that will actually have the ability to trade stocks on our behalf. Now, when I say agent, I mean something that can take all of this data, then actually make a purchase or a sell of these stocks through actual API services that do that. Now, that's definitely outside the scope of what I recommend doing for beginners or people who aren't quite ready to throw away money at this, because it may or may not work. But the big benefit of using some sort of agent, maybe it's with LangChain or some other tool, is you could actually prompt you as the person on whether or not you want to take the next action, which would be buy or sell any given stock. that also might be really, really interesting to see. So if you want to see me make an automated agent that does actually buy and sell and trade stocks, please let me know in the description below, because of course that might be something I'll cover in the future. So thanks again for watching, and thanks to Timescale for sponsoring this series. I think doing stocks like this is really, really compelling, and luckily their tool makes it so much easier. Using a time series database and Postgres and Django is just so great. As you see, it just fit in so naturally. So thanks again to them for sponsoring this one, and I look forward to seeing you next time. My name is Justin Mitchell. Thanks again. Take care.